Hello everyone, welcome to AWS Big Data Full Course by Intellipaat. In recent times, many companies are going through heavy layoffs. According to a report from Business Today, IT companies in India laid off 226,000 employees in 2023. Even if that is true, one industry actually boomed across India and the world. I'm talking about the cloud computing industry. As of today, almost 94% of companies are using cloud computing. And it is not just about virtualization of infrastructure. Cloud lets you do functionalities such as data analytics, big data management and analytics, machine learning, network engineering, and much more. Today we are going to cover all you need to know about big data services AWS offers. But first, let's try to comprehend why companies need big data services. According to Statista, there were 15 million data breaches last year, and there is no sign that they'll stop happening anytime soon. That's where proper data management services are required, and AWS Big Data solves that problem. It not only provides a management mechanism but also offers tools to make sense of that huge volume of data. With rising cloud adoption and AWS being the biggest market player, job opportunities around AWS Big Data are quite substantial. Not only that, according to Glassdoor, a beginner AWS Big Data professional in India can earn between 9 lakh rupees to 30 lakh rupees, whereas in the USA, the annual salary ranges between 120,000 US dollars to 250,000 US dollars. Do you want to start your journey into the AWS Big Data? Then this video on AWS Big Data Training is for you. This AWS Big Data tutorial for beginners covers all the important skill sets required to get you a job. This video has been designed by top industry experts from around the world, which includes multiple real-time projects and important interview questions. But before we dive into its technicalities, I request you guys to hit the subscribe button and click on the bell icon to never miss out on any update coming from Intellipaat's YouTube channel. First of all, let me take you guys through the agenda for this session. We'll begin this session with introduction to big data and data collection. After that, we'll get ourselves introduced to cloud computing and AWS. Once done with that, we'll look into elastic compute and storage volumes, virtual private cloud, Amazon S3, databases and in-memory data stores, etc. After that, we'll iterate through data storage, data processing, data analysis on AWS platform. Finally, we'll iterate through data visualization and data security. I hope I have made myself clear with the agenda. So let's dive into the session directly.
This is the scenario that we have an application and its data is present in a bucket which is present in US East 1 region. And that works pretty well to send and receive data. Our users are going to add items to the bucket and read items from this bucket. And as long as our users are fairly close to this US East 1 region, all these users that you're seeing here, they are pretty fairly close to this bucket which is present in US East 1 region. So that they are going to have no issues at all whatsoever. Now, once we get out to the further geographic locations, we are going to start seeing some latency. So for all these users, for an example, as you can see here, for if this user tries to get something from this bucket, he is going to experience some sort of latency. Obviously, the reason is you have all this fiber optics cable, they are underground, under ocean, and once your internet crosses over those fiber optic cable, obviously, because of this length and all these issues, you will experience some sort of latency. Now, so in that case, this particular user might complain about how long it takes to get things from our S3 data store. And if our application user base keeps on growing, we are going to run into issues as we have users all over the world. As you can see, now this application is quite big and you have users present all over the world now. So how do we deal with this situation? Well, the first thing we'll likely implement in this case is called something as CloudFront. And what is CloudFront? It is going to allow us to get data to our users more quickly with the network of caching nodes. Now, this caching nodes, they have an optimized network path between them. So data goes from our bucket into this CloudFront and then to our users. So this is going to look something like this, that all this CloudFront have a optimized network path because you use internet via some optic cables which are owned by your internet companies or private subsidiaries. However, AWS has their own internet as well, and it is an optimized network path, which basically reduce this latency. And for that, what they use is called as CloudFront. So your data, it goes from your bucket, it resides in this bucket. From here, it will go into CloudFront. So this is CloudFront, the purple object that you're seeing here. If a user in this continent is asking for data, this data from here first goes to this CloudFront cached location. And if an object is not cached in CloudFront, it can still take a little while to get to our end user. But again, it is still going to use those optimized network path. So it is generally greatly increases the usability of your application for global users. So for an example, all these big sites like Amazon.com, which have presence all over the world, and they do not want to impact customer experience, they use this heavily. CloudFront is used heavily for global applications. So for an example, you use Netflix. Netflix uses CloudFront as well. Netflix is based and Netflix is hosted on AWS if you're not aware already. So they also use the CloudFront in order to reduce the latency for their global audience. Now, we still have an issue though. And what is that issue is that we need our users to be able to get data into our bucket. So we will we can still see that we have a problem as before. We have in this case solved the download side of the communication, that I am a person who has my data. Like for an example, I am Amazon.com. I have posted all of my data in a S3 bucket. Now people wants that data. So essentially what they are doing is they're downloading that data. And in that case, we have solved the problem of download by this CloudFront mechanism or CloudFront service. But still, if you have not already noticed, we still have a problem for uploads. Like for an example, they want to upload something. So for an example, you are again an employee of Amazon.com. You have a bucket present in US East 1A location. Now your employees from India or Australia, they want to upload something into that bucket as well. They are going to experience this latency as well, because we are increasing the geographic distance here as well. So your users across the oceans, they are going to likely have failed uploads, and they are definitely going to be unhappy. So this is where transfer acceleration comes in. Your transfer acceleration is enabled per bucket. Before that, let me see if you have any questions. I'll stop here. So yeah, this is how the CloudFront, the download side works, that you have your actual data in US East 1A. If a person who is in this continent wants the data, it will first go to this CloudFront cached location, and all of these users are going to get this data from this CloudFront location, which is an optimized network path. And that's the whole problem statement that CloudFront solves, which is the download side of the things. As you can see, it streamlines a lot of things. However, it still does not solve the upload sites. Whenever this users, as you can see here, whenever they are trying to upload something to this bucket, in that case, still they are going to face some sort of latency, or it might fail as well, because probably they are trying to upload a big file. In that case, it will not work. And all these users who are in, let's say, Australia, New Zealand, and this red signifies that all their uploads are failing because of huge geographic distance. This green says that it works perfectly fine. This yellow says it is being uploaded, but it takes time. With this transfer actually, oh sorry, CloudFront, we have solved the download side of the communication. Your uploads are still going to face the increased latency along with the increase of geographic distance. And in order to make sure that your users across geographic locations, they are not unhappy, we use transfer acceleration. So your transfer acceleration is enabled per bucket. It uses special endpoints. So if you are hard writing endpoints, it would look something like this. Your bucket name, for an example, my bucket name is Harsh Demo, Harsh itself. It would be called Harsh.s3 slash hyphen accelerate.amazonaws.com, or it could write accelerate.dualstack.amazonaws.com. So it uses its own special endpoints for your buckets so that you are sure that, okay, this particular bucket is using transfer acceleration. So this is how it looks like. We'll see in the demo as well in actual AWS account. But yeah, so far I just wanted to put it in slides as well. That's why it looks like this. Now, obviously, they are giving you a benefit or an additional service, which is pretty great and works for global users across. And obviously, they are charging something for it. So here, the price is 4 cents per gigabyte of data transferred from the United States to Europe and Japan as locations. And it is 8 cents per gigabyte for all other AWS Edge locations. So looking at a map here, as you can see in this map, we have a CloudFront edge locations. And what transfer acceleration does is it leverages those edge locations to allow us to send data back to the S3. So this becomes a content ingestion network and not just the content distribution network. So CloudFront, if you have not noticed, it is called provides a global content distribution network. In short, the acronym for this is CDN. So when somebody says I'm using CDN, they basically mean to say I'm using CloudFront. Both are same thing. And transfer acceleration, as I mentioned, it provides you CIN, which is content ingestion network. I hope that makes sense. So this basically means that our users are all using optimized network links to get our data or send data to us. And in this case, everyone is happy. So with that, we are going to head over to our AWS console after this, and we'll take a look at how do you actually upload some information to an S3 bucket. Tier account as well. As you can see, you can read more about AWS free tier, and you can get hands-on experience with AWS platform. So whatever I am doing, you are able to do free of cost in your own account if Intellipaat does not provide or your company does not provide. And the signing in remains pretty simple. How you sign up for anything like Instagram, Gmail, Facebook, similar sign up process. All you have to do is you have to provide your root user email address, which is whatever email address you want to log in with for the first time as a root user, and whatever name you want to provide. So for example, I call myself cloud user, or in my other account, personal account, I call myself Soul Harsh. So whatever, any name is fine here. You have to just verify that email address. After that, it will ask you for your credit card information. Just provide that. It's again just to verify you. They are not going to charge you unless you go beyond the free tier. And you can set up a lot of things like set up a budget, set up alarms, set up uh, limits that I don't want to spend more than $1. So of $1 over here, as I am creating a new account, I mean, I have intentionally deleted everything from this account so that I can show you from scratch. So ideally, it will take you to this page. Otherwise, it will take you to the page showing all of your buckets. So right now, I do not have bucket. So let me create one. I'll call my bucket data analytics specialty. So DAS. You can do a lot of things like you can turn on bucket versioning. You can modify it here, the file, whatever you have. And then there are some destination details that you can check. Uh, versioning as versioning, if you're aware, versioning, if you have used something like GitHub, you already know what versioning is. That let's say today this file is called hi, I came from the web console. Now I made some edit to it or made changes to it. I called it hi, I came from web console. Again, I just added one more word to it, but it's a new file. It contains new data. In that case, if you're going to upload that file, if you have versioning available, the first file with the this content is will be called v1. The next one will be called v2. But again, right now I'm not worried about versioning. Then what you can do is you can set some permissions as well. We can use an access control list. There are few predefined access control lists available as well for us to use, and we can actually write our own access control list as well for this particular upload, whatever we are doing. And then we can set the properties for this. And what exactly that means, you can set the storage class. We can decide if we want encryption turned on and which key you're going to use. We can add tags and we can add additional metadata. and let me show you how or where exactly all that looks. So let me go to my buckets again. So buckets, my bucket called DAS demo Hirsch, and it clearly has one file. So whenever you upload, you see all these things. You see this destination details, and in the destination details, you have bucket versioning, which is disabled by default. Now you have all this encryption tag that I've mentioned that you can enable the encryption for this particular bucket, and you can add tags as well, and that comes over here. Then this is the place where I mentioned that you can create permissions, like who can have access to this. And in this place, which is properties, you can set the storage class. We are going to talk about storage class just after this. Here you have encryption, which is again, uh, you can enable a encryption key, and using that, your data will be encrypted. You can have additional tags. So for an example, I can call this purpose, and my purpose is training. You can add something like project, like what this project, this particular upload belongs to, and let's say it's belong to DS project, which is a super secret name for a project. And then you have metadata. All of these things are optional. You just, if you want, you can just upload a file as well, like we did already. But if you want to add anything, you can add user defined, like this kind of key, what should be the value of it. You can have some system defines as well, like what is the content type, is it a text file, is it a JSON file, is it a CSV file. You can have cache control, content encoding, content language, whether it's in English, Japanese, whatever, when it is going to expire, all this additional information as well you can add here. But I'm not going to add right now anything. I just wanted to show you how exactly this looks. And I think there was one question. Basically, ACLs are using to get the permission from users, right? Okay, now the major thing I want to stress about when we are uploading or doing anything from S3 is that there are few features that are not available through Web Console. So for an example, there is a feature called multi-part uploads, and I'll show you, and we'll take a look at that in the later sessions or the latest lessons that I'm going to give you about S3, so that we are not leaving anything out. But for simply getting data into and out of S3, the web console works great for that. Now, speaking of CLI, I'll head over and perform a few commands there as well. So let me do that first. And again, if you do not know how I did what I did, the initial steps, that because I have already mentioned that some assumptions that I'm going to make that you already know that. If you do not, please Google about that. It has this very cool looking extension installed called Oh My GSH. I really like this. It is all colorful. It makes me look cool, I think. So yeah, so I'm here. I'll just all you have to do is type AWS console, and font size is fine, or should I increase? For some reason, I've heard this in my all of classes that you work with very small font. Okay, is this fine now? Give me a second here. It should work. AWS console. Why is not working? Oh, sorry, my bad. It's already there. You have to type AWS configure. Okay, and it is going. I already have mine. US East 1, and format I like is JSON. So that's all you have to do. And now you can reach out to your AWS console. Now, what I'm going to do is I'm going to go to the root of my, there is a folder that I've created for this. Okay, it's not here. CD desktop certification. Okay, here we go. CD content ls CD Amazon simple storage service, getting data into S3, and The example that I'm showing is CLI. So I'll do the CLI. And over here, you will find that I have few files which are CLI.txt, move me CLI, sync me CLI, web console.txt. All of these files are present to demonstrate what I'm going to show you. So we can see that we have a CLI.txt, a move me CLI.txt, and a sync me CLI.txt. And actually, let me remove one file, web console.txt. This is an additional file. It should not be there. And we'll start off by using first command, and that is your copy command. Now, how do you use copy command? But that's correct. So over here, what all I have to do is copy and write the same command that you just mentioned it to me. We are going to upload the first file called cli.txt to our S3 bucket, which whatever is the name, I forgot. Now, command for that is AWS S3CP, my file name, which is cli.txt. Let me first clear my screen. Sorry, I just need to drink some water. Give me a second. Yeah, so the command for that is AWS S3 CP and source, and our source is cli.txt. Don't know why it is not working. It should work. Let me try it this way. // your bucket name and enter. Okay, and it clearly says that it has uploaded cli.txt to this particular bucket. Now, obviously, we do not trust machines, security credentials. Yeah, this is where you go, my security credentials in IAM. You will find it somewhere here. Just you can see it's my local machine. I am in my desktop. I'll show you. This is the path of my desktop. So I'm not in EC2.
S3 has nothing to do with EC2.
On the topic. So all you have to do is click on type AWS configure. It ensures that you are local or wherever you are, EC2 or Unix or any system that gets connected to your AWS account. And that is the operation of AWS configure. Is that clear? Okay, awesome. So we have seen how do we copy something. Now we'll see how do we move something. So for that, the command remains kind of same. All you have to do is instead of CP, you do MV. And let me be a little lazy. And hey, sorry, AWS S3CP. Why it's not going? Hey, this is too annoying. I'm not doing this. So I'll just type it again instead. AWS S3CP. I have a file called moveme.cli.txt. And then again, I have to give my S3 bucket location. My S3 bucket location is S3:// demo harsh. Do another cross check by doing a ls, and you will see that moveme cli.txt does not exist anymore. Now we'll use another S3 command, which is AWS S3 ls and then S3 blah blah ds demo harsh. What do you think this is going to do? This is pretty self-explanatory.
On a list.
Yep. So just
List
enter it.
files.
It will show you the list of the files which are present in your S3 bucket. Now it is not showing me the list of files present in my local, which is my Mac. It is showing me files which are present in my S3 bucket. So S3 ls really only functions for buckets and bucket prefixes. we don't need to specify that it is an S3 bucket with your S3 blah blah blah. So even if you want, you can type this AWS S3 LS and DAS demo Harsh. You do not have to provide S3 :/ here, and it will do the same job. Okay. Last but certainly not the least, and this is the command that I have used a lot for all the system administration tasks where I need to basically sync things between, let's say, auto scaling groups and so forth, which is the sync command. So what that will let us do is that it will only move the files that are not already there in a bucket. It also uses the last modified flag on your file to detect if that file is changed versus the file which is present in the bucket. So if that file has changed, so that the newest version in your bucket is present. So for an example, right now I have a file called, let me read this. So you have a file called cli.txt. Okay. And it has this content. Hi, I came from CLI. Let's say I changed it. Hello, this is Harsh. I came from CLI. Okay. In that case, if I'm using a sync command, what that sync command will ensure is that all of my file, which is my latest file, that gets moved to S3 bucket. Okay. And instead of talking about it, let's see it in action, how AWS S3 sync command works. And you explain it to me, what exactly you saw here. Okay, so let's get started with that. So all you have to do is type AWS S3 sync and then your destination or source. So source, you can just put a dot over there because I just want to do whatever is present in this entire folder. We want to sync the current folder. Okay. Now, all I have to do is provide the destination, which is
getting data into S3 and go to 3. So this is the last step that we want to see of how do you get data into S3. And in this particular lesson or session, we are going to wrap up our demonstration with getting data into S3 with the Python Boto3 SDK. And then we will summarize what we have discussed so far. And finally, we are going to take a look at how to move some data around with the Boto3 SDK. So here, this is my text editor or whatever you prefer, you can use it. I prefer Visual Studio Code, so I am using that to read my code. So this is my text editor in that. I'm going to go ahead here and now I'm going to move my file called boto3upload.txt using an SDK. So how does that file look like? And this is that file. Hi, I was uploaded with Boto3. Pretty simple. And so first, I have prepared a script that will perform these actions for us. Now, what we are going to do here is I'll walk you through this, and then we'll go and run the script and confirm that everything works as intended as well. Now, first, we are going to import Boto3 command, as you can imagine, to our Python script. This is called boto3actions.py. First thing is to import Boto3 library to your Python script, which makes it available for use in the script. Now we are going to initialize our two interfaces. And so we have a S3 client variable, which is boto3.client S3. And then we have our reference variable as well. So S3 resource variable, which is the reference to the Boto3 resource for S3. Now the resource is the older model. It is still available because it has not been deprecated and it's fairly widely used as well. Now, it does allow us to do a few things in a more simple manner. It doesn't have as many levers and knobs to flip and twist, but it's useful to do a few things. So we'll take a look at that and we'll see which operations are using that resource versus the client. So basically, or essentially, resource and client do the same thing. One does little more things than the other. However, resource was created first. That's why it has less features or different features than client. So I'll tell you what exactly are the differences later. But right now, you do not need to worry about it. So far, just remember, you can use any of this, either client or resource. Now, so first, we are going to use the put object, which is essentially going to upload a binary object from our script to our S3 bucket. So we need some data to move. And so we have a variable called put message. This is a byte type string, and it just says, hi, I came from Boto3. It's not a file right now anywhere. It only exists here in this particular script. And essentially, we are going to turn this into an object or a file that is going to be in our bucket. Now, this is useful for performing operations like collating log files and so forth. So that is a practical application of this kind of operation, that you probably are getting a lot of logs. You do not have a file. You have actual binary data, or you have string data. You just want to club it together and put into a file. In that case, you can use this, which is body put message. So this is my put message. This is my bucket. Actually, I've changed it. I don't want to type it again and again. So instead, I'll do this. It will replace the previous bucket name with the new name. Okay, so I hope you are with me so far. So now we can pick them all up and modify the memory. We do not need to write them back to a file before we send them to S3 if you are using this put object. So that's the purpose of it. Now we are going to capture the response of our API call in the response variable. Now I'm going to use the S3 client. This is a client operation, and we are going to put object. So you need to provide a body of your object, which is going to be our byte string here. Okay. We need to specify a bucket. So that's a bucket. Okay. Dash demo hash. That is our bucket name. And you have to provide a name of the key. Key is nothing but your file name. Okay. So it's just a prefix. You can call it whatever you want. I'm calling it boto3 put.txt. Okay. Now, if we had any prefixes, we could add them here as well. So we would just say prefix, then our key, which means essentially if you have a bucket created inside bucket, you can write the name of that internal bucket here as well, along with the key. But we do not want that here. So we are just going to leave boto3 put.txt here. And then we'll print the response just to verify that there are no errors about it. Now, next we have the copy command. So we need to specify our source for our copy. This needs to be a dictionary with a bucket and a key, and then the values that are appropriate for that. And we are going to specify bucket, that is dash demo hash, as you can see here. Then we are going to specify bucket is, if we are going to specify key, is going to be boto3 put.txt in this. Okay. And again, this is the source. So we are going to copy this object that we just uploaded with this put object call and send it to a destination. You can just put this dictionary syntax into the source argument space over here as well. Okay, so this is your copy object. That's how you copy. The next thing, I'll just skim through it because we are running short of time. You'll upload a file. You provide the name of file, whatever you want. You use operation called upload file. You provide this and the name of the bucket. And this is how you upload it. Again, teaching you the code is not my job here. So man, I'll come back to you. Let me just run this first. Okay, here I am in my terminal and blah, blah. Go back. ls, boto3, ls, Python, boto3 actions. Oh, I do not have. Pip install boto3. Hey, it's trying to download it from my office network. Obviously, it will not work. Then it will download it from usual internet. Source demo dash bin activate. Okay, pip3 install boto3. Okay, hopefully this will run now. Python 3. Yep, it worked. Now it works. Or whatever. Am I getting? Yep, if it gives you this status code 200, that means it worked. So that is for my demonstration. I have already created all this file and kept it in this folder. Even if that file does not exist, if I delete this file, 423, I'll show you. Actually, let me delete this. Okay. It will work. See, I got 200 and that file, where is it? Yeah, this much we have covered. We tried uploading files and doing some actions with the file from 3 places. One was your console, second was your CLI, and third we saw the same thing with the SDK as well. So this much we have covered. We have seen all these 3 upload interfaces: console, CLI, SDKs. Then we talked about transfer acceleration, and along with that, we talked about CloudFront as well. So CloudFront is for download and transfer acceleration is for the upload part of it. Now we have to start this. Actually, we can skip. So I'm going to not show you the demo of it right now. If we have time after we have done with the other things, just remind me about this and I'll show you the demo of it as well. Not a big thing, but I'll give you the theory of it for now. So this one is S3 multi-part upload. So where exactly we will need this is when you have this situation, when you basically will say that, oh, I am dealing with a lot of data. In that case, it does not make sense to upload that via console, because console will rely entirely on your bandwidth, whatever you have. Even if you are using CloudFront for that upload, if you're dealing with terabytes of data, in that case as well, it's a terrible idea to just directly upload a 5 TB file directly from console. So the second natural question that arises is there a better way to do this then? So that's where the multi-part upload comes into the picture, where we will see this 3 multi-part upload API calls, which you can make in order to upload a very big file. After that, we'll talk about few consideration. And as I said, there is a demo for this as well. I have the code prepared and everything. You will use S3 multi-part upload when you have a lot of data that you are dealing with. So basically the analogy for that, which I have put here, is you are trying to move a building, which is pretty impractical, time consuming as well, and probably expensive. You will need a lot of equipment, bulldozer and whatnot in order to be able to move a. So you can use single S3 put object, which can upload up to 5 GB of file. Now, S3 objects, they can be up to 5 TB. In that case, what happens is, in a single put call, you cannot upload more than 5 TB. What does this tell you? That even though a file, a single object can be up to 5 TB, but when you're trying to upload it, you cannot go beyond 5 GB, right? Because till then it makes sense. Apart from that, you have to go for some better scheme. And that's where this comes into play. So what you do, these are the 3 consideration or moving pieces that you have. You basically will first prepare the data. And when I say prepare the data, what you do here in this step is break your data into reasonably sized pieces. This could be few MBs, few gigabytes, depending on what kind of object you're uploading. Then instead of moving the entire building, probably you're just moving few blocks or few bricks at a time or few concrete at a time, whatever. So in the next step, what you do is you perform multi-part upload on this break data or broken data, and then put your files, entire file, into an S3 bucket. And S3 will put it all together by itself. You do not have to stitch it back together again. S3 takes care of that part. So these are the 3 API calls that you will need to make when you are moving a big file or when you're using multi-part upload. So first API call is called create multi-part upload API call. What it gives you, it returns bucket, key, and upload ID. So bucket would be, let's say anything. We named it demo Harsh last time. Let's consider that. This is my bucket name. So if you remember, we uploaded a file called web console. That was the name of a file. So this particular API call will return this as well, web console.txt. There it was few KBs itself, but for now, consider that this is a, let's say, 10 gigabytes of file. Okay, for this example, just consider that. Now, and last thing it will return is upload ID. Now you will need something to keep a track of. So that's what it gives you. It will give you one random alphanumeric ID, and that will basically allow you to stitch this thing back together that, okay, all of these files, what I have received as a broken pieces, they belong to this particular upload ID. And S3 will know that I have to stitch it back together. The second API call is upload part API call. And here you provide bucket that you got from here. You provide key, which again you got from here, part number, and upload ID. So 3 things are what you already received from the first API call. Only thing that you need to give here is part number. Now your file is broken down. Let's say this 10 gigabytes worth of file is broken down into 100 pieces. So you will just keep on giving or create a for loop, take piece 1, piece 2, piece 3, and just upload that. So this will take care of that. What it will give you is it will return an E tag. Okay, so that's what it will give you, E tag. The last thing is complete multi-part upload API call. And over here again, you provide bucket, key, upload ID. Again, the same 3 things that you got from the first call. And here you provide all part numbers. And along with that, you provide this E tag as well. And it will basically return bucket, E tag, and key that of saying with a 200 HTTP status that this one has been uploaded. How do we get part number? Is the question from Shashi. So part number is basically you are dividing that file into multiple portions. So you will have that logic created that, okay, I have broken down this file into 100 pieces. That again depends on your logic. If you want to create a piece of 10 KB, 10 MB or whatever, you will know that it will just be 1, 2, 3, 4, whatever. Yeah. So coming to few considerations that you have to take care when you are using all this API operations, multi-part uploads, it can be made up to 10,000 parts. So there is a limit to it. You cannot make 11,000 parts. So make sure whatever logic you're using to break down your file, it should not be more than 10,000 part. And 10,000 part is more than sufficient because as we mentioned, this is a question that you guys should be able to infer this. Why 10,000? There is a math behind it, a very simple math. Can you think of it? Okay, so that's how they came to this number, that one overall file can be 5 terabytes. We allow 5 gigabytes in one call. That's how you can make not more than 10,000 calls. So that's how you remember stuff, because otherwise it's hard to remember how many parts and all these things, too many things to remember. So you should know the logic, how they came to this. Anyway, so I hope this is clear. Why 10,000 parts? Please do remember that. Second one is override. So when you specify the same part number as previously uploaded part number, it can be utilized to override that part. So for an example, I am uploading a file in 100 pieces. I found that, okay, 64th piece, I got an error. In S3, when you go and see, it contains only 700 megabytes. In that case, you can just specify this 64 part number again in that API call, and it will make sure that it rewrites this. So basically a retry mechanism is there when you specify the same part number. So that takes care of the override. Now, final thing that you have to consider is auto abort, which is you can have a bucket lifecycle policy that can be utilized to automatically abort multi-part uploads after a specified time period. It's basically you define that I just want to keep trying for 30 minutes. If it takes more than 30 minutes, it will cancel that call. And obviously, the upload will not happen because you have set this auto abort limit. Again, if it's up to you, if you want that, you can have that. So these are the three considerations. And yeah, you can utilize multi-part upload for files larger than 100 megabyte is a thumb rule. Again, it's not written anywhere. This is where I use it. So don't hold me if somebody says that, oh, I have used it for 5 megabytes or whatever. I usually use more than 100 megabytes. I go for multi-part uploads. I find it much more easier. Now, all parts except the final part must be at least 5 megabytes. This is another thing, that your single part should be 5 megabytes. So that's how you take care of this consideration. So this one basically says that first one is just a thumb rule. Again, you can use it for less than that as well, but usually I use it for files which are more than 100 MB. Till 100 MB, I just upload it from one single put call and it works. It's not a problem. If any file I have which is more than 100 MB that needs to go to S3, I usually use multi-part upload. And the second point which I was mentioning is yours every single part should be at least 5 MB. It cannot be 3 MB and maximum 100. So it can be 5 MB, 6 MB, 10 MB, 20 MB, 100 MB, but it cannot be 110 MB or it cannot be 3 MB. Hope that makes sense.
No, sir,
Yeah,
I have a question. I've shown the abort action, right, for the uploading. Like after
Auto
some time, it is going to abort automatically. Auto abort. So what is the use of that? Means in which during means where are we going to use that auto abort?
Again, that's a utility usage depends on you. How I actually have never used it, but how probably you would use it. You have a certain limit or you have certain budget or threshold that you're working with. And you know that if it is going to take more than 30 minutes, let's say, it is going to cost you more. So that's why probably you don't want to do it. Again, usage is totally up to you. They have just given a functionality. How you want to use it depends on it. A lot of nines you will see. I'll show you that. So what are all these nines? We are going to talk about that. And then we are going to talk about all the storage classes that S3 gives, which are S3 standard, S3 infrequent, intelligent tiering, glacier, deep archive, and finally we summarize whatever we have learned so far. So let's quickly dive into it. So yeah, S3 provides you a bucket for every kind of use case, and I have tried to summarize it here where exactly you might want to use which class. So let's see. So first one is standard. Standard, I would say, being honest, for last 5 years, I have not used anything else apart from standard. Like 70% or 75% of my use cases goes in S3 standard itself. So that's why it is called general purpose. For anything, you don't want to waste too much your head into figuring out a lot of stuff, why class, which class, all these things. You just want to upload your objects, you go for standard, and it's the most general purpose class. Then comes intelligent tiering. So this you are going to use when you do not know access pattern, whether you are going to need this file tomorrow, whether you are going to need this file after 1 month, or whether you are going to need this file after 1 year. You do not know that pattern. In that case, again, you don't want to waste too much of your brain power in figuring out which class I should go for. In that case, you can leave the heavy lifting to this class called intelligent tiering. Then comes standard infrequent access. As the name suggests, it's for data which is being accessed infrequently. When you're using, when you know the pattern that, okay, I will need this file, but only weekly or monthly. In that case, it makes sense to go for this class, which is called standard infrequent access. Then we have one zone infrequent access. And here, when you are dealing with the data, which can be easily replaced, you do not mind losing this data. For whatever reason, you do not mind losing this data, then only you should go for one zone infrequent access. Then comes Glacier. Glacier is basically for archival. Same goes for Glacier Deep Archive. It's for archival as well. Now, why Glacier? When Glacier Deep Archive? So when you have acceptable retrieval time of minutes to few hours, you can wait for your files to be retrieved in few minutes or within few hours. In that case, you can go for Glacier. When you have a retrieval time which is acceptable in hours, not minutes. Here we are not talking about minutes. It can be like 5 hours, 6 hours, 12 hours, something like that. In that case, you can go for Glacier Deep Archive. So these are the storage classes and these are their use cases.
Could you explain the Glacier serving?
Glacier, as the name, again, I am going to explain it again, all of the, as I showed already. I'm going to talk about all of this in detail, as you saw here. We are going to talk about standard, infrequent, blah, 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 everything. Here, it just shows you the use case. Now, obviously, why you probably might want to use your head in figuring out which class I should go for, like how everything in life boils down to, it's because of money. So here it's in ascending order. Glacier Deep Archive is the cheapest and standard is the costliest of all the options that you have. That's why you might want to know or understand what are these classes, basis that you can save money. Now, yep. So what are all these nines? So in S3, if you go and look at their documentation or S3 page, you will see they claiming that they provide this much durability, this much availability, and blah, blah, blah. And everything has a lot of nines in it. That's why all these nines. This one is very famously called 11 nines of durability. So here, if you count, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nines. So they tell you that S3 standard access, it gives you a standard class, it gives you 99.99999 11 nines of durability, which means there is very little chance that something might happen to this file. If you have uploaded it, it will be there. Nothing will happen to this file is what durability suggests. Then availability is how quickly or how easily that file is available. So there's nothing much to explain here. So again, there is limit how S3 is designed. So it gives you from 99.5 to 99.99% availability. That I have asked for food, that food is available at that particular restaurant. There are chances, 99.99% chances is there that when I go to MacD and I ask for my Big Mac, 99.99% chances there that it will be there. There's only 0.01% chance that they'll say no to you. Same goes for S3, that there's very little chance that S3 will say that, okay, this file is right now not available. And then you have service level agreement, which is 2 to 3 nines, 99.2, 99.9%, which means service level agreement basically means that, again, same example, carrying forwarding, which is MACD. MACD, let's say, have a service level agreement with their users that we will be open 99.9% of the time. If something happened, world calamity or something very big, then only there is a chance that we will not be present. Same goes for S3, that it will be available 99 to 99.9% of the times. If something happens, there is flood, calamity, earthquake, whatever, because of which their data center, all three data centers are affected, then only they will say that, oh, S3 is down today. So this is the design of S3, and it, as you can see, includes a lot of nines. Now, coming to our very first class, which I mentioned is a general purpose class, which I use it personally very much. So that is your S3 standard. As I mentioned already, it is a standard purpose or general purpose class, which means you don't waste your too much head. You want to upload something. This is the default. You upload it. It will be there. As easy as that. It's just that only caveat here is that this is the most costliest of all the storage classes. Then comes high throughput, low latency. Here, whatever you upload, it will be uploaded very easily. It will not have any kind of hiccups. It will give you low latency as well. You want that file, it will not give you too much time to download that file or retrieve that file. You will get it. Often the first stop in data storage lifecycle.
Standard class, and this is the place where they need less charge or more and whatever, right? So that it's a little bit I'm confused here, so that's why I'm.
It's because of this. How much durability they can offer you, how much availability they can offer you. It's based on that. So basically, let's say you have what do you say? A Target store, Walmart store, whatever store nearby you, and there might be one store, let's say in Times Square, which will say that I give you 99.9% availability. That it's a very area which has a lot of footfall, and they make sure that this particular store is open most of the times. Same way you have another Target or Walmart store somewhere in suburbs, and probably that store is not this much available. So basis this, how much durable they are or how much available they are, they have all these classes. Okay, the second one is your S3 infrequent access. And as the name suggests, it's for infrequent access. What do you do basically here? If you know that I am probably not going to be using this file after uploading for around a month, around a week, in that case, you can basically use this particular S3 infrequent access and it will save you some bucks. Now, coming to few technicalities about it, and that's where most of the people gets it wrong. And I've seen so many people screwing up here. So there is one caveat that AWS gives, which confuses everyone, especially not for the certification when you are actually using it. So they provide this additional data write charge, which is 0.01 per 1,000 requests. This is how much you are charged when you are writing for 1,000 requests. This is what you're charged for retrieval as well. You are asking for your own data, but if you have put it in this infrequent class, you will be charged this much. And that's the caveat. This does not happen in your general purpose or S3 standard. And that's why I said I'm a person who do not like to waste my head where I don't have to. In that case, why should I calculate if I retrieve this file or how many requests I'm making, blah, blah, blah. I go for S3 standard because it's cheaper as well. But again, when you're working for a company, a production use case, when you are migrating your customers' data and they don't want to save some money and all, in that case, they have all these classes. In that case, your skills of being a data engineer comes into play. You will calculate all this. Okay, my client has this much data. If they retrieve it this many times, this is how much they'll be charged, blah, blah, blah. But again, I am not going to do that. Please do that on your own. My job here is to tell you what will happen if you use S3 infrequent access. So please do remember there is write charges, there are retrieval charges. Just keep that in mind. Now, this is one simple point that objects which are smaller than 128 KB, they are built as 128 KB objects, which basically means that if it is 128 KB and less, it will be charged as per that. But if it is 129 KB and less than 1 MB, you will be charged for 1 MB. Understood or not? Same thing goes for your one zone as well. That one zone is, again, as the name suggests, it's exactly like infrequent access that you pay for this retrieval charge here as well. It's just that in one zone, what will happen is here your data is replicated, which means you uploaded a file called webconsole.txt. It will automatically be present in 2 other AZs as well. So that if something happened to this particular AZ, your file will be present here. If something happens to this, it will be present here. So there are less chances of your files getting destroyed or not being available. So that's why I mentioned you only go for one zone when you have some data which you don't mind losing. Okay. In that case, why you go for one zone? Because it's cheaper than your infrequent access. Why you don't go for one zone? Because you have a file which you definitely have to make sure that nothing will happen to this file. Okay, so yeah, these are the charges as well. As you can see, standard infrequent access, you pay 0.0125 per gigabyte stored. Here you pay only 0.01 per gigabyte stored. You do not pay this extra whatever it is. I don't know how to pronounce this. And both have the similar nines thing that here, if you are uploading your data, whether in infrequent access or one zone infrequent access, you will get 11 nines of durability. This is same as your standard. Everywhere you are getting 11 nines of durability. That there are very less chances that your file will go corrupt or it will not open or it loses some data. That will not happen even in infrequent access or one zone as well. However, as you can see, it has 3 nines of availability. Why? Because obviously here you are storing in an infrequent access. So it is basically, let's say you are saving in standard access, it's kept in one box. If you're keeping in infrequent access, there is a box inside a box. So first you have to open this box, then another box, and then you retrieve whatever you have saved in that box. Same goes here as well. It's one layer beneath. So obviously it will take some time to retrieve that. That's the entire logic of infrequent access and one zone as well.
Let's have a quick quiz question, guys. And the question is, which of the following is not one of the 3 V's of big data? Option A, volume. Option B, variety. Option C, velocity. And option D, validity. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data Certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
Now comes the most, what do you say, not so easy option. This involves a lot of things. So if you understood so far everything, you're good. If you are confused already, this will confuse you even more. So intelligent tiering is, as I mentioned, you tell me, when I use intelligent tiering, what is the use case?
When the demand is unpredictable.
Exactly. When you do not know the access pattern. The previous one, you knew that, okay, when you have a file which needs to be retrieved weekly, monthly, you will definitely go for infrequent access or one zone infrequent access. But here you do not know. I might need this file tomorrow. I might need this file 1 year later. In that case, you leave the heavy lifting to S3. And what this one do is basically it uses a combination of standard and infrequent access. So your objects, whatever you're saving in this particular class, intelligent tiering, they will be basically monitored. There will be a basically class prefect assigned to this particular class, which will keep on monitoring it in the absence of a teacher, and basis that it will report or do things. So over here, what will happen? Again, here we brought another layer, which is of monitoring. What do you think? Think AWS is so gracious that they will do something for free? Yes, no?
No.
Definitely no. Here, they give you this flexibility that you can save it for cheaper when you're not using this file for 7 days, 30 days. But here they brought another thing that, oh, okay, you are saving money here. Let me take some money from you in the form of data retrieval charges. Same thing they have kind of introduced here as well. Here, what are they doing? They are doing one additional thing, which is monitoring. What do you think this charge will be called? The extra charge? To moving into classes and monitoring. They are keeping a check. Here, you uploaded something in standard infrequent access. You uploaded it. You forgot about them. AWS forgot about them. The file is present here. But here, they are monitoring it. They have created an entire service which monitors it. So they charge this monitoring fee as well, as you will see later. But let me first talk about this, so how it works exactly. So as you can see, they have this monitoring and automation charges. Automation basically means moving it from here to here. They have done some sort of automation, which you don't have to do manually. So they charge 0.0025 per 1,000 objects. Again, as you can see, the number is very small. It only feels bigger when you're dealing with lot of data, lot of company data. Usually we don't have this much data on our own to worry about. And here storage fees are there, which are a little higher as well. Very few 0.0 some difference, but there is some difference. So here you pay 0.0125 to 0.023, depending on where it is stored. It will be stored. So kind of I'm not choosing the most costliest class, which is standard. I do not know whether infrequent access is good for my client, because again, I don't want to think about it too much. Okay. In that case, I'll choose this middle approach, which is intelligent tiering. So here you cannot be too wrong. Here, there are very good chances that you can be too wrong. Why? Because let's say I am just a new person. I just heard it from Harsh's class that, okay, infrequent access allows me to save some money over standard class. In that case, instead of going for standard class to impress my manager, I went for infrequent access. But I ended up spending even more for my company. Why? Because what files I have uploaded, they are being called every day, every minute, so many people are accessing those files. In that case, my retrieval fee became much more than my this fee, which is storage fee. So in that case, I can be very wrong. I can, instead of saving money for my company, I can end up spending more. Here, you are obviously spending more. There is like, nobody has to even think about it, that you have saved it in the standard class. That means you have done literally nothing. You got some default option, you uploaded there, you did nothing here as well. So intelligent tiering, here, as I mentioned, I do not want to worry about this heavy lifting, and it's very good for automation, and everybody likes automation. So here, if I have saved it initially, my file in standard, and that file is not being accessed for 30 days. Okay, this very intelligent service will figure out, oh, Harsh has made a mistake. He should not have uploaded it in the standard. He should have uploaded it in infrequent access. So automatically it will take this file, it will move here. So here what I did, let's say I'm again made up numbers. Here I was spending $1 every month. Because of this intelligent tiering, what happened? I came here. Here probably I'm spending 80 cents on storage. But there is a retrieval fee. But it has already figured out that you have not retrieved it for 30 days. And it makes sense that probably for 30 more days or 15 more days, you're not going to need it. And even if you are going to need it, it is going to cost you, let's say, 0.5 cents more. So even then, I save some money, right?
Okay, I see what you're saying. Thank you. Yeah.
Okay. And it is, again, as I mentioned, it is intelligent enough more that, okay, when I retrieve this file, after, let's say, 60 days. It will assume here that, okay, as you have retrieved it now, you might retrieve it again. It does not take that chance that it will keep it in infrequent access and then 10,000 people came and asked for that file and then you ended up spending more here. What it will do when you retrieved it, as soon as that, it will move it back to the standard. Standard, again, same thing, you pay for storage, but you're not paying for retrieval. Same thing, it will keep on figuring out, not just for one file, for entire files present in your bucket, and it will do all of these things on your behalf. Yeah, Gaurav, go ahead. It only makes sense when it is on file levels. Why? Because let's say my bucket contains, obviously, when you're working for a company project or something, it might contain like 10 lakh file, 1 lakh file, something of that sort. If let's say I retrieved one file, that does not mean I'll be retrieving all 10 lakhs of them. If I move all 10 lakhs of them to standard, I'm paying for all 10 lakh of them. So it does not make sense when you're doing it to a bucket. It only makes sense when you're doing it individually at a file level. Yeah, Lakshmi, go ahead. And these are again nines. I'm not going to read. This is your responsibility. Read it, remember it. But durability, as I mentioned, they give 11 nines of durability. Not much to remember there. Availability, 3 nines, not bad as well. Additionally, these are the charges that you have to worry about when you're using intelligent tiering, which is monitoring and automation charges, which is not there in any other class. And storage, this are the amounts. If it is saving in some particular standard, it will be this. If it is saving in infrequent, it would be this. Again, for your certification, you do not have to remember this numbers. You just have to understand what exactly a class does, when do you use it, what exactly that class is doing. That's all. You do not have to remember this. This I have put for your knowledge to be able to compare this for your personal use cases or office related use cases.
So you told us like during infrequent access, the file can be accessed during monthly or weekly, right? So is there any option there like so that we can configure it so that we will be needing this file for 1 week, after 1 week or 1 month, or is it automatically going to suggest us like after every 1 month or after every 1 week that we are going to need that file?
So I guess it's like totally like, business people know key I don't use this file frequently. So based on that, we categorize as, it's like based on use case.
That's what you are paying for. You have to worry about this as well. There is no use of intelligent tiering. Okay.
So I think AWS is also providing option where we can select like how much time I can put the data from standard to infrequent access kind of things.
Okay, then comes the Glacier. So in Glacier, as I mentioned, it's for archival. Here you just have to think about how fast do you need that data. If you need that data in few minutes to few hours of time, then you can go for Glacier and save more money. And this is how much it costs. As you can see, it's even lower than intelligent infrequent one zone. It's the lowest of whatever we have seen so far. Here as well, there is a catch. If you want it expedited, you have to pay this much. If you want standard, this much. If you want like bulk, this much, and all these things. If you have put it here, that you know that you have to wait 4 hours, but you want it probably in 1 hour. You have to go for this. They'll give you no problem, but they'll charge you more. So if you want a file to be retrieved early, then it does not make sense to put in Glacier. That's all you have to know here. And finally comes the Glacier Deep Archive. Here, your data will be retrieved within 12 hours. Okay, so it can be 1 hour, 2 hour, 3 hour, whatever, but it can take up to 12 hours. So if you are sure that you can wait for a file to be retrieved within 12 hours, in that case, you can save it in Deep Archive. Where exactly people use this? When you have this kind of requirements that like Europe has this requirement of you need to give users their data if they ask for it. In that case, no matter how many years you have to keep that data. It's just that you are not using it every day or every month. It's only when somebody asks it. And you can definitely give them an SLA. Like basically you might have seen with banks, not sure about other countries, but I can give an example of India, that you go for a bank, that you ask for certain documents, that, okay, I want this, my home loan foreclosure letter or whatever. In that case, they say that we have a SLA of this many hours or this many days. We are very slow, so it takes days here. But yeah, that's why it is, because they have saved that data in this kind of classes to save some money. That's why they give you SLA. Otherwise, obviously, if they have saved it in S3 standard, why would they ask you to wait for 5 days, 2 days, 1 day? They should give you immediately. It's because of this that they have saved it. They are giving you that SLA because they want to save money. They have put it in this kind of classes, and they have the liberty to say to their customers that please wait, we have raised your request, but you have to wait. That's all. But there are certain cases that you cannot wait, like you're ordering from Amazon and you're giving your SLA to users that, okay, you have ordered today, but I'll tell you when it will be delivered after 2 days. That cannot happen. That's why they probably save it in standard access. So how much it costs? As you can see, it is the lowest of all. This is how much you pay, which is very, very cheap. But if for whatever reasons you want bulk data, like whatever 10 terabytes of data you have uploaded, you want it all, you have to pay for this. If you want standard, that is pretty fine. That's much you pay for it. And for both Glacier and Glacier Deep Archive, you get 11 nines of durability, 4 nines of availability. It's only for your personal use. Otherwise, they just ask, as I mentioned already, they ask scenario-based question. And I have an example as well that is coming up. That's why people usually have questions. So I have put that here as well. That we'll quickly see after this. The next thing that you should know about S3 is life cycle policies. So let's quickly see that. So yeah, that's a funny looking analogy for this. So entire data has this life cycle. You create that data somewhere, anywhere. Your customers might be creating it. You are creating it. There are logs coming in. There are different ways of creating data. Somewhere it is being created. Then there is some active utilization. Otherwise, why you're even creating it? Somebody uses that data maybe every day, every week, every month, or whatever. But there is some sort of utilization of that data. Okay, if that utilization is not there, then it does not make sense to keep that data. But you have to save it. You cannot just keep it in this class. In that case, you archive that data. You put it in this archival class. If probably you want to use it, as I mentioned, a customer came, asked for the data, that comes again to this active utilization stage. So this keeps on going. So that's the entire life of data. Now, this is the life cycle that works in S3. That probably you put something in S3 standard. You create something, you might probably don't want to think too much about it, just simply put it into S3 standard. Then if you see that, okay, I'm not going to be using this data anymore, you put it in infrequent access, knowing that I might need it next month. Then after next month as well, you figured out that, okay, I'm not using the data at all, but I just want to save it. You can go for Glacier or Glacier Deep Archive. Then if some request came, you can move it back to standard, infrequent access, whatever. So that would be the life cycle of data in S3. Now, to kind of make your life again easy, just like intelligent tiering, there is another thing which is little manual than intelligent tiering. Intelligent tiering is completely automated, and that's why you pay that money. But again, let's say you are a frugal person. You don't want to pay that money as well, but you want to achieve the similar kind of thing here by using some sort of logic from your head. So in that case, you can use something called as life cycle policy. So this is how the policy would look like. And you can write something like this that you are seeing here. You have to assign this rules. First is filter. What do you think filter will do? What exactly, where exactly you want to apply this? So this particular logs basically says that, okay, there is a folder or a bucket called logs. I want you to apply this rule there. So you can apply this prefix. Okay. Then you have status enabled. Obviously, you want to enable it, you'll enable it. When you want to disable it, you'll call it disabled, and nothing will apply there. Then comes the transition. Now in transition, you can mention this kind of rules that you'll see here. Anyway, what we are trying to achieve, first I'll tell that. So I have, let's say, a bucket called logs. Okay. In that bucket, I already know that, okay, this logs I'll use for 1 month. So I can keep it in S3 standard because I do not want to pay for retrieval fee because I'm using them every day for a month. After that, I might not be using it, but I might need it anytime. So I cannot keep it in here. So in that case, I'll move this logs from standard to infrequent access for next 3 months. And after 3 months, I am sure that I'm not going to be needing them. So what I can do, I can move them to Glacier, and the entire thing I do not want to do manually. In that case, I can go for life cycle policies. So how do we do that? We just have to write this rule. Very simple thing, which I have already given example and I'm writing for you as well. So here you can apply this transition that I want you to transition it when after 30 days. What storage class should you transition to? Standard infrequent access. So after 30 days, S3 will automatically move all the files which are present in this folder to standard infrequent access. With me so far?
Yeah.
Yes, no? Okay, yeah. Then these are the options you have. I have clearly mentioned those as well. Then you can provide all these options here. You can move it to standard infrequent access, one zone access, intelligent tiering, Glacier, whatever. You can move it to anywhere. So yeah, basically lifecycle, as I mentioned, it allows you to transition as well as expire everything without paying unnecessarily for intelligent tiering. Again, if you don't even want to do this and think about here, what is the difference from intelligent tiering? This you are setting it 30 days, 120 days, and there it will figure out automatically. Then why use lifecycle policy? Just to save some money that intelligent tiering is costing you. That's the only use case of lifecycle policies. And yeah, we have covered this as well. And that brings us to our last section, which is to understand how exactly S3 secure your data as well, because you have seen that there is a security related section in the certification as well. So you should understand security aspects as well. So before that, let me ask, it's 10:30 and as I joined late and we have this blah, 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 hiccups and all. Do you want to take your break or can I skip your break? Again, totally up to you. I'm ready to skip break and keep on teaching if you want, or we can go for a 10-minute quick break as well. Okay, so these are the overall security features that S3 provides. I'll just name them: Access Analyzer, Amazon S3, Server Access Logging, Bucket Policies, Bucket Access Control List, Cross-Region Replication, Multi-Factor Authentication Delete, Object Access Control, ACL, Object Locking, Versioning, CloudWatch Alarms. These are again integration, not exactly S3 features, but you can integrate with CloudWatch Alarms, CloudTrail, IAM, VPC endpoints, and service control policies and KMS as well. Obviously, this is very overwhelming, and that's why I'm going to break it down and simplify it for you to understand how exactly these things work. For first thing is your in-flight security. Like what happens when you're putting data to S3, when it is traveling the internet, how do you secure that data? So that's where your TLS support comes into play. And again, here I am not going to dive deep into what exactly is TLS, but I've given you links in that support guide. If you're interested, you do not need to know. It is not for a data engineer to know what TLS is. It's for a network engineer. But basically, all of your data that you use from any of the respected sites, it follows this TLS protocol, or it traverses through TLS principles. So all S3 clients supports TLS 1.0 through TLS 1.2 is recommended, but at least it provides this as well. So yeah, this you can set it that I want a TLS support, and it will make sure that your data, when it is traveling the internet, when you are, let's say, uploading it, or when you're downloading it or putting into Snowflake or somewhere else, in between, nobody can see what exactly is in the data and just steal it. To not allow that, it gives you this TLS support. So it provides this, and it has this industry level, like how we have for food, medicines, FDA and all these things, approval, you have this approval as well, which allows this particular operation. So DHE and ECDHE, again, two things you do not need to know, plus need not remember as well. Only thing to remember here is that S3 provides mandatory TLS support, which is required for in-flight encryption. Then second thing is VPC endpoint. This is something you have to configure, and this is very interesting as well and widely used as well. In every project, whatever I have worked for so far, mostly it is in VPC endpoint. So what does this basically means? You work in a VPC. What exactly is a VPC? That is told to you in solutions architect, but I'll summarize for you. VPC, if you do not already know, you work in a virtual private cloud. Like I gave example already that when you're working for your company, they have given you some sort of VPN connection or whatever, so that whatever links you guys are using in your company, I might not be able to, I will not be able to access them because you are using a VPC, which means this is a very big internet. Just assume, and this is one section of the internet that your company has borrowed. That, okay, all of my things will reside here. Anybody who is using this internet, he cannot bypass and come into this, or anybody who is using this global internet, he cannot come and see anything here. So basically, not allowing outside internet is what VPC allows. Okay, now what is VPC endpoint that S3 gives? Which means so outside internet is not allowed. All of your this personal virtual private cloud. Okay, now for this, even S3 is outside, right? Technically, it does not know that S3 is inside, right? No. So let's say you have some machine learning algorithm that you're building here, and your training data resides in S3. Now, when it is traveling from S3 to this particular algorithm or your EC2 instance or wherever you're using it, it is traveling the internet. Now, we have already talked about that you have TLS support. So here, you don't have to worry about that. Anybody will come and see, oh, this is the customer name, this is the customer social security number. All of those things you do not have to worry about because of this TLS. However, here, somebody can come and see this, or anybody can come and inject into this, but we do not want that. Here in VPC, nobody from outside can come, and that includes S3. Right now, even S3 cannot come because for us, it is traveling outside internet. To not allow that, what we do is S3 provides you this VPC endpoint that S3 basically act that, okay, you are VPC, this endpoint, S3 will say, okay, I am not outside, I am here itself. Ask me whatever you want. And that's how VPC endpoint work, that you are still not going to outside internet. You are still in that VPC internet itself, so that you are sure that nothing is going outside that particular VPC. So that's what VPC endpoint provides. And it's very widely and very useful service as well. Now you have multiple VPN options as well that AWS gives, which is site-to-site VPN, direct connect. These are nothing but VPN. As I mentioned already, what are VPNs? Your company, VPC is what we use inside AWS. They have this thing. But right now, your company has their own VPC, and whatever VPN that is their VPC. Now, to make sure that AWS, you are using AWS outside this VPN, but you wanna make sure that this AWS is inside your already existing VPN. In that case, you can use this VPN options, and what it will do is basically it will treat this AWS account that you have as an extension to the existing VPN. Make sense? Okay, good. So these are the security features that we have talked about so far. Now, then we have much more detailed features related to, let's say, access control. And it basically boils down to a lot of things which we are going to talk about. First one is service control policies. And this defines you have AWS account. 1, you have AWS account. 2, right now, assume they are not AWS organization. They are separate AWS account. And here you can set service control policy that whatever is my file web console.txt or Hers demo bucket name, this can be accessed only via AWS 1. If I try to access it via here, it will not work. It will give me an error. So you can set it here, this in service control policy. Second, IAM, you should already know. If you do not, it's identity and access management. Here you define which user can use it, which group can use it, what are the policies that you can only use S3, you can only use EC2, even in S3, you can use only this bucket. All such things you can set via IAM. Now you can set bucket policies as well, that this bucket has a policy that only this group called developer can access it. You can set it directly in the bucket policies as well. And they are very similar to IAM. It's just that S3 has provided you option of providing this IAM policy directly inside S3. That's all it is. And you have bucket access control. If you want to dive deep much more into it, that this entire developer group can access it, but I do not like this one person, XYZ, whoever it is. I just don't want to specifically not allow this person. You can set it here. Object policies, this is ingrained in terms of, this is my S3 bucket called demo. It contains 10 files. If I want to set that 9 files, developers can access. 1 file they cannot. So that is my object level policy. So I write it for specifically for this object, that this object should not be allowed for developer group. Same goes for object ACL. It's basically policies were used earlier. ACL came later, but both kind of serves the same thing. It's just that one is older, one is newer. But that's how the access control works for S3. As you can see, you can set it for entire AWS account. You can set it for one user. You can set it for entire group. You can even set it for one object or one file and a lot of things. Every kind of granular detail can be managed. Now, auditing. CloudTrail logs provides you that. Here you know that, okay, from developer group, this person called XYZ access my bucket. He downloaded this particular file called webconsole.txt. All of these things are logged in CloudTrail logs, so that it's again a security mechanism. Something happened, you should know whom to blame. That's what CloudTrail allows you to do. S3 server access log, this we are going to talk about. Same goes for access analyzer for S3 later. Somebody has a question, but I don't see anything. No. Okay, then comes REST security. Now we have talked about in-flight security. Now your data, when it is already present in this S3 bucket, how does it is secured? So you can encrypt this data when it is resting in S3 as well. And these are the ways of doing it. You can use something called as customer master key, CMK. And this KMS is an already existing service called key management service. That's all it is. It's an additional service altogether, but it has good integration with all AWS services. And this service basically just whenever you hear the name KMS, it's for, oh, sorry, I am writing A. It's for encryption. Okay, now you can use this CMK, which KMS provides, or you can use application stored key as well, which is your own key. So both options are there. And this SDK is available in all of these languages that you are seeing here. Then these are the different options that KMS provides. Your S3 gives you SSC S3, SSCC, and SSC KMS. Difference, again, cost. Here, if you are using SSC S3, S3 will manage this encryption key. You do not have to even worry about anything. You just enable this. S3 will go to KMS. It will take that key. It will encrypt, decrypt your data. You will not even know that there is encryption happening. Customer provided encryption key. Let's say you are an organization who has created their own KMS kind of thing, where, like my company does, they have their own encryption keys, own way of encrypting that data, own algorithm written for encrypting that data, and blah, blah, blah. If you are somebody like that, in that case, you do not need S3 to manage it. You already have something that you are managing. In that case, you can just select this option, you provide that key, and it will take care of other things. But here you provide key. Then CMK stored in AWS KMS. This is kind of like this. Here S3 was managing. Here you have already created your own key, but inside AWS, inside KMS, and you're just telling S3, please get it from there and do encryption and decryption. Just like this. Here it is automated, here it is automated, here it is on key. So these are the different ways of server-side encryption. And this definitely you have to remember for certification, that this is 1, this is 2, this is 3. These are the 3 ways of encrypting in S3. How it works, I kind of have already talked about it, but as I have a diagram, why not show it? So how it works is you have data saved in your S3 bucket, and you have some application EC2 instance. Let's say here is some logic that here your UI is running Amazon.com. In this UI, somebody asked, what is the price of this? Or somebody asked when my product will be delivered. You go to S3 and you figure out, oh, I do not have this information because it is encrypted. Then what will happen? You will reach out for KMS with an API call with a cipher blob that, okay, I have asked for this data, which looks very gibberish to me. I'm sending it to you with this data key. Please give me that key. It will provide you that unencrypted key. Using that key, you will decrypt that data. You will see that data. You will use that data. You will show it to your users. And that's how the job is done. This I have already talked about it, that here it is automatic, here it is automatic, but if you are using your own key, then you have to write your own logic as well to go get that key, use that key, encrypt it, decrypt it, blah, blah, blah. As the name suggests, customer provided key. So obviously they are managed by customer as well. This is where everything gets very complicated. So again, this is an additional thing, which kind of partially I've already talked about it. So service control policy, it is for organization, as I gave you an example of AWS account. So it's for that. Then comes, this is called as S3 access security waterfall. Why this? I'll tell you later, but right now just understand the waterfall, like how it goes. So first is organization. Second is for IAM policy. So basically, as I mentioned, you have a lot of ways to deny something. So you can deny something at an organization level, you can deny something at a bucket level, you can deny something at a object level. So how S3 reads it? What should I deny? So it checks this first. If it passes, then it goes here. Otherwise, it will deny here itself that, okay, you cannot access it. Then it will go and check this IAM policy, and it figures out that, okay, you are not allowed to access it. It will deny it here. But here, let's say you have allowed it, but you have denied it at a bucket level. So it will deny here. Same goes for, you have access to bucket, but the file that you asked for, you're denied for that. So it will deny here. So this is how S3 sees the access. It first checks for organization level, then IAM level, then bucket level, and finally the object level. And very important thing to remember, implicit deny is default, which means wherever you have mentioned denied, it will deny that. Very simple. That works. Then explicit allow beats implicit deny, which means that here I have said that, okay, this particular person cannot access this file. He is denied. But here I have explicitly mentioned that this person, let's say, it will be confusing. So let me try it some other way. So here at the bucket level, my bucket name was demo. In my bucket policy, I have returned that a person named Harsh cannot access a file called webconsole.txt. I have implicitly denied that this person is not allowed. Okay. So it goes here, checks, and denies me. But here I have set another policy, and here I have said that anybody can access this. Here I have made that file public. Anybody can access it, and that obviously includes Harsh. And this I have set it explicitly. So in that case, it will not deny Harsh. It will say, okay, Harsh. That's why we have this waterfall. That I might make one mistake, that I have made sure that I say that everybody can access this file. But at one point of time while working on this project, I saw one file which was very important to me. And I made sure that I write another policy for it here at the object level, that no matter what, this file should be private. So in this case, as I've explicitly said that this file should be private, that I have denied everybody access to it. So no matter at what level of this waterfall, I have explicitly allowed anybody. At last, if I see that it is denied anywhere explicitly, in that case, it will bypass this rule.
Yeah, so the explicit deny at a lower level beats the explicit allow at a higher level.
Yep. So even if I have said that allowed here, but here I say it is not allowed, it will make sure that this is followed.
So the algorithm actually will go from the lower level up, isn't it, while checking? Because if it's an explicit deny at the lowest level, then that algorithm stops there, because it's either explicit allow or explicit deny at the lowest level. And then
thing is that let's say it does not go from lower, it goes from up. Why is that? Is because I might explicitly allow this file here. I have said
that should beat everything. Yeah?
Webconsole.txt file is explicitly allowed, I have said here, right? But, or take it other way, let's say I have a private bucket. So anything I put inside this bucket is private to me, and does not matter here or here. Somewhere I have said that this particular file is public, which means I have explicitly allowed it, right?
Yeah, so at the highest level is explicitly allowed. And then
does not matter if it was at highest level. Let's say I've explicitly allowed it here.
Okay.
Okay. But at one of them, I have returned that I explicitly denied. In that case, no matter if I have said somewhere that this file can be allowed, this can be accessed, anywhere I have returned that this file is denied, it will give preference to the deny command rather than allow command. So it does not matter, it goes from above to below or below to above. It first checks for this, whether something is explicitly denied. We have this responsibility. That's why I gave you that example. And firstly, in practical life, this is not much used. Again, my experience, it could be different from someone else. It's not much used. Whenever what I have used it for this is, let's say initially I made something very general, allowed to everyone. But later on, for let's say I have 10,000 file, in that 10,000 file, I am fine with them being accessed by somebody else. Or out of those 10,000 files, I know that 999 files, they can be left unencrypted. I do not mind. But at one point of time, I went and uploaded a file which contained secure information like social security number, their payment methods, and whatever, lot of information related to that. I have that uploaded one file. So here, what I have done practically is, here I want to explicitly deny it. So no matter anybody in my team make that mistake of explicitly allowing it anywhere, my job was to make sure that this file cannot be accessed or it should not be left unencrypted for anybody. So I made sure that this file is explicitly denied it. So no matter at what stage somebody has returned that this file should be allowed. If I have written anywhere that this is explicitly denied, it will be denied. That's why I mentioned this is a very rare scenario that you want to dive deep into this very fine grained controls. A lot of times, at least in my company, we have a separate team taking care of it all together. But at your personal developer level or engineer level, you might have some sort of things that you need to take care of. And that's where you can use this, deny it explicitly somewhere. Out of all this EC2 instances which are taking data from S3, which EC2 instance got which data, that is called as your server access logging. Then CloudWatch alarms, you can put some alarms as well, like, okay, whenever more than 10,000 requests are made to this particular folder, alert me, something of this sort. Lot of, again, logic depends entirely on you, but CloudWatch alarms allow you to set this kind of alerts. And auditing access analyzer is for S3, like who has access to what. As I mentioned, we have this very complex rule of setting this explicit allow, deny. Nobody can, or not nobody is a very strong word, but it's very difficult to figure out right in the first place. So what you do, you keep on auditing who is doing what, and you figure out, oh, this file should not have been accessed, but it was accessed. So you do that using access analyzer, and later on put some more security or granular control over that particular file, bucket, or whatever. So for that, you have access analyzer. Then the last thing that you have is object protection. Another security layer that you want to make sure that this file is not deleted even mistakenly by anybody. So let's say somebody is trying to delete entire bucket. They can easily, as you see, we have CLI to take care of. You just put RM, RF, and it will force delete everything in that bucket. But let's say you have some file that needs protection. So what you can use worm there, which means you specifically log that file, that, okay, this is one file which needs to be logged. You log that file. So nobody can do anything to that file unless obviously they do some sort of multi-factor authentication and things like that. So here there is a multi-factor authentication. Without this file will not be deleted. Another thing is versioning. Just like how you have versioning in Git, something happens to this version, you have another version, blah, blah, blah. All versions are kept intact. Just have to enable the versioning. Replication, even if something happens to file in one region, you are already replicating in multiple regions. So you have multiple redundant copies of this available. Oh, this is an interesting one, which is cross-region replication with versioning. So how it works is you have multiple versions of a file, and you can set rules that I want the latest version, only latest version, to be copied in another region, because that's what makes sense to me. I do not want all this previous version 3, 2, 1 unnecessary to keep on accumulating cost for me. So it will make sure that it sends only one copy and not all 4. So that covers a lot of security things that you can do with S3. So we talked about firstly TLS, which gives you the in-flight encryption. Then we talked about how you use S3 inside your VPC by using VPC endpoints. Then we saw that if you have your own company's VPC or VPN already in place, how you can connect AWS's VPN with that and make it kind of an extension to the existing VPN, so that again S3 works inside your company network only and nowhere else. Same, we saw a lot of access control, bucket level, object level, and who, just to keep on audit on who is accessing what they are accessing, you can do a lot of auditing as well. So then there are important stuff that we saw related to encryption, which is SSE S3, SSE KMS, and SSE customer managed. So remember, there are three kinds of encryption that REST encryption that S3 provides. Remember the names of them. Then we saw that security waterfall. So first you can control from at the organization level, then IAM level, then bucket level, then finally at the object level. And then we saw all the logging related things, how you can create CloudWatch alarm, and you can keep on monitoring using the access analyzer. And finally, you saw how you lock a file, how you enable multi-factor authentication delete, cross-region replication can be enabled along with versioning. So I think that covers S3. Yep, it does. So that it can help you there as well. Anyway, so somebody asked this already, but I have already covered it here in the slides as well, that virtually there is no hard limit to how much a data can, a bucket can hold basically. As you can see this image as well, it shows you have this bucket and it can virtually store all the data you have in the world. So there is no as such limit which is there in S3 on how much data you can store in S3. However, as I mentioned already, that a single object, it cannot be more than 5 terabyte. And a single put operation, it can hold up to 5 gigabytes, and that you use when you're using multi-part uploads. So that's about it. What's next? Now, can S3 be used in architectures that require security compliance? We have already seen that a lot of security things are there in S3. So S3 is definitely ideal for security compliance standard, even like HIPAA, which is kind of stringent. Now, it can allow you to implement in-flight as well as at-rest encryption. We saw both. Now, you have excellent data archiving capabilities as well in Glacier and Glacier Deep Archive. And there's something very unique called government cloud regions, which is available for ITAR compliance or ITAR compliance. What basically this means is, let's say you are working for some project which is NASA has given it to you, some portion of their work, or US Defense has given it to you. In that case, there is a special requirement that it needs to follow ITAR compliance, that your server should be in the same country and it should not have, it's basically much more stringent than your usual regions and availability zones. So S3 does have a government cloud region as well. So when you're working on this kind of project, instead of choosing US East 1, US East 2, US West, blah, blah, whatever, you can select this government cloud region as well. Now, as I mentioned, I just wanted to give you a feel of what exactly will be asked in the examination. So this is one simulated exam question that I put here, and I want you guys to figure out how would you go.
Let's have a quick quiz question, guys. And the question is, what is the process of collection and storing data from various sources for analysis and decision making called? Option A, data aggregation. Option B, data collection. Option C, data filtering. And option D, data analysis. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
About answering this. So before, please get used to it, because these are the kind of questions that AWS ask in their certification, which are very big scenarios. So firstly, you need to be able to read that quickly, then figure out what is the correct answers. Now, how do we figure that out? All the AWS questions, they follow a certain pattern that they give you a lot of rubbish information, which is not useful to you. You should be in a position, that's why you have mock questions. So you should go through the mock questions and create this habit where you are able to figure out or filter what is important to you. So here I have highlighted what is important to us. So here it has this application which stores the data in S3 before deleting it from the table. All the things about DynamoDB, they are useless to you, even though for entire application, it holds sense, but here it is useless. This question is related to S3. The S3 related information here is that you store data in S3 before deleting it from the table. Now, what they want, currently everything is S3 standard. What they want to move data from S3 standard to S3 infrequent access automatically. Again, a keyword. After 3 months, Glacier Deep Archive, after additional 3 months, and after the data is 5 years old, it should be automatically deleted. And the major thing, you would usually find it at the last. What is the correct solution, which is the least development effort? Because over here, you will find that there are certain things like, for example, this one. This is also true. You can do that, but it requires development effort. So this is not a correct answer. Definitely. Over here, but I don't want you to do this in your examination. I want you to be able to read the question, options, and eliminate what does not make sense first. So over here, it says implement a custom Lambda function. Again, you are talking about creating something custom code basically. That cannot be least development effort. It definitely requires some development effort. So this goes away. Then creating a cron activated AWS CLI script on an always running EC2 instance that changes an object storage class based on the object's last modified date. It is entirely true. Even if you do this, this works. It will do the job. However, here you're creating a CLI script. You're keeping an EC2 instance running for that. And you are creating some logic that bases the modified date, it will figure out and change it. So what is already available to you, it is asking you to build that solution. They don't want that as well. So this goes away. And this one goes away as well. Change all objects in S3 bucket to use the intelligent tiering class. Add a lifecycle policy to delete objects after creation. It is also true. You can do that. But here they have specifically mentioned that you want to move it after 3 months, after 5 years old. Intelligent tiering, it will do it automatically by itself. It may move it in 2 months. It may move it after 4 months. Here, they have specifically mentioned that they want to move it after 3 months. So in that case, the only correct option is to move it using life cycle policies. So these are the kind of questions you can expect in your examination as well. And the last thing, we are done with S3. Let me see if I can give this demo. We do not have time for demos, but I want to give this. So over here, what you are seeing is basically we'll be programmatically utilizing data which is present in S3. And there are a lot of components to it. Let me kind of clarify what we are doing here first. Somebody want to volunteer and guess what exactly we are doing here? If not, I'll definitely explain. No problem, I'll do it. So here, what we are going to do in this particular demo is that we'll work through completing a filtering function that I have already created for a simple web application. So there is one web application that I have created that displays user data. Now, in order to filter this user data, we are going to accomplish this by editing a Lambda function. Again, I have already returned that. You do not need to know about that right now. And we are going to use something called as S3 select. So we are going to write the necessary code to utilize something called as S3 select. Now, the development team, assume this is a scenario, a development team at your company is working on a proof of concept for a directory of all the employees which are present in the company. Now, they have a very basic web application working, but they just want to add a filtering feature to this application. And they have run into problems attempting to get S3 select working to implement this. And they have requested for your assistance. They have provided you with a dev environment with an S3 host web frontend, API gateway, as you can see here, Lambda function, and another S3 bucket which contains the data for the application. You have all these things that you are seeing on your screen. What you need to do is you need to update this Lambda function so that it has the logic to filter the data and return the results. So that's what we are going to do. So first thing that we are going to do is we are going to go to our, this is not working, should work. Oh yeah, I think I got it. S3 public random users.js. API gateway. Here it is working. Why it is not working there? This API gateway, blah, 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 blah. Click on deploy or not? I think I did. Oh yeah, it is working. Hey, no, it's not. Sorry guys, just a minute. Let me figure out. Let's try Spain. Anyway, there seems to be some problem with the code, which I'll figure out later. But the intent here was that you can use S3 select to basically filter out the data. How it is doing that? It does that using this where clause that you are seeing here, that this is the expression you provided select all from S3 object. S3 object is nothing but the files that you have as S3 object where you are using a filter string. And filter string is what? Basically, whatever you are getting from here, the key value. If my name is Anna, I provide that here dynamically. If country is Spain, it comes here. And basis that, it filters here. And this is the logic for that. Oh, yeah, it worked. There's something wrong with it. So for example, as you can see, overall, I have 1500 users. If I provided age equals to 46, I have user group of 38, which means it is working for age. Let's see, state, country, I'll give Spain. It is working for that as well. These are all the users of Spain. State, let's see, Galicia. Hey, sorry, state as well is working. What is not working then? Name itself says, yep, it is working for last name as well. There are two people who has the last name says, and just try one more time. Eduardo. Hey, it's working now. I think I did not deploy that time. So yeah, this is your demo on using S3 select. It tells you the functionality of S3 select. Right now, you do not know how to code or does not know what exactly is Lambda function. You do not need to worry about that. All you need to understand here is what is S3 select now. The next portion of this is your databases, and we are going to look at databases. And databases, they follow or come under this data preparation in the steps for success, as I mentioned. So far, we have talked about data collection. We use S3 for collecting our data. Now we have moved on to the data preparation. What exactly we do when we are dealing with the databases. Now, when it comes to databases, you have relational databases, you have Aurora, which we are going to talk about. It's a proprietary service of AWS, and it's quite good. And we are going to talk about DynamoDB, which is a NoSQL database in the cloud. And then we are going to talk about Elasticache, which is an in-memory engine. So before starting that, we are going to start from very scratch. We are going to, I know a lot of people know already what is a relational databases, what are key value databases, but we are still going to touch base on that. So this one, which one is this example of? Quickly, you guys know this, I know.
I think SQL database kind of things, it is their relations.
Yep, this is an example of a relational database over here. this is how it works. You have normalization in place. You have this joins, you have queries and things like that. And this is the most familiar databases that everybody, no matter what they do, they have encountered or worked with this kind of databases at least once in their life. So that's an example of relational database. Then you have this kind of tables with rows and columns. You can have joins with the other tables. You can have a foreign key and a lot of indexes and whatnot. And in terms of engines that AWS supports inside cloud, these are the examples of it. First one is Aurora. Second one is MySQL, MariaDB, PostgreSQL, Oracle, SQL Server, and Redshift. Redshift probably is not a database as such. It's a data warehouse, but we are going to talk about that separately later. And that's a big portion of this examination as well. But do remember all these things. You definitely have to remember this. What are the relational databases that are present in the cloud?
Transaction, for example, what happens at the ATM and stuff like that. So
exactly. So it's for those kind of use cases. It was first used by banking industry, and that's why this name got stuck, which is transaction. You make transactions in bank, and that's why this name came from there as well. Right now, you use online transaction processing everywhere in your Amazon.com and a lot of e-commerce. Everywhere it's quite prevalent. And the relational databases that AWS has, it is good for this kind of transactions, which is on OLTP use cases. Of what exactly is that? You use it for rapid transactions. It should have atomicity, or basically it should follow that ACID principle, and it allows you to protect your data through transaction rollback as well. You already gave the example of ATM and stuff, which means that you do not want this situation ever that you got the message from your ATM that, okay, here is $500 credited from your account, but you never got that money. But still that 500 got deducted because of whatever issue they got in between. It said that it was able to give you that 500, but actually you never got that 500. Same goes for e-commerce. Let's say you purchase some product on Amazon. They said that, okay, we have deducted this much, but the order was never confirmed. So that happens. The OLTP databases are good for this OLTP kind of transaction where you want a rollback. If something goes wrong somewhere in between, you don't want anything to happen. You don't want one person to say that, okay, I have sent money, but the other person never received it. So it's ideal for low latency application as well. As I mentioned, banking industry, online transactions, we use OLTP. Where exactly we use this?
Business decisions.
Business intelligence, basically decision support.
Exactly. What exactly is the technology which allows it to be used for larger queries of business intelligence decision? That you mentioned, what is your part? How you are exactly making sure that database or data warehouses are different from databases? In terms of tech stack, what exactly they have done that allows you to create this complex query? So let me tell you that. So over here, we talked about OLTP, and if you have not noticed it, I have already mentioned in my slides, which is they follow this row-based format, which means all of your data looks like this. Engine ID 0 is for Aurora. Engine ID 1 is for MySQL. That's how they work. The databases, all this MySQL, MariaDB, Postgres, they all work like this. Even Redshift works like this, but Redshift supports both use cases, row-based as well as columnar-based. And that's what data warehouses do differently from your databases. They do not save their data in a row-based fashion. Instead, they save it in a column-based fashion, which allows for easier querying. And that's the major change that you will see when you're going from databases to data warehouses. And Redshift is a good example of that in AWS. So Redshift is a data warehouse in the cloud. So what are the use cases? As you already mentioned, for business intelligence or creating some sort of, so basically for an example, let's say you are a global company. Take the example of Amazon itself. Amazon probably wanna know how exactly AWS is doing in terms of profits in, let's say, this Asia Pacific region. So they just want you guys, if you are, let's say, a business intelligence engineer working at Amazon, they want you to give them reports or visualization showing how we are doing in terms of profit in this particular region. So it will require a lot of things like, okay, I want to collect this entire data. Out of that data, I want to filter this particular region. In that region, I want to have multiple joins with other tables which I have, which takes all this other data or whatever I do business there, and finally give me the consolidated or aggregated report. So for this kind of use cases, you are going to use OLAP, and OLAP is present in Redshift in AWS. So basically, it allows you to manage large amounts of data and handle complex long-running query operations as well. Now, the next thing that we are going to see is key value base, and key value, as you can see here, this is how they are. You have a key, for an example, favorite superhero. This is my key, and that is Iron Man. That is the value. That's all they are. No SQL databases or key value based databases. That's how they store data. Key value. You have, these are the examples that you have. You have Elasticache. In Elasticache as well, you can have this kind of nesting. So Memcached and Redis, these are the two things which are present in AWS. Then you have DynamoDB, which is the most prevalent OLTP service that you will find a lot of startups and even AWS using. It's quite good. One of my top 5 services by AWS. Then you have document related, you have DynamoDB again. You can use it for storing documents as well. And then you have a separate thing called DocumentDB, which is kind of equivalent to MongoDB. And finally, the last databases that you have in AWS is Neptune. And that is an example of a graph database. And yeah, let's quickly read this. So what exactly they are, the NoSQL or the key value base, this one, Elasticache, what exactly they are? It's a memory store, which means all of your data, instead of being saved it in some solid state drive or hard disk drive, it is saved in memory. And that's why it is very fast, but also very fragile. Once your session is over, you will lose that data. So your memory access, it's much faster than your disk access. That's what gives it speed. But it comes at the cost of volatile. It is quite volatile. Now, all of data can be lost if there is a hardware failure because it is in memory. Redis does allow disk persistent, but when you're persisting data, you lose speed. Elasticache is nothing. They have just created this wrapper on top of this industry-wide used services, which are Memcached and Redis. That's all. Now, DynamoDB, on the other hand, it's a key value based database. And what are the benefits of it? It is quite flexible, and at the same time, it is inflexible as well. And that's what gives it its power as well. So it can be used in a key value pair kind of fashion or a document style as well. That's why you will find it here in the key value and document as well. Oh, actually, Redis and Memcached are key value. Sorry, my bad. They store data in key value fashion. Now, over here, your data model, it dictates the style. Your table structure, it can be changed after creation. For an example, when you have this kind of table, I don't have an example, but let me write it down. So let's say I have this kind of table, name, address, zip code, and SSN number. Okay. In relational databases, there is a thing that I need to provide name. Harsh, Jai Bharti, lower your hand, please. I need to provide the address of Harsh. I need to provide his zip code as well as his social security number. But because this is very strict in terms of schema. If you have defined that my table contains this so many columns, then you have to provide the data for all of them. But for your key value databases like DynamoDB, they are quite flexible. If you have the name Harsh, provide it. If you don't have Harsh's address, don't provide it. If you have his zip code provided, social security number, you can leave it. So it's not very strict when it comes to schema, and that's what gives its flexibility as well. And as I mentioned, you have DynamoDB, you can use it for document style as well, but they have a separate service altogether for that, which is DocumentDB. Why not use that? So ideally, you should use DocumentDB. So both of them, they are great for documents. You can save structured or semi-structured document, which are of JSON, YAML format. Your metadata, it is stored along with the document records, and you can hit critical scale failures when you're dealing with DocumentDB, but this we don't have to discuss at this point of time. We are going to see it. And finally, you have your graph. Now, graph databases, and they are the most interesting ones. So this is how they work. This is you have this kind of structure that your data is structured as nodes, which are connected with edges, and your edges are shared attribute between nodes, and they can reveal hidden patterns in your data. And very common example of that is your Facebook, how they started this. You might know this, or how Amazon uses it as you might like this product, or your friends bought this product. People usually bought this product together. They do it using this graph databases. So your data, it is stored in this kind of fashion. You have name, location, and job of that particular person. And you have another person with all the same information. How they are connected to each other, that is your edge. The data is node. Now, using this, you can reveal some patterns in your data, which, for example, how Facebook does it. That, okay, Harsh knows this X person, this X person's knows Y person. Harsh might know this Z person as well. So that's how they do it. They are able to figure out all of this hidden patterns because of this graph databases. So yeah, that's pretty much it. This is what we are going to cover in the next session, which is your database engine database. So we talked about what we are going to read in relational databases. You have row-based databases, you have columnar databases. We saw what is OLTP, what is OLAP. Then we'll see what is key value pair and what are the benefits of it. They are much more faster than your relational databases. However, they are potentially a little bit fragile because they do not have that normalization, things like that. And that's what kind of makes them a little bit inflexible, because there are obviously demerits of that as well. It gives you speed, it gives you flexibility, but there are some benefits of relational databases, and that's why they are widely used even after what, 50, 60 years they are into existence. Now you have documents as well. So documents can store your structured or semi-structured data. Usually they are JSON format, but it can be YAML as well. And finally, we saw what exactly are graph databases, and the graph database name in AWS is called Neptune. And what it does, it allows you to, they're hyper relational. You are able to figure out all this relation between your data, and it allows you to figure out these patterns, which you might probably not notice when you're storing it in a structured database or a NoSQL database as well. So it's good for this pattern recognition and analysis as well. There's relational databases that we are going to cover. And over here, we are going to see that the relational database, or RDS, that's the name of the service, RDS, that is a managed service. So we are going to talk about what exactly are managed services. Second, what exactly are second level services? RDS is a second level service. Then it does not have no operating system access. So here we are going to see what are the alternatives. Then how does it support disaster recovery? You already know that your databases have the disaster recovery option. And finally, we are going to summarize whatever we covered in RDS. So the first thing, it is a managed service, which means a lot of heavy lifting is already taken care by AWS. So over here, as you already asked, where exactly is your data saved? So it is saved in the same place when you're using MySQL, MariaDB, PostgreSQL, SQL Server, Oracle. It's stored there itself. It's not stored in S3. So that's the answer to that. Now, what they do, you are still using it. But what they have done is they have created this RDS wrapper on top of this services. And what it does, they have given you this management API calls that gives you a little bit more functionality than you get using MySQL, MariaDB, PostgreSQL. That's one. Then you have database instance management as well. And we are going to talk about it soon. What exactly are instances? So as I mentioned, it's a second level service. What basically that means is that they have not created a new thing altogether or inventing a whole new thing. They have just used an existing service, which they already had, and they have created this wrapper on top of it. So if you just type this command, dig plus no all, blah, 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 whatever, this is the name of your RDS instance, you will get all this information. And this will basically tell you that you are using an EC2 instance. Along with that EC2 instance, you are using Route 53, which is another service in AWS. And using that, you are using Elastic Block Store or EBS. And finally, you are using somewhere S3 as well. So where exactly is your data saved? Elastic Block Store. How it is running, where exactly it is running? In EC2 instance. I mentioned that you have access to this API calls. How that API call works? Using this Route 53. Where exactly your backups are saved? They are saved in S3. So it is a second-hand service, or that's what it means, that these are all the existing services that AWS has already created, and they have just clubbed them together to create RDS. So RDS is nothing but a combination of all these things that you are seeing over here. Make sense? What is second level service? So Route 53, we have not talked about it, but Route 53 is a service basically which is for DNS, domain name system. And basically it gives you what do you say? An IP address, let's consider that, or a domain name like google.com, facebook.com. These are all domain name. And google.com, you understand. Your computer does not understand google.com. Google.com might have some IP address. I don't know if it is the correct address, but let's say it is this address, 192.168.74.89. This is the IP address where Google is hosted. You know google.com, your computer does not. It knows this IP address. What exactly a DNS service does? It takes this value from you, it interprets what exactly this value means, and it will figure out this, and it will give you or take you here, and then you can use google.com. So that's the purpose of Route 53. So over here, as I mentioned, it uses EC2 instance. An EC2 instance will give you this kind of IP address or a domain name. But this domain name is not useful for me. I should know what exactly this domain name takes me to. So it takes me this RDS cluster. You can see one domain name here. This EC2, there is a domain name here. And Route 53 takes care that, okay, whenever somebody reaches out here, they are basically asking to reach this EC2 instance. So what exactly is an instance? Instance is nothing but a server. That's all an instance is. It's a virtual server present in the cloud. That's where somebody came, logged into this EC2 instance, and they have, let's say, installed PostgreSQL. That's what you do when you are using it in your local. You go download PostgreSQL, You download and install it in your local, and that's how you're able to use Postgres, right? Same thing. You have this server, nothing but a virtual computer present in the cloud. You went inside it, SSH inside it, you installed Postgres in it. And that's how this is now your Postgres instance. But here AWS has taken care of this. You don't have to install this. AWS has already installed it along with other things as well. Whatever you use, it's already installed. You just have to use it. Now, where exactly is your data stored? So your data is stored in EBS volumes. What are EBS volume? Again, nothing but they are just your solid state drives or hard disk drives. Depending on your choice, they are one of this. So this is where your data is stored. This is how you go to that data store. And what AWS has done is they have just created this database engine for you to abstract all of these things and provide you with some additional functionalities. Now, as it is a managed service and as it is a second level service, you cannot go inside that operating system and change a lot of things. Okay, because in EC2 instance, you can go inside an EC2 instance, change whatever you want. It's entirely up to you. You want to do update, you want to patch something, you want to do anything related to your EC2 instance, you can do with it. But for RDS, as it's a second level service, it is not allowed. But that does not mean that some necessary operations which are required using operating system are not there. For that, AWS has created something called as parameter group and option groups. And this is very important for your examination as well. So over here in parameter group, you want to change something inside the operating system. What you do, you provide some values over here, like how I want logging to be enabled, whether I want it 1 minute, 5 minutes, how refined I want my logging. If you want to change all that, you don't have to go to operating system. They provide you this parameter group. You can change its value. What exactly it is? They just give you, lot of options. You just have to go and configure its value. Let's say currently it was 30, but that does not work for you. You just set it to 60. Same goes for memory management. Inside operating system, you can do like a lot of things. If you have installed, let's say if you're using Windows, I have done it in, what do? You use some sort of virtual box or something of that sort. And over there, you have to do memory management. You are asking your operating system to not give entire 16 GB of my memory to Windows. Give 8 GB or 4 GB to my Ubuntu operating system. So you do that memory management. Same thing you can do over here as well using parameter group. And last thing is other engine variables. There are a lot of other variables that you can set for PostgreSQL or MySQL. You might have noticed that it gives you a lot of configuration option. If you have worked with databases, how do you provide those configuration option in AWS, in RDS, is using this parameter group. Now, there is another group called option group. Over here, if you have some plugins, you can enable or disable that plugin. You can manage that plugin settings. And this option group, there's just one exception that you have to remember is that PostgreSQL just has this. It does not have this. This is pretty simple thing, which is disaster recovery, how that works in the cloud. Similarly, what you're used to already, highly available services, you might have, definitely be using HH architecture, which is highly available. You have one primary instance and then you have another secondary instance. This one, as you can see, it is present in US West 2A. This one is present in US West 2B, which means, let's say it is present in Oregon. And this one is present in, let's say, Nashville. So basically, there are two different data centers. If something happens, there is an earthquake in Oregon, what exactly will happen? You will not lose your data. It will just change it right now at initial level. When everything is fine, this one will be sleeping. As you can see, yes, I have put here. This one will be sleeping. Nothing will happen here. And you'll just keep on doing the block level replication. one block keep on going to this secondary storage. And something happens to your primary instance. Let's say there was a volcano eruption. Right now, Oregon does not exist. In that case, all of your data is present in your secondary instance, and RDS automatically will make sure that it will wake this instance up that, okay, enough sleeping, wake up now. And it will make this one primary now. As you can see over here, this one is primary now. And in the meantime, it will automatically, whatever was the failure, it will be for a particular time period. In half an hour, in 1 hour, in 1 day, or in a week, they will make sure whatever was the problem, they will figure it out, rectify it, and you will have this one as well. Only change would be that now this one would become secondary and this one would be sleeping. That's the entire concept of disaster recovery in RDS. Certification about RDS, it's a managed service. And what exactly are managed services? Which is it runs and manages multiple databases engines without you to worry about. You just go to RDS, you say that I want MySQL database. It will give you MySQL database. And backend, it requires EC2 instance. It will automatically create. It will do all the updates in EC2 instance. It will do all the patching in EC2 instance. It will do anything, virus or antivirus update or any sort of things which are required here in this operating system. They will do all of that. Same goes for your EBS volumes. Your data is exactly stored here. So they will create this EBS volumes as well. They will make sure your data is stored here. If you are using multi-AZ architecture, it will copy this data from one primary instance to the second instance without you to worry about it. They will do all of that. They'll take care of the disaster recovery as well. And if there are some changes that you want related to operating system, which is rare, they give you a lot of things, even though it is a managed service. But let's say you are a person who is quite tech savvy and he wanna have some sort of control. To get that control, you can use that parameter and option groups. And I've already specified where you use parameter, where you used option groups. This one, you have to just touch base at a very high level overview. You do not have to dive deep into Neptune or graph databases at all. So I'll try to cover it quickly. So we are going to see what exactly are graph structure. What are the interfaces language that Neptune uses? And there is a language called RDF, which we are going to see what exactly is that, how it is different to RDS, and where exactly we use graphs for. And finally, we'll summarize everything that we have covered here. The data is whatever data you have. It is present inside nodes, and these nodes are connected using this edges. That's the whole concept of databases. They are very tricky. They are very complex. But the theory of that is pretty simple, that this is how they work. You have large amounts of data. You just need to define the data. Using graph databases is pretty simple. But creating the graph database or the graph data set initially, it's a one-time effort. It's a great effort. It's like literally took me 2 months just to create proper appropriate data for my use case, which was fraud detection. So basically my company that I was working for, the client that I was working for, it was an Indonesian bank, and they had their hands into everything. They were primarily a bank, but they had a telecom service as well. They own a lot of retail stores. They had basically all sorts of things, whatever everyday thing, gas connection, retail things, phone connection, Wi-Fi connection, everything. They were owned by that particular bank itself. And that bank wanted us to figure out, tell me who can be my potential fraudulent customers using graph databases. So what we did, we took all of this data, which was a usual data from them, which was all this different. It was basically SQL structured data that they have given to us, and somewhat few non-structured data as well, which was JSON files. And our job was to convert into graph database. How do you do that? You come to Neptune, it has a certain format that you have to say, okay, this is a node. Firstly, you have to tell what is the node, what are the edges, how this data is connected to it. It does not figure it out automatically. You initially as a user have to provide this input. After that, it uses this two interface languages. This one, Apache Tinkerpop Gremlin, is an open source version. It's free for use and it's quite simple as well. This is what I used initially. This one I found a little bit tricky. So this one, here you have this kind of structure, which is you define a property. What exactly is a property? So node, the node thing that we mentioned already, in this particular language, you call the same thing property. What is the interface? You use WebSocket. If you're not aware, you have REST APIs, you have WebSockets. So this one uses WebSocket. And W3C, this one uses REST API. The query pattern here, this one is little difficult, which is traversal. Again, you do not know this because just like SQL is a language, this traversal is another language altogether. Obviously, we are not going to teach that. But here, the thing is that this is little bit difficult over here, the first step. But finally, the query, you can do it in SQL here. But over here, initial thing is pretty easy to set, which is in terms of property. But the query pattern is a little bit difficult. So both have their own advantages and disadvantages. All you need to know for the certification is that Neptune is a graph database. Then you need to know what exactly are graph databases. When you're using Neptune or when you're using graph databases, what are the languages that it supports? So for example, when you use relational databases, already SQL comes to mind, that you are going to be querying data using SQL. With your graph databases, you should know there are two languages. One is Apache Tinkerpop Gremlin, and second one is W3C. So basically, this is how the RDF graph structure works. You define the same thing, node, data, edges. You provide here, this is your edge that you are trying to find out where exactly this person lives. And this is one example of how you define that query. So g.v has name, location, blah, blah, blah. Okay, and you provide this kind of query and it gives you this result. And in SQL, everybody knows, same thing, you will write it like this. As you can see, this one, obviously, if you're not familiar, you will find problem for few days that writing query this way is not very intuitive. This one, we are already used to using it. Both gives the same information, but again, the pattern of writing is like learning a new language altogether. So that's all Neptune is. It's a graph databases. It supports two languages, which is Apache Tinkerpop Gremlin, and second one is your W3C. Now, how do you compare it to relational databases? They are both fully managed services. We talked about already what are managed services. They both have this parameter option groups that you can go ahead and set the internal settings. Both supports multi-AZ deployment. That disaster recovery is already there. There is instance monitoring. So some AWS has already in place that, okay, so whatever reason this instance is not working, you will be getting the health reports. Both support this, and both support snapshots and backups as well. Now, what exactly do we use graphs for? So whenever you want to have some sort of pattern recognition. So for an example, you might have seen all these movies where somebody is trying to crack a code. You have this encryption key, or like you might have seen that a lot of World War related movies, like Imitation Game is a popular example, where they had a huge code which they wanted to solve. And if they had graph databases that time, it would have been very easy. Obviously, they did not have, so they created their own algorithm. And that's how they were able to recognize this pattern that, okay, this is a particular pattern which they are using to send that message. It would have figured it out and you might be able to crack that code. Same thing you can do over here as well for security purposes like fraud detection or any sort of other security related use cases. Social media, as I already mentioned, it's heavily used in social media and your e-commerce. People who you might know, people similar to you have purchased this and things like that. All of those things are done using graph databases, and they are heavily used in science as well. So for an example, all this COVID-19 vaccination, or this companies that they are working on DNA sequencing, they are trying to take DNA from monkey and put it into some animal and change their characteristics and all these things. It has a lot of different patterns that they want to not rectify, they want to analyze or figure out. And basically that's why they use graph databases as well. That's why it's heavily used in scientific modeling. So these are the use cases of Neptune. And yeah, with this, we have covered Neptune and graph databases as well. For your certification, you just have to remember that Neptune support this node, data, and edges kind of architecture. Supported interface languages are Gremlin and SparkQL. Or basically, they are exactly just like SQL, but they are called SparkQL. Now, here it has this format which is similar to your node data edges, which is triple structure defined format, which is called as RDF, Resource Description Framework. And how it is similar to RDS, we have seen that as well. So yeah, with this, we are done with this as well. After a break, now we are going to talk about document DB. Before that, if you have one question, I can take one or two questions. Okay, the next one is your document DB, and it's pretty simple. We are going to see what exactly it is, what are the features of it, how it is useful, and just summarize what we saw. So document DB, again, a key value kind of store. And what exactly do you store here? Entire document, like you have a huge file like Wikipedia data and something of that sort. So for an example, this is a document about document DB. Over here, we are just listing the features of document DB. So these are the features that it supports. So it is MongoDB compatible, just like other services. It is fully managed as well, that you don't have to worry about the connection or installing it, patching, updates, or anything of that sort. Disaster recovery and read performance, a lot of the things are taken care by AWS itself. That's why they call it fully managed service. Now the storage of it is auto scaling, which means whenever you need it, you just are using 10 kilobytes of data, you upload that much data, and that's it. If you upload it like 10 GB of data, it will automatically scale to handle this much data as well. So scaling is auto scale basically, and it does support JSON indexing as well to allow for some sort of quicker returns of your documents. And obviously it is MongoDB compatible, that how you are used to use you have already used MongoDB. It works in the similar fashion, just like RDS, as I mentioned, it's fully managed, it scales upward, and you're able to index the JSON data structure as well. So these are some of the features of document DB. Majorly, as I mentioned, when you use DynamoDB for storing simple key value pairs like favorite superhero, the name of the superhero, name of that person, address, the actual address, this kind of data. For document DB, you upload entire data files, like you have a huge CSV file or huge text file. You just want to keep a dump of it in a document style. You put it in the document DB. How exactly it is useful? So like your data, social media data, it is stored in MongoDB. So Facebook, it uses MongoDB to store your data. It stores in this kind of fashion that, okay, this is name of this person, blah, blah, blah. Then what is the relationship status? It will save that relationship status, and so on and so forth. Your entire profile, it would be stored in this kind of a JSON file, and they will put it into document DB. So that's one example of how you, or where exactly you would use document DB. If you want to have an object catalog, just like how Amazon would store their products, that okay, this is this product A, this product description, this product ASIN, this product SKU, country of origin, ingredients, description, where exactly are the images stored. Everything about that product will be stored in just one document itself. And finally, content management systems. You can save it, entire content as well. The blog post, entire blog post content, you can save it in document DB. So these are some of the use cases of document DB. And yeah, that covers what exactly we wanted to cover about document DB. It's a document store database management system. Features of it are, it is MongoDB compatible, it has auto scale storage, and it allows the JSON indexing as well. How exactly it is useful? You can save your content management systems, you can have entire social media profiles, you can save the object metadata as well in the document DB. And the final section of databases is serverless options. So AWS has all of these options that we have seen. They have some sort of servers somewhere in the background. Servers are running. AWS supports some serverless database offering as well. And we have already seen one, which is S3 Select. You use S3. S3 Select is a serverless offering built on top of that, but there are actually no servers. You don't pay for those servers as well. So it's entirely serverless. You just pay for whatever queries you're sending it to it. Same goes for Athena. Whatever data you have it in S3, you can filter this data. You can query this data directly from Athena itself. Again, there are no servers, so you do not pay 24/7 cost. You just pay by the queries. Same goes for DynamoDB. DynamoDB is a serverless offering. And then there is one thing. Aurora is not serverless. It has its servers in RDS. However, the extension of Aurora they have created calling Aurora serverless as well. So you basically, why they have created it? So you already are using PostgreSQL, MariaDB, MySQL. They want to give you some sort of incentive to use Amazon Aurora, which is a similar database that AWS has created. And it has its own benefits as well. And another benefit they wanted to give you of switching from your usual databases, which are MySQL, PostgreSQL, MariaDB and all, they wanted to give you another incentive. And that's why they created this service, Aurora Serverless. So let's quickly dive deep and see what exactly are this. S3 Select, we have already seen that S3, you have data present. In our data, we had 3 files. Every file was a JSON file, and each file contained 500 user information with their image, their name, country, age, and few other parameters. We had this 3 files in S3. Now, if I'm not using S3, if I'm using Athena, what will happen? I'll go read this entire 1500 records. Okay, so if you're using Athena, what will happen? You can use Athena to query this data as well. It's just that it will load this entire 1500 record in its memory. Then it will filter for age equals to 45, and it will give you those 38 records that we saw. But we wanted to save some money, and that's why we use S3 Select. So S3 Select over here, it will not read entire 1500 files. As it is already present in S3, it notes that I just have to read this 38 files. So here, instead of 1500, we ended up selecting only 38. So these are 2 serverless offerings. Both are used to query the data in S3. You should definitely know when to use what. So S3 Select is not a replacement of Athena. Okay. But it's a good service whenever you have this kind of requirement where you want to filter a very specific data of that particular object or of that particular bucket. Now, DynamoDB, I have already mentioned that it's a fully managed serverless database, which is of key value type present in the cloud. Finally, we have serverless, Aurora Serverless, which leverages the existing Aurora architecture that allows you to allows your clusters to become cold while persisting cluster storage. And we are going to see exactly how it happens, but later. But this is what we are going to cover. It's a brief of that. S3 select, again, I'm not going to waste a lot of time, but that's how it works. It has this SDK in all of these languages. You are feel free to use whatever you want. In our example, we use Python Boto 3, but you can use any of this as well. Now, data formats, it supports, somebody asked this, CSV it supports, JSON it supports, Parquet it supports, and apart from that, it's not written here, but I have tried ORC and Avro as well. Those are supported as well. Encoding, it supports UTF-8 encoding. And in terms of compression, even if your data is compressed to save some storage, you can save it in gzip, bzip2 for your CSV and JSON, and gzip columnar for your Parquet files, and still it will be able to read the content of that file. So that's one good thing, that you are free to use compression on your data, and still it will allow it to be queried. Encryption, just like how S3 supports this 3 encryption, this also supports. Let me quickly check who remembers this. Give me full form of all these 3. Server-side encryption, SSE, very important for your examination. Start remembering. This one, C, is for customer, where customer will manage their own key. S3, here definitely S3 will manage the key. KMS, here KMS, you have to use KMS to manage the key. That's all it is. I don't know what makes it so complex to remember. Anyway, so this is the same command that we use. I mean, not the same command. This is a CLI command, but we use the SDK version of it. So you provide a bucket name. We did that there as well. If you remember, I provided a bucket name. Key name, my file name was common, so I didn't provide that. But if you remember, I showed you a SQL query, select all from this particular object. You provide that, it's a SQL type. You provide serialization, that's a CSV file, compression type, if there is any, you have to provide that. If not, and finally, if you want to save the output somewhere, you can provide output serialization as well, and it will save that output as well. So that's how S3 select works. Now, Athena, what exactly it is? So Athena is a SQL interface for your data stored in S3. Again, in simpler language, you have data present in this S3 bucket. Data, you just want to be able to query this data, and you use Athena for it. So it's a fully featured service. What exactly it uses? It uses Presto under the hood. The exact technology that Athena uses is Presto. So they have taken this Presto and created their own version, which works with S3, and started calling it Athena. Presto, if you do not know, please read it. I have given you the page. It's called Apache Presto. It's an open source technology which queries something very quickly. Now, what does it support? CSV, JSON, ORC, Parquet, and Avro. And it has good integration. So you might be confused whether I should select S3 select or whether you should select Athena, because both are able to query S3. But in your examination scenario, you'll get something like this. You want to be able to query this data and finally do some sort of ETL on that data, or finally be able to visualize the data. That is only supported by Athena. So in that case, the answer would obviously be Athena and not your S3 select. Hope that makes sense. Now, DynamoDB, let's dive deep little bit into it. We have already seen that it's a key value and a document kind of database. Engine name is DynamoDB, and you can have some sort of partition key as well. So for an example, if you have a lot of data coming in every week, in that case, what would be your partition key? Yep, that's correct. You will have your date as a partition key, or which will have this week information. So that allows you to segregate your files into different partitions. So DynamoDB supports that as well, to save money, to allow quicker access and things like that. Then you have a sort key as well. What is the usage of sort key? Again, everything is in the name. Exactly. So you already know, let's say that your data is coming in every week. So first you will save some money by creating partition key so that you don't have to call entire data. If you are concerned with the last week data, you will just call that. Now, even in that last week data, you know that you usually need the latest data. So in that case, you can sort that, or probably you need that data sorted by, what do you say? Country of origin or country, wherever exactly that is. You have a country column as well. And you want to keep this data sorted by country. That first, I want to see everything for Algeria. For second, then I want it for Belgium, blah, 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 blah. Alphabetically, you're sorting it so that you get the relevant information first. So that, let's say you want to filter it, give me everything from A to J initial companies. In that case, your database will not read anything after J. So that again, it saves some sort of query. It will not read the entire data. It will read from A to J. Again, it's just a made up example of country. You will have some better part sort key, but DynamoDB does support sort key as well. Now, the access is via an API call. You say that I want a data, it will give you via an API call. And you can have metadata stored in this kind of fashion as well. And these are some use cases of DynamoDB. Again, same content management, metadata stores, saving user profile, saving logs. What are the features? It supports local secondary index and global secondary index. And finally, streams. What are these? Local secondary indexes. So you have a data. First thing is partition key that you have already given, which is date. Now, after date, you find that you usually end up filtering your data using price, let's say. I don't know. I'm just making up. Okay, so price is something that you usually query your data on. So what you can say, price is my local secondary index. That first, query everything related to this partition, which is a date key. Then second, query everything related to price. That would be a local secondary index. If you want to provide global secondary index, you can provide another column. That would be a global secondary index. Basically, again, to simplify query pattern or saving data in such a way that whatever is your access pattern, it supports that. Yeah, Jayabharti, go ahead. Now there are certain integrated service along with DynamoDB. DAX is one. We are going to talk about this. It's basically a streaming service that DynamoDB supports. Just like we have S3 and we have S3 Select, which does something for S3. For DynamoDB, you have DynamoDB, and then you have something called as DAX. It supports streaming data for DynamoDB. We are going to talk about it. Obviously, it has integration with IAM and it has integration with Lambda as well. Okay, now finally coming to your Aurora. So how it works, Aurora is or can be an alternative to whatever you're using like MySQL, PostgreSQL. Aurora is just built on top of this too. If you want MySQL, you can have Aurora MySQL version. If you want PostgreSQL, if you're used to PostgreSQL, you can have Aurora PostgreSQL as well. Now, what exactly is serverless? That you don't have this servers running all the time. I mean, obviously you have one server which is running for Aurora, but for querying it, you do not need to have a separate server altogether, and you can use Aurora serverless. And how it will work, a user will reach out to this connection endpoint and it will find that this is sleeping. So whenever it is sleeping, obviously you're not paying for it. It sends some query, it will wake it up, it will give you the results of this query, and again, it will go back to sleep. That's the entire concept of Aurora serverless. Again, in theory, it seems pretty simple that, okay, they are just waking something up, but there are a lot of moving parts inside, which kind of have a lot of intricacies on how they have built it. Storage remains same. You have storage somewhere in EBS volumes, blah, 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 blah. So yeah, that's all you need to know about the serverless options that AWS gives you. First one we talked about was S3 Select, and it's just the SQL interface for S3. And I gave you where exactly you should use it whenever you want to filter certain records. We took a demo on this as well. So we are good with that as well. Then we have Athena. Whenever you have a data stored in S3 that you need to basically query and then visualize it, or query and then do some sort of ETL on top of it, like changing structure, compressing it, or saving it in a particular format, change the format. All these things you can use Athena along with Glue and do all that. The formats it support are CSV, JSON, Parquet, ORC, and Avro. DynamoDB, it's the most famous database, NoSQL database, which fits most of the OLTP use cases. So it's highly used in wherever you have this OLTP kind of use case. It's highly scalable. You start with like literally 10 KB and you can virtually go to whatever number, 10 petabytes, let's say. And it will scale to that. You do not have to worry about it. And it will still give you millisecond latency as well. It's that good. It can fit key value pairs or it can fit entire documents as well. But I mentioned for documents, use DocumentDB. And finally, we talked about Aurora Serverless, which is just like how your any relational databases are, but it has this benefit that it keeps on sleeping and it only wakes up and gives you results whenever you're querying from it. So whenever you have infrequently accessed data, you can use Aurora Serverless for it. At the backend, it either uses MySQL or PostgreSQL. So it's compatible to both. It's your choice what you want to use it for. So yeah, that covers this entire section about the databases that we wanted to cover. So first, oh, why would I? These are often a data source in your analytics workflows, and understanding which available AWS databases apply to which use case is very important. So now what services can manage data between these databases? Let's say you want to move data from one database to another. What exactly you will use? You will use everything again, it's in the name, database migration service. Let's say you have data present in RDS. Inside RDS, you have data present in Oracle. And you wanna, for whatever reason, decided that right now I wanna use PostgreSQL. In that case, you can go to DBS or DMS, and you can say that, okay, currently this is my source, this is my sink. Take my data from here and put it here. Same applies. This is an example of when your data you're moving in AWS. Your data could be in your on-premise as well. Currently, your company is not using AWS. They are using whatever XYZ, but in the on-premise itself, they are using, let's say, MySQL. And now they want to move to AWS. And basically, when I say AWS, I say RDS. Inside RDS, they want to move to, again, let's say PostgreSQL. They can do that using this DMS as well. What are the other ways of moving data or putting data from one place to another? You can use some sort of ETL pipelines that, okay, this data is coming in from this place, S3 bucket, I want to put it into Redshift, but in between, I want to do some sort of ETL operations on that, transformation on that data, convert it from JSON to CSV, or change the encryption from gzip to gzip2, or anything. Take this column name and change the column name. All of those operations, they can be done via Glue. You can use Glue for that. And finally, you can move data using EMR as well. EMR stands for Elastic MapReduce, and Elastic MapReduce is basically everything related to big data is what exactly is done in EMR. Whatever you hear the term big data, you are dealing with large amounts of data. You basically are using EMR in AWS. It's basically equivalent of, let's say you want to use Spark or you want to use HDFS storage. All of this terminologies are related to EMR. Again, we have a section coming up specifically for EMR. So we are going to talk in detail there. But yeah, these are certain ways of moving data from one place to another. you are already used to using PostgreSQL. So ideally, people would stick to this. When Aurora is again just how exactly PostgreSQL works as well. But here, AWS has created some additional features. So for an example, for let's say, again, some made up numbers, for $1 a month, you are able to save your data in 3 different places. You are replicating data in 3 different places in PostgreSQL. Aurora gives you this facility for, let's say, 80 cents. You can save it in 6 different places. And it gives you this another service, which is Aurora Serverless for the same money. Then it has some other benefits as well, that it will query some results in 1 second. Aurora probably will return those results in less than 1 second. Okay, so basis that you might want to use Aurora over PostgreSQL or MySQL. Make sense? Okay, so it's basically a service created by AWS, and they have actually, they did nothing but they took something which was already existing, they perfected it a little bit, they added few more utilities or benefits to it, so that people, instead of using this very famous databases, they start using their database, which they have created, and they can earn money from it. And as it is in AWS, they can offer some discounts as well. So it's win-win for users and AWS. Now, are there any database services or engines which have not talked about in this section? Yes, there are. And these are the name of it. I'm not going to explain them. They're not very important for your certification. You will not see any question related to that. Even if you get, there won't be more than one question. So it's not worth investing much time in that, because they are much more complex. And again, they are not being asked in the question. So I've intentionally skipped this 3 things. So first one is Amazon Quantum Ledger Database. And I just have to give you a high level overview without explaining it. It's basically your blockchain technology, how your crypto works. It's kind of like that. You can have that here as well. Amazon Time Stream, it's a time series data. It's as simple as that. You want to save your stock data. Instead of saving it in usual database, you will save it in time stream database, because time stream obviously has its own benefits for this kind of data, which keeps on changing over time. There are patterns to it and things like that. Time stream can figure out all that. And finally, Amazon Key Spaces. It's nothing but Apache Cassandra, but a managed version of Apache Cassandra, which they call it Key Spaces. So if you already are using Cassandra, you don't want to use DynamoDB, in that case, they have that as well in AWS. There's nothing to explain over here. It's just like Cassandra, but it's managed. Some sort of keywords analysis. Figure out what are the keywords over here. Again, my keywords could be different from yours, does not matter. But here, these are the keywords that I think which are important for this. So first one is they want us to set up an API. So this will give you an idea. Okay, is Neptune an API? If Neptune is not an API, you can skip it. Just giving an example here. Then they want you to identify some pattern in whatever it is. We don't care about blah, blah, blah. Our thing is that I want to identify pattern. Now, the solution should allow complex SQL-based queries. And it's a very good point, which will allow us to eliminate few options over here. And it should be able to scale to accommodate large amount of data as well with minimal development. As I mentioned, the last words are usually very important. Over here, they write something like, it should be cost effective, it should be least effort, least development, and blah, blah, blah. So first thing is always to figure out what exactly works or what are the key things here. Answer, you already figured that it is Neptune. Why it is Neptune? Because firstly, Neptune supports SQL. We have already seen that. It supports 2 languages. What are those languages? Gremlin, it has its own format like G.val, has blah, 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 blah. So you have both options. So this requirement is handled by SQL. DynamoDB is definitely eliminated just because of this keyword. You were able to figure out they want SQL based. DynamoDB does not support SQL based queries. So this is eliminated. Now they said that you want it to scale to accommodate a large amount of data. This is still fine, but this all three can do. But this one, they want you to identify pattern. RDS can store. It cannot identify patterns for you. So only feasible option over here remaining was Neptune. So again, these are the kind of questions that you will get in your examination. So with proper study or whatever we are doing over here in terms of preparation, I am very sure that you'll be able to answer this there as well. Now, the next section is all about collecting streaming data. And before that, it's like a few years ago, big data was a commonly used term. Right now, you might have seen all these memes as well, that all companies, they all talk about generative AI, generative AI, generative AI. So these are the terms which are just usually used in the business context. What exactly is the technical definition of it? Nobody knows, but they just keep on using it for some reason. So big data was used like that as well. Some people are calling 200 GB data big data, some are calling petabytes level of data big data. But this famous definition was revolving around 3 V's, that whenever you are dealing with a massive volume of data which is generated from various sources such as your business transactions, social media posts, sensor media data, and all this thing. So whenever you have this sheer volume of data which is usually too large to be managed and analyzed using your traditional methods. What was the traditional method? As you can see over here, you have one computer, you have a remote access, and you have a big data, this big data cluster. This is the approach of using it. Now, you break down basically that data into various parts is the approach towards big data. That's all it is. In a traditional sense, you just try to access it from a very one big computer. That does not work with big data. So any data which cannot be handled by that just one computer, you can call that data big data. Second one is velocity. Initially, few years ago, at least before Facebook and all, before let's say 2004, we never had this problem with that, where we have huge amounts of data coming in at a very fast pace. Because what data we had? Bank data, this few companies' data, some internet data, and all this thing. It was very hard to create data that time. But now with the advent of social networks, everybody is uploading, everybody is tweeting, everybody is posting something. So you started getting that data in huge volume, plus with huge speed as well. Everybody is uploading something every second, every few minutes. Everybody's using Instagram or something. So velocity increased. And with that, we got the need of calling this data something else. And from there, we started calling it big data on the basis of its velocity as well. And finally, variety. Again, social media is a huge driver there as well, which is before that, we used to have structured data mostly, some sort of semi-structured data, but we never had this problem of unstructured data, which is like anything is coming in, images, videos, short clips, and blah, blah, whatnot. So you got variety of data as well. So the combination of these 3 famous V's, we started calling big data, but nobody talks about the 4 V's, and I want to talk about it. So veracity is the 4th V. So what exactly that means is that your big data can be noisy, or it can be inconsistent, and or it could be of questionable quality as well. So only when I fulfill this 4 V's, then I call it big data, not on the basis of just 3 V's. So what exactly this means is your data is coming in from various sources. Somebody is generating data from their mobile, somebody is generating data from their computer, somebody is generating data from their smartwatch, somebody is generating from their Alexa, somebody is generating data from their thermostat at home. So again, your data is coming in from a lot of places, which means it is very inconsistent. There's no structure which is same for everywhere. And that started causing problems in storing that as well, or processing it basically. So that's the 4th V, which is veracity. So that's basically my definition of big data. Again, there are a lot of definitions going around, floating around. So yeah, that's big data. And how do you use it? You have a very big cluster. You break down the data, save it in multiple computers instead of saving it in one computer, and you use it from somewhere else. How you do that as per Intellipaat on AWS? is you put AWS in between. I don't know how to explain this more than this, but yeah, that's all it is. And you will find some things that we have already talked about. AWS gives certain advantages. It is fully managed. We have already talked about what fully managed services are. You pay only for what you use. You have this integration that you have already seen, that Athena quickly integrates with IAM. It quickly integrates with S3. It quickly integrates with Clue. It quickly integrates with QuickSight, and a lot of other services integrates with each other. So AWS has good integration. That's what is their benefit as well. You obviously do not have a hardware requirement apart from your computer and an internet connection. They allow you to scale up and down quickly. The source could be anything. Your data could be coming in from Amazon Kinesis, from SQS. We are going to talk about both of them. Do not worry. How do you process this data? As I mentioned, whenever you hear big data, we are most probably doing that in EMR. It's very important for this certification, for big data engineers, for data engineers, this particular service. Lambda, you have loosely seen it already in my demo that I showed today. That's what Lambda does. You can write code in the cloud and it's serverless. It's quite cheap. It's basically compute. Now Redshift is a data warehouse. It supports columnar format. That's what gives it its speed. Then we'd already talked extensively about S3. DynamoDB as well, and RDS as well. So these are some places where you can store this data. So what exactly is Kinesis? Kinesis, if somebody has used Kafka, it's kind of like that. But if you have not, it's a data streaming service. So you could have a data coming in from this tractor sensors, machine equipment sensors, or anything, which is a streaming data. It is coming in terms of a stream. You take that data via something called as Amazon Kinesis data stream. Then on top of this data, you can apply some custom code logic using Lambda. And finally, you can save that output or view that output somewhere. So that's how you use data collection service called Amazon Kinesis. Just remember for now, it's a data streaming service. In my slides, I'm going to dive deep into it. So EMR is again second level service. It's built on top of EC2 instance. What exactly is EMR? EMR is nothing but lot of different computers or servers connected to each other. What are the servers? They are nothing but they are different EC2 instance. And what they have done, they have called one EC2 instance master node, other 1, 2, 3, 4, 10, 20, how much ever n number of instances you want, you can have in an EMR cluster. What they will do basically, they'll connect to each other, they'll talk to each other, and they will, instead of doing instead of one person building one product, they have created a team to build that product. So here, instead of this one person creating one entire building on its own, what they are doing, they are saying, okay, you build this first block, you build this second block, you build the ground floor, and blah, blah, blah. All these different components, they have done some sort of parallelism here, which allows them to work with very big data. Otherwise, it is going to take a lot of time, or it is going to take a lot of compute. What they have done, instead of taking this entire big machine or big CPU, they have broken down into smaller number of cheaply available servers or cheaply available CPUs, so that they can say, okay, you work on the first part, you work on second, you work on third, you work on fourth, and I am your leader. I will see if you have done your part correctly, you have done your part correctly, you have done your part correctly, and so on and so forth. And finally, you give me all this small results that you have worked on. As a manager, I'll take your credit and give it to the user, saying that, okay, take your final product. That's what EMR is. Again, at a high level overview, there is a lot of tech stack which is used here, like HDFS. Google is built on top of it. They created very first one.
Let's have a quick quiz question, guys. And the question is, which of the following is an example of structured data? Option A, social media posts. Option B, sensor data. Option C, customer names and addresses. And option D, email messages. Please do mention your answers in the comment section below. Just a quick info guys, Intellipaat offers an AWS Big Data Certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
White paper on this HDFS in 2000. So obviously there are a lot of things and a lot of complexity in how they achieved it. But for high level understanding, that's all they do. They break down a very big file, a very big data into a smaller number of units, distribute it to a lot of servers, and all of the servers work on their own. Once they are done, they go give the results to master. Master takes it, shows to the user. You provide the name, you click on filter button, and Lambda had the logic to filter it for you. Here it's basically a serverless event driven. That means you do not have servers running 24/7. Here you are giving a name and you are clicking on filter, then only Lambda wakes up, works on this particular piece of code, and then sleeps again. And you are only charged for this period of time where Lambda was awake and worked on your piece of code. So it's an event-driven service. That's what its superpower is. And again, it's a fully managed service. You do not have to worry about which server should I call, what server will that be, whether it will be a Mac, Windows, Ubuntu, Linux. You don't have to worry about any of that. Everything is taken care by AWS. It's a fully managed service. And you just write your code, put it into Lambda. Lambda will just run that code serverlessly and even in an event-driven fashion. Okay. And you only pay for whatever compute period of time that you are using and nothing else. Another example of this is, let's say you are creating this kind of logic that you take a picture from your phone, you upload that picture to S3, or you have created a website which when you click on upload, it uploads to S3. Then Lambda wakes up, and the logic is whenever you get this picture, resize it to some whatever XYZ, and the resized picture is displayed. So I'll give you another example of how I use Lambda. So for an example, I teach for a lot of different companies, not just Intellipaat. And Intellipaat, it's a live training. Some companies want me to deliver whatever recorded content of this entire certification. They give it to their people. Once they are done with my recordings, they reach out, they ask me questions, they ask me to whatever they had doubts, they just ask me for clarifying those. And some company, let's say this X company, they wanted me to give videos in MKV format. This Y company wanted me to give videos in MP4 format and something else. And this is an actual situation. This happened with me. And I was like, this is too much work. I record myself in one format, then I record myself in another format, save it, give it to them, uploading it, sending it to them, because these are huge files. So what I did, I just record myself every time in one of the formats. My preference is MP4. So I record myself in MP4 by default because that's what works in Mac. I have set it as my default. Then I upload that file to my S3 bucket. Okay. Then I have created a Lambda function which uses a library called transcode. And this library takes this file. Whenever I upload something to S3, I don't even have to go and run it. It's event driven. Whenever I upload something new to S3, it makes sure that, oh, Harsh needs this to be transcoded. He has uploaded an MP4. He will figure out there is an MP4 file created. It's give me the MKV file of it and stores it in another S3 bucket. And it sends me an email that this one has been done. Then if I have some other automation, but I usually don't have this much I can do. I'm not this lazy. So here I go read this email and send out the rest. But if you want, you can take it another step that, okay, this particular company wants it in this format. Basis that logic, you can send it to this company and so on and so forth. So this is one thing. I have other things done here as well for my training, that there are other people who are from different languages and they don't want it in English. I just take my voice, whatever I am saying, I transcribe it and I give them subtitles as well in different languages automatically. Again, I am saying only everything in English, but I am transcribing it, giving it subtitles in whatever languages they want. Even if they want different voice, they want me to speak or take this entire class in French, I have taken that logic as well. AWS has all these tools already created. I don't have to do much work. I don't like to do much work. I'm very lazy that way. So this take care of that as well. I say everything in English. It converts that into Spanish, French, blah, blah, blah. Save it in different S3 buckets. And basis that, I can figure out what to send where. So it's a very powerful service, Lambda, if used appropriately because of this event-driven nature. Now, then you have Glue. So Glue is a fully managed ETL service. ETL, you guys, I think, know because you belong to this stream more than I belong. So yeah, it's extract, load, and transform. The tool for that in AWS is called Glue. It helps you to prepare data for further analysis or further saving into data warehouse. Before sending into data warehouse, you want this data to be pristine. You want everything appropriately done to this data, and you can use AWS Glue scripts for that. Your data would be recorded, you upload it to S3, you use Glue, your data would be cataloged, you will have metadata of it. And finally, once you have done transformation on it, you can send it to Redshift, EMR, Athena for further things. Now, analysis, as I mentioned, for OLAP use cases, we use Redshift. Redshift is a fully managed petabyte scale data warehousing solution in the cloud that allows its user to deal with pretty much whatever petabyte size of data they have for OLAP kind of transactions. SageMaker, you do not have to know, but SageMaker is basically an entire suite that AWS has created that takes care of all things related to machine learning. All this generative AI things, SageMaker. Anything related to computer vision, you upload an image, you want something to figure out who is the celebrity, what is the name, where exactly is the nose, what exactly is in that image. If you upload some text, you want that text to be converted into voice. Again, everything, all these things are in SageMaker. So it's a fully managed machine learning service or a platform that AWS has created, which provides you a lot of benefits of, again, it's a fully managed service. So unless you are using SageMaker, you can do all of those, but it will take you much time to train, build those models. Here, they have made your job easier by doing a lot of things firsthand and you just using them.
The brief overview of how it works. So it's like data usually loses its value over the time. So as you can see, this particular graph shows that itself. So whenever you have real time data coming in, that is when it is of most importance, that you can do a lot of preventive as well as predictive analytics on top of that data. Within few seconds, it's quite actionable. You can take certain actions on the basis of data that you are collecting. And whenever it's minutes to hours, basically you're doing some sort of reactive actions on top of the data. But after that, as you can see, mostly this is where your traditional batch business intelligence starts coming, where your data is just sitting idly and you might need it once, few days, few weeks, few months. But yeah, the whole purpose of this diagram is to show you that streaming data is of utmost importance because it helps you generate most valuable insights. So that's what we are going to see, how exactly we do that in AWS. So yeah, this one is about data collection as well as data preparation. So over here, you are going to learn how do you exactly collect this streaming data, because again, collecting streaming data has to be a little different from how you collect your traditional a tabular data or historical batch data. It needs to have some difference. So that's what we are going to see, how exactly data collection works for streaming data, and as well as this data, what exactly you can do to prepare it as well, like do some sort of processing on top of that before actually storing it in some place. So that's where the problem is solved in AWS by the Kinesis family. So the Kinesis family is what helps you with the streaming data. Streaming data could come from a lot of resources, a lot of places. Can you quickly see in this diagram? All the answers are there, and tell me what are all the places where you might get streaming data coming from. Online games is one. Yep, definitely. IoT, definitely. A lot of IoT devices, your Fitbit, your Apple Watch, and a lot of things generate this streaming data as well. Social media is a very big example of that. Every minute you see some tweet, Instagram, or whatever. Kind of an example of streaming data itself. Yeah. That diagram though is for sensors. A lot of companies have their sensors probably working in their machinery, in some oil rig or somewhere. All the sensors are working and sending that data so that you can make some sort of decisions based on that data that you're getting from sensors. For an example, NASA might be sending it, or ISRO might be sending all of these probes to different places like moon and everywhere else. All those things, they work on sensors as well. They are also sending streaming data. And finally, a lot of energy related companies use sensor data as well. Now, so that's what we are going to see, that all of these different things that we talked about, IoT or your sensors or your social media, they are just your producers generating this data. This data will come in to AWS via Kinesis family. So that's what you will see in between, that you will use Kinesis. So that should be synonymous to streaming data when it comes to working in AWS. So how I would like to remember is by the Marvel family. The Kinesis family is kind of like that, or the Shazam family. All of them, they are called Captain Marvel, Shazam, Mary Marvel, all those things. Similarly, Kinesis have this kind of different services as well. So these are the services that you will find in Kinesis. Yeah. So the first thing that we are going to talk about is something called as Kinesis data streams. And the second one is Kinesis data firehose. Then you have Kinesis video streams. And finally, you have Kinesis data analytics. So these are the 4 services in the Kinesis family. And we are going to start off by talking about Kinesis data streams. Over here, we'll see that all these data producers that we talked about, they can generate a lot of information, and examples of those are written here. Like you can have application log files, video game interactions, mobile clients generating data, clickstream data, social media streams, IoT devices, EC2 instances, on-prem servers, a lot of things that you guys already mentioned, and few additional here as well. Now, the very first thing that comes when you start talking about Kinesis data stream is shards. So shard, how you would like to, let me think. So shard is basically the atomic unit on which the Kinesis data stream operates on. So default limit for shard is 500. And I would like you to think about shard as just some sort of packaging, where you package or wrap your data, which is coming from all these producers, and keep it inside this package. So shard is nothing but this packaging over here that you see. So shard is exactly that. You can have n number of shards. Default, do remember the default is 500 shards. And finally, once you have data in the form of shards, you can send this data to a lot of different consumers. You can send it to EC2 instances where you will do something with this data, or you can send it to Lambda to take some actions on this data. Like if you get this data, then do this operation, event-driven approaches you can create, or you can just run real-time analytics on top of this data as well using Kinesis data analytics, which we are going to talk about in some time. And finally, you can send it to EMR as well. EMR is again something that we are going to talk about after this module. And finally, if you just want to store this data, you don't want to do anything, you want to deal with this data later, then your choice is Kinesis data firehose, which we are going to talk about very next. So this is how exactly the entire flow would look like. You will have all of your data producers sending in their data. In Kinesis data stream, you will be storing this data in forms of different n number of shards. And once you have this data in Kinesis data stream, you can do a lot of things on top of this data, have your custom code running on top of it, do some sort of analytics on top of it, or just store this data and you can save it in S3, DynamoDB, Redshift, or just some sort of business intelligence tools itself. So this is how a typical data stream or the data streaming data application would look like in AWS using Kinesis. So shards, I have already told you what exactly shards are. They are just some sort of packaging which wraps up your data, but we'll look into shards in a little more detail. And that's what we are going to do now. Yeah, so when it comes to shards, I would like you to think about or remember these three things. Every shard has these three things. First one is a partition key. That's pretty obvious. You're dealing with streaming data. If you have heard about Kafka, Kafka has a partition key as well. Similarly, you will have a partition key in a shard as well. Then you will have some sort of sequence because your data is a streaming data. It is coming in some sort of sequence. And inside this shard, you will provide this sequence number to whatever n number of shards you have. And finally, this is where your actual data will be stored. Whatever the data it is, you are generating name, place, whatever. Anything, sensor data, geographical data, whatever data you are generating, that data will come here. But apart from this, you will save these two important things, which is sequence and a partition key as well. Now, each shard, it consists of data records. As I mentioned, you will have whatever data you are having here. And like for an example, right now, let's say I'm streaming this data that I have, that how many people are joining my class. Few people join at 8 p.m. IST, some people join at 8:01 IST, and let's say I have to stream this information. So let's say Jaya Bharti joined first. And what data I'll get? Okay, trainee name, Jaya Bharti, trainee ID, blah, 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 blah. That would be my data. And as you came first, this data, what I got, that will be called as sequence one in this. Now somebody has joined in, that person will have, I will have that information, the data over here, and I'll call it sequence two. And now the most important stuff that you have to remember definitely for this certification is this metrics or the numbers that you see over here, that each chart, it consists of a data record and you can generate 1,000 records per second. So the same example, if I have to continue, let's say I have 5,000 people coming in and joining my class. All right, that's not happening, but let's consider that. And I have to just keep on streaming this information as well. Whatever you are asking, I have to send this data that, okay, this person asked this person asked that, this person interacted this much or whatever. This is all the data. Let's suppose I am accumulating over here and then finally streaming it. So that would be my data. And in a second, I can send 1,000 of this information across. Now, your data payload, every record. Here we talked about that you can have 1,000 records per second. Now I'm talking about one record from this. Each record, it can be 1 MB of information. It cannot be more than 1 MB. It can be 100 KB. It can be few bytes. It can be whatever. Till 1 MB, you can have the size of this data payload that you're getting for each record. So here you have this record 1. This is record 2. This probably is 1 MB. This is probably 800 KB. Make sense? Any confusion here? Okay, I'll assume in 3 seconds that you don't have. 1, 2, 3. Okay, now the very important bit to remember as well, which is each chart, it is capable of inputting or reading this much, 1 MB per second input. And each chart is capable of writing 2 MB per second output, which means whatever application you are building, which is using Kinesis data stream, you can send this to consumers at a much faster rate than you are reading. how it helps, you will never have this congestion that, okay, I have too much data, but I cannot send this data to the next place or the next stream or next piece of code or the next place wherever I want to save it. So this makes sure of that you are reading at slow speed, but you're writing at much faster speed. So you don't have any overhead at the writing or the output cycle. Now, obviously, the logical thing is that, as I mentioned already, one shard can have 1,000 records. But let's say my application is generating 2,000 records. What should I do in that case? Just instead of one shard, have two shards, which basically means now you are able to read 2 MB per second input and you're able to write 4 MB per second output. So this basically infers that whatever is your application, all you have to do when you're using Kinesis data stream is increase the number of shards, and it will deal with whatever amount of information you have. So how I would like to remember this, again, for certification, remembering a lot of things becomes difficult. So I like to have some sort of analogy to remember things. So when you're learning about or trying to remember what exactly shard is, I try to compare it with a train compartment. So over here, every train has some sort of ID. You might have seen it already. It has some sort of uniquely generated number printed or pasted on top of train itself. So that train ID is analogous to your partition key. Every train has this ID. Every shard has this partition key. Now, every train car, it has some sort of sequence number as well. That this is bogie number 1, bogie number 2, or blah, 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 blah. It keeps on going, AC coach, first coach, blah, 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 all these things. There's nothing but a sequence number for a shard. And finally, the passengers sitting inside the train, they are nothing but the data which the shard is going to carry to the next location. So few limits, again, very important for the certification, that a shard is transient data storage, which means it does not persist information like for forever. It has this information only for 24 hours, which is the default. But if you want, you can set it to keep this information within itself for 365 days. But after 365 days, unless you are storing in some place like S3, DynamoDB, Redshift, that data will go away. So do remember this, that your data or a shard is a transient data storage. It does not store your data forever. So 24 hours, as I mentioned, is already by default. If you want, you can raise this retention period to 7 days by enabling something called as extended data retention. You just have to enable a checkbox and it will make sure it will retain it for 7 days. Now, if you want for it to keep for 365 days, there is another option, which is long-term data retention. So these are the only 3 options you have. You cannot set it for like 363 days. That's what it gives you. 24 hours by default, 7 days, or 365 days. So that's what basically it means. If you again come back to your train train example or the train analogy, here your passengers or your data in shard, it has to go out of the train after 24 hours of travel. It won't allow you to stay there after 24 hours. But if for whatever reason, if that passenger wants to stay in that train, it can stay for around 365 days. So how do we interact with Kinesis data stream? That's what we are going to see. All of this producer, they will be generating their data, but how exactly Kinesis data stream takes that data, or what is required to take that information and do whatever we talked about, saving it, do some sort of code on top of it, or any analytics on top of it. So here, this first section, we discussed what exactly is Kinesis data stream. We talked about shards, how shards have a partition key, how it has a sequence number, and it has your actual data as well. And then we talked about if you want to scale, all you have to do is increase the number of shards and you can scale limitlessly. It entirely depends on you how much you want to scale. Then we talked about its retention, that by default, it is retained for 2 or 24 hours. If you want, you can enable long-term data retention by enabling it for 7 days. And if you want long-term, you can enable it for 365 days as well. And then we also talked about few limits that by default you can have 500 shards, but that is a temporary limit or a soft limit. You just have to reach out to AWS, create a ticket, and they'll increase this limit for you. And we talked about this as well, that each shard is capable of reading 1 megabyte per second, and it is capable of writing 2 megabyte per second, which means it can read write much faster than it is able to read. And apart from that, we also talked about what exactly we talked about. Blah, 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 blah. I think that's it. Now, in this next section, we are going to discuss what exactly are your data producers. I kind of have touched based on it already, but here we are going to have a look at it again. Then discuss shards in little more detail. Then what exactly you do when you have this data, how do you process or store it, give you some example of how exactly the entire flow looks like, and how do you interact with Kinesis. Then there are certain things required to use Kinesis, which is KPL and Kinesis API. We are going to see how they actually differ, and this is very important for your certification. And then we'll talk about few use cases, and then finally we'll summarize whatever we learned here. And yeah, once we have learned all the members of Kinesis family, we are going to do the demo covering everything together as well, so that you have a hands-on experience on Kinesis as well. So it's going to be a lot of things that we are going to be covering. So first things first, how do we exactly interact with Kinesis data stream? So there are a few options you have. First one is by using Kinesis producer library, or it is called as KPL. So what exactly is a KPL? It's just a library that AWS has created, which allows you to write to a Kinesis data stream. So you might have your data in whatever places that we talked about. All you have to do is install this library at that source, and then it will start sending data to Kinesis. That's all there is. Okay. Then obviously the counterpart of this is already also there, which is Kinesis client library. Now, this library is it's integrated directly with your KPL for your consumer application. Then we talked about that you can send this data to EC2 and then do some whatever custom code on top of it. So that consumer also needs a library to process this data or take this data, which again, AWS has conveniently returned for you. The code is there. All you have to do is install this library in your consumer, and then you will be in a position to take this data coming in from your Kinesis data stream. Now, the third thing is Kinesis agent. What exactly it is? It's a pre-built Java application which you can install on Linux-based server environments. So over here, this is very specific. It does the same thing what KPL, KCL does, but over here, it's just a Java application, and it is specific to Linux-based server environment. If you want, you're working on, let's say Windows, you can't use this Kinesis agent. So that's the difference. And finally, Kinesis API, my favorite actually. So this is basically used for any sort of API operation to send records to a Kinesis data stream. So just like how we were sending it in S3, we did the demo, we sent record, put record. So we uploaded a file, we did something. Same thing, instead of uploading a file, this API will allow you to upload the streaming data to your Kinesis data stream.
So what is the difference between KPL and Kinesis API? So over here, KPL, it provides you a layer of abstraction specifically for ingesting data. So again, you do not know what exactly they are using under the hood, what is the tech stack they have used, or how exactly they are sending data to Kinesis data stream. You don't have to worry about that. They have wrote this abstraction layer specifically, which allows you to ingest data, send data to Kinesis data stream. On the other hand, Kinesis API, what exactly it is? It is just an API call. You make this API call that I want to send my data here. It just send that data. If you want, I want to get my data as well. So Kinesis API will do not just ingesting, but consuming as well. It's just series of API calls. You can put data, you can get data as well. Now, Kinesis producer library, it has automatic and configurable retry mechanism. So for an example, in the first time I was not able to send data, something happened, network failure, 500 error or whatever. In between, what it will do is it will retry again to send the data. But Kinesis API, so here stream creation, resharding, and putting and getting records, everything you have to do manually. So over here, there is much less abstraction. Here you have to handle or tackle few things on your hand, but KPL does a lot of things for you. So KPL is much more easier, but in Kinesis API, you have much more control. Just because you do not have this, what do you say? You don't have to do a lot of things manually, which AWS is doing it, but somebody is doing it, right? So some sort of additional processing is required when you're using KPL. And because of this extra processing, you can have certain delays. Few, again, here when I talked about delays, it's very minor, few fraction of seconds delay, which can occur to achieve this higher packing efficiencies and better performance, because AWS is making sure that you are retrying it, you are sending it properly, there is no issues over here. Kinesis API, it's just making a call. That call, it can be successful, it can be unsuccessful, but they are not taking responsibility that we'll try again if it is unsuccessful. So over here, they are not doing a lot of processing, and that what that what saves all these delays. So if you, so again, how exactly it will come in your examination is they'll give you a scenario that I want to ingest data or I want to get data, and that data should not have any delay at all. What would be your answer? KPL or API? What exactly you'll use in that case? And finally, KPL is just a Java wrapper. So here also, again, a scenario came in my examination that you want to use Kinesis data stream, and these are your options. They give all these 4 options that you have. Along with that, they give some made up names as well. And they asked you, what I am just proficient in Java. In that case, what should I use? Or no, my question was exactly that. I do not know Java, I know Python or something like that. So in that case, obviously, I cannot choose KPL because it's a Java wrapper. Here, the requirement is that you should know Java, then only you'll be able to use the Kinesis producer library or KPL. Now in Kinesis API, as it is an SDK, AWS has it's just an API, and over that, they have written multiple SDKs. So you have code in Ruby, Java, Python, Go, and a lot of languages that AWS support, and they do support a lot of languages. So this is what we are going to do later, but just wanted to give you a sneak peek of how exactly Kinesis data stream looks like, or how do you create it. Creating it's super simple or super easy. So you just go to Kinesis data stream. This is what you see. The first thing that they ask you is what exactly you want to call this stream, Kinesis stream name. After that, you have to configure shard, because as I mentioned, shard is the unit of throughput capacity. Whatever throughput capacity you want, you provide that many shards. Okay, so whatever data you have coming in from your producers, you and they also have created this wonderful calculator as well, which allows you to estimate the number of shards that you will need. Because let's say you are a new person, you're using it for the first time, you don't know if I need 10 shards, 20 shards, or whatever. Though you have been taught by Harsh, I told you that a shard can read 1 MB per second. In that case, you know that, okay, let's say I'm sending 10 MB per second. In that case, how many shards I'm going to need? It's a 10 because of 1 MB per second. And that's what, again, a very simple thing. You just saw it that you need 1 MB per second, but still you guys are a little confused. That's why they have created this calculator, which will calculate this information for you. But right now we are preparing for the certification. So we need to remember this so that we are able to calculate it on the fly. So this is what they ask. What is your write capacity, MB per second? What is your read capacity? How many records you're generating every second? And basis that, they give you how many shards you're going to need. If you have any questions, please don't put it on chat. Please put it in Q&A. Even if you're answering, put it in Q&A. I do not monitor chat all the time. So many people here. Okay, so that's how this is this simple. This is all you have to do in order to create a Kinesis data stream. You provide whatever shards you want. You provide what the name of the stream, and you're good to go. Enter a mall, and that mall is currently occupied. Every parking is taken. What will happen? The car whichever are coming later or at a faster rate than you expected, they are going to wait in the queue. Same happens over here. Whenever it has processed those 10 records, you are sending 15 MB per second, but it can handle only 10 MB per second because you have provided only 10 shards. In that case, this information will go away. The other information, there will be a delay. It will be processed, but at a later stage. That's what that you will find it in the Kinesis producer library documentation, that it has some in-memory capacity, that this is the amount of information it can hold. Basically, that is as per how much RAM you have. And finally, the use cases. So you can use Kinesis data stream to process and evaluate logs immediately. You are generating, your system is generating logs, or your application is generating logs continuously, and you want to process those records or the logs within few seconds. You can use Kinesis data streams for that, or you can use it for running real-time data analytics. You have this clickstream data coming in and you want to process it, show it in some sort of bar graph chart or whatever, or you just want to display it on the screen. You can do those real-time data analytics as well. So this is just one example. You can play around with it. I mentioned that average record size I have, my producer is generating is 1 megabyte, and maximum I can have 5 records to be returned per second. And I'll be reading from total number of 2 consumers. In that case, it tells me how many shards I'm going to need as per that. You can just play around with it and exactly see. So here, this is one example, and we are going to work with it later, right? Because I want to show everything together, Kinesis data stream, Firehose, but this is exactly what we are going to see in that demo as well, that I'll be generating this fake data that you see on your screen, that it will have gender information, some name, what is your first name, last name, location, postcode, country you belong to, and a lot of such information. I'll be sending this information to Kinesis data stream, and we'll do something with that. So yeah, that's pretty much what exactly Kinesis data stream is. Somebody quickly summarize it for me. You have all the things written over here. Please volunteer. If multiple people want, they can go ahead. If few people want, whatever. Just someone summarize it for the class. So the next thing, or the next service in the Kinesis family that we are going to talk about, is Kinesis Data Firehose. And this is exactly what we are going to discuss. What are the Kinesis Data Firehose destination? Kinesis Data Firehose is pretty simple. It does not even have shards, so you don't have to even worry about that, even though having a shard itself is pretty simple. That Kinesis data stream is simple as well, but Kinesis Data Firehose is much more simpler. So you can save your data which you are getting from Kinesis data stream or from your producers, and you just want to save it. You don't want to do anything with it. You just want to save it. In that case, the thing that should come to your mind, what should I use? That should be Kinesis data firehose. So you can save your data to S3, you can save your data to Redshift, you can save your data to Elasticsearch, and finally you can save your data to Splunk as well. So these are the destination possible where you can save your data. So think about Firehose, as the name suggests, as literally Firehose. This is how it works as well. That you have your data coming in from multiple places. This is your producer. This is one record, second record, third record. All it just is just send it somewhere, save it somewhere. That's all it does. It takes this data and just save it in some place. That's all Kinesis data firehose is. And as I mentioned, these are the places where exactly it can store data: S3, Redshift, Elasticsearch, or Splunk. These are the places where it can save the data. And few things just to remember is your data records again can be only 1000 KB or around 1 MB. Your producers will just send the data to Kinesis data firehose, and it will save it to all of these destinations that we talked about. And what else? Apart from that, there is another thing that a firehose can do. Apart from just saving, what you can do is do some sort of transformation in between as well. That change the name of this column, or you change the format. Instead of you are receiving it in a JSON format, save it in a CSV format. The coming data is not compressed, you want to compress it. This kind of transformations you can do in between as well if you want. What else? And then we have your, yeah, this transformation. It allows some sort of transformation by default in the service itself. But let's say those things does not suffice your requirement. You don't want to just change the format. You don't want to just compress it. Maybe you want to do something much more advanced, which suits your application, whatever you're working in, or the entire pipeline that you're running in. In that case, it allows you to use Lambda. And Lambda, we are going to talk about Lambda, but Lambda is basically gives you this limitless capability. Again, your imagination is the only limit that you have when you're working with Lambda. You write whatever code, Lambda's job is to just run that code. So whatever is your transformation logic, just put it in Lambda before saving it to one of the destinations that we talked about. And what else? Yeah, this is one example how exactly this particular service is used. So you have your data producers, obviously producing data. They sending their data to Kinesis data firehose. The data, it cannot be more than 1000 KB at a time. What you can do is maybe do some sort of transformation on this data and finally save it to destination bucket. And you can save it to a backup bucket as well if you want. So this data is your raw data, which came and got saved in one bucket. Then you did some transformation. And finally, you save this transform data into another bucket so that you are keeping both the copies, transform data as well as the raw data. Now, the example, just a second, Jayabharati, let me just complete this Redshift one as well. So same thing will happen for a producer. Again, producers will be producing their data. Kinesis data firehose will take this data, and finally, it will save it to S3 bucket first anyway. Here, the destination is Redshift, but this is an important thing to remember that when you send it to Redshift, it does not actually send it to Redshift. First, it takes the streaming data and deliver it to an S3 bucket first. And from there is a command called copy command, which Redshift uses, but Firehose just issues this command that load this data from S3 to Redshift. So just remember this flow that whenever you're sending data to Redshift, it does not directly go to Redshift. First, it goes to S3 bucket, and from there, Firehose issues a copy command, and that copy command is responsible for sending this data from S3 to Redshift. Now, same thing happens for your Elasticsearch as well. Producers produces their data. Kinesis data firehose takes this data. If you want, you can save this data to a backup bucket. Then do your transformation. Again, this is an optional step. If you just want to save it, you can save it and end it here itself. But let's say you went ahead and did some transformation and finally send it to Elasticsearch. Even if you do not know Elasticsearch at this point of time, do not worry. We are going to talk about it. Same thing is going to happen in Splunk. Again, if you do not know about Splunk, you do not need to know as well. And this we are not going to discuss as well. Splunk is just one of the popular services that industry uses. So AWS chose to give it as an option of sending or storing this data in this destination as well. So just remember, there is one destination or service called Splunk, where your data firehose can save its data as well. Apart from this, I already talked about it can save it to S3, it can save it to Redshift, but first it sends to S3 and then it issues a copy command, or it can save it to Elasticsearch, or it can save it to Splunk as well. But one thing I did not show earlier, which is HTTP endpoint. So this is one convenient thing that they introduced recently, not recently actually, it's been 2 years now. But yeah, I used to miss this because let's say I got my data in S3, but I am again a very lazy person. I do not want to go to S3, open it and then see it. Maybe I want to see it in Postman, or I want to see it in my Insomnia or something, whatever application I use for using all this REST APIs. Basically, they create an API out of your data. So if you want, you can create get data kind of records, and you can see it in your web browser, or you can just directly use it in your UI as well, or you can just show it in the screen itself. So it's very convenient option that they can send it directly to an endpoint, and you can consume this endpoint to get this data. So that's pretty much it what data firehose is. But in this place, in this next section, we are going to talk about few more technical things, so the limitations or few things that you need to remember about Kinesis data firehose. So we are going to start off with buffer size and buffer interval. Then again, same use cases and summary as well. Yeah. So what exactly is a buffer size and buffer interval? That's what we are going to see over here in this section. So when you send it to Kinesis data firehose, you saw already that it is much more simpler. You don't have to think about shards, right? And anything simple comes at some cost. And that's the cost that we are going to discuss. That over here, it first creates the buffer there is some sort of buffering that happens, how it happens in YouTube, or it used to happen when we had shitty internet. But buffer size is basically that you can have a buffer size ranging from 1 MB to 128 MB for your S3, or you can have a buffer size ranging from 1 MB to 100 MB for Elasticsearch. Please do remember this. These are important. So what exactly this means is that, let's say, for the same example that I talked about, that I have a class teaching 5,000 people, and I have, for some whatever reasons, I created this application that sends this information to Intellipaat, let's say. Now, what I want is, it's a waste of my money if I just have one person joining my class and me sending that information to Intellipaat. It's waste of my time, energy, money. That unnecessarily I'm doing the same work again and again. So instead of that, what I do, just like what I do here as well, instead of giving access to everybody at 8, I know people are going to join at 8:05 as well. I wait till 8:05. I collect this much more bigger chunk of buffer, a bigger chunk of trainees. Then once I have that information, then I give you access to talk. So that's just me creating a buffer. So I'm waiting for at least 20 people to join my class. That is my buffer. So that's the same thing. Kinesis data firehose waits. Okay, do I have at least 1 MB records? Okay, I have now. Then it sends it to S3. Then for Elasticsearch as well, it does the same thing, but over here it can wait till 128 MB as well for S3. That okay, do I have 128 MB of records? Then I'll send it to S3. Till then, I'm going to keep waiting. Same thing. There is another concept which is pretty similar to this as well, which is buffer interval. So either you can have size, like I mentioned, or I can have interval. Like for an example, same, I give you guys interval of 5 minutes. That I start my class at 8 p.m. IST. I'm going to wait till 8:05 IST. Anybody joins till then, I'll give them access to talk. Anybody joins after that, I won't give them access to talk. Same thing. So buffer interval, you can have this interval ranging from 60 seconds to 900 seconds. What exactly or essentially you are saying it to Kinesis data fire is that please wait 60 seconds, then send it to S3 or your final destination, whatever it is. And it can range to 900 seconds as well. So one thing to notice over here is that you definitely have to wait 60 seconds. So for an example, I just sent this data that, okay, my name is Harsh. I want to send it to somebody, my consumers or my destination, S3. In that case, I generated it at like, let's say 8:01. I cannot send it at 8:01, which Kinesis data stream can do. KPL, you get this record, your KPL or Kinesis agent, it will just write or it will just post this and it will be saved to Kinesis data stream or whatever your location. It can do that same thing at 8:01. But Kinesis data firehose, it wait for at least 60 seconds. So it will keep waiting for 60 seconds. By the time it is already what? 8:02. So important thing to remember again for your certification is that they'll give you this scenario that, okay, I have this requirement there where I want to send this streaming data without any delay at all. They have returned. Again, they'll write some word like this, no delay at all. They are not going to mention that, okay, there is a 60-second buffer or all these things. You have to infer that what exactly they are trying to confuse you with or what distractor they are providing you. So they are exactly saying that I want to use one of the Kinesis family services, and my requirement is that there should be no delay. So buffer size and buffer interval, the only thing to remember over here is that there is a possible time delay due to this buffer size or buffer interval, whatever you have set, before actually your data is delivered to one of the destinations. That's all Kinesis data firehose is. Let me see the question. Oh, API. That is a strange answer, Shashi. So what are the use cases? You want to stream and store data from devices. You are getting some important data from your IoT devices, embedded systems, consumer applications, and you just want to store it in some data lake. That's the best example of using data firehose. Here, why would you unnecessarily choose data stream? You don't have to figure about the shards or anything. You just want to save it. Kinesis data firehose is perfect for that. Or You want to create some sort of ETL jobs on top of the streaming data, which that every time you get this data, just save it somewhere into your data warehousing solution like Redshift. You just want to have a ETL job doing this for you. You can use Kinesis data firehose for that as well. Krishna has a question. What if I get 200 MB data in 60-second buffer interval? Will it allow to stream? And this is very interesting as well. So far we have talked about Kinesis data streams, we have talked about Kinesis data firehose, and then after this we are going to talk about Kinesis data analytics as well. So far, initially, as I mentioned, it was a Shazam family or it was a Marvel family. They put all of these things together as a bunch or as a collective. But later on, after launching this service, Kinesis family, they thought, okay, this one makes much more sense. If I put this three together, and this one as its own separate thing, because here Kinesis data stream can stream this data, put it to data firehose, and then you are allowed to do some sort of video data analytics as well. So it makes sense to keep them together. They are doing something or other on top of data. This one is video. Why not put it completely together? So the same thing, if you have to think about it. So if you have followed this comic or if you have seen this, you know that this Junior Marvel, he run away from the family and joins his own thing and does his own thing. So here the family breaks. Same thing happened with Kinesis as well. Now, how exactly video streams work is that this is actually my camera, which I got from while working at AWS, and this is my home as well. I put this camera just looking at my car. So over here, what exactly this camera does, you have this video stream coming in from this camera. Again, this one, it goes to my AWS account by using Kinesis video stream. I get the stream of images in my Kinesis video stream, which I can do a lot of things on top of it. So for my machine learning class or for other classes or my computer vision classes, I teach a lot of examples from this video stream section. So, and I've built a lot of applications for that as well. That I have one application which is, again, as I mentioned, this camera is looking at my car. So anybody comes near my car, I get this message in my phone and a notification in one of the app that I've developed that, okay, somebody is trying to harm your Katsumi. I call my car Katsumi. So yeah, I get this notification anytime anybody approaches my car. Same thing, a similar application which I have built is for my door, which is another camera. It is just looking at my door, and anybody apart from my mom, my girlfriend, anybody comes to our house, I get this notification intruder alert. So that comes immediately. So again, same thing I'm using. I have this live stream coming in from my camera. It goes to my Kinesis video stream. Over there, I have this custom logic I have created in a Lambda function that sees, okay, I have done the person recognition there. I have trained that model to recognize me, my mom, my girlfriend. And apart from that, anytime it sees another face, it sends this data to me by means of SNS notification that you are seeing here, simple notification service, SNS. The service, you don't need to know the service, but that's what it does. It gets some information and it sends a message. It sends a notification. As the name suggests, it's a simple notification service. Then AWS itself has built a lot of machine learning applications, which is about this recognition video, which you are free to explore on your own. Please go ahead and see all those machine learning applications that AWS built for videos. You will have video coming in and it will detect if there is a celebrity in that. It will detect how many objects are in that. It will detect what are those objects, whether it's a dog, cat, person, things like that you can do. Or you can create your custom license plate number recognition, a lot of things. Basically, again, that's up to you what you want to write. But yeah, that's how you use a Kinesis video stream. And what you need for this, again, as I mentioned, video stream, I gave you example of my house camera itself. It's just a camera that I have placed in front of my house. Again, you can have video stream coming in from your phone. You are just live streaming what AWS, not AWS, I was giving an example of Facebook or Instagram. They allow you to do this live streams. Same thing, you can do live stream over here to your AWS account using Kinesis video streams as well. So you can have data coming in from AWS camera. You can have data coming in from a third-party camera, which allows you to install certain application. You can have So as the name suggests, it is a Kinesis video stream, but it does not mean it just sends video. If you want, you can send just images. If you want, you can send sound waves as well. So it does have all those other things as well. So Kinesis, all it uses is it uses Kinesis video stream library that AWS has created. Just like how we have KPL, you have to install this library in one of your devices, and it will start sending data to Kinesis video stream. All you have to do is install this on your device for securely connecting to Kinesis video stream. And finally, you manage media sources and the stream lifecycle as your data flows from a media source to a Kinesis video stream as well. So it could be all of the sources that we talked about, what exactly should be the life cycle, when it should just get deleted, how much time it should be retained, if there should be retention, all those things you can configure. Now, as I mentioned, actually the videos are nothing but collection of lot of images or sequence of images. That's what it is. If you just want to save this video somewhere, you can do that. That's one use case. If you just want to play this video, like for an example, I use the same camera and I use Kinesis video stream itself to see if anybody is outside my door. So I can just keep on live streaming, though that would be unwise. It charges a lot of money. Better to buy a normal security camera for that. But yeah, that can be done if you want. Or finally, you can do some sort of analytics on this as well. As I mentioned, you can do like Boston police used it to create this registry of known offenders and keep on tracking them. And China heavily uses Kinesis video stream to detect your emotion, how you're performing, how exactly. Oh, one good example of Kinesis video stream is the certification itself that you're going to give. When you're going to sit for this certification, you are going to use a software called Pearson. And Pearson, earlier they literally had this a person looking at you all the time, checking if you are cheating or not. But now that person lost his job, not entirely, partially. There is still a person who looks at you, but instead of that person looking at you continuously without for like 3 hours or whatever is the duration of your exam, they have used some sort of analytics to see if you're looking here and there, if you are cheating or doing some. So they have all this tracking logic created by using all this machine learning algorithms, which does all of these things for them. Now, the consumers. So the question arises here is, do we need to consume and process the video stream in real time or after the data is durably stored? So obviously you can have real-time video analytics. As I mentioned, somebody comes to my door, it gives me a message. That's an example of real-time video analytics. Or if I just want to keep saving it, and then once I have good amount of information, then I want to do something on top of it. It allows you to do that batch oriented video analytics as well, that instead of doing it real time, immediately you have something and it doing something for you, you just store it and then do it on top of that entire video that you have saved so far. So what could be the consumers over here? So consumer, you probably can have an EC2 instance running in, getting this video stream, and then doing something on top of this stream. You can use AWS recognition. These are the services which are available for you to use, which AWS has created. All you have to do is just upload your video stream or put your video stream here, and they have all this machine learning algorithms already created, which does lot of cool tasks for you. Or you can integrate it with some other AWS service as well, or you can integrate it with a third-party service if you want as well. So these are the options of consumers you have when you use Kinesis video stream. Now, what could be the use cases over here? First one is obviously your smart city with Amber Alert system. What exactly this will do? You'll keep on capturing and streaming live video feed from your city cameras, and you will ingest or store this data and create some sort of index video stream from all these cameras. And you can probably use it to match license plate of suspected vehicles, send alerts to law enforcement officials that, okay, this vehicle crossed this particular area and all this thing. So you can have the smart city with Amber Alert system using Kinesis video stream, and just Google about it. You will know a lot of things. US use Kinesis video stream for a lot of use cases. And they had a lot of backlash as well that you are invading privacy, this, that, and blah, blah. But they did it. Read about it. It's interesting. And then you can have something like equipment preventive maintenance as well. So you can have all this. For an example, you have this Tesla factory, and it will keep on using this camera, which is a thermal camera. It will keep on ingesting this thermal images and stream it to your stream all these thermal profiles to predict some sort of overheating and take actions accordingly, do preventive maintenance and things like that. So again, somebody please summarize it for me.
So let's quickly cover the last service in the Kinesis family, and then we'll just see everything all together. So in this, we are going to talk about Kinesis data analytics, and we are going to see what exactly are the use cases of this particular service. So this is how it looks. You might have your data, as we have already seen. It might be coming in from a lot of producers, and we have to create an input stream. So input stream, you have two options. You can have a Kinesis data stream that is accepting data from your producers and keeping it in the stream, or you can have data coming in from Kinesis data files. And then finally, let's say if you want to do some sort of analytics on top of this data. So by that, I mean is just do some sort of SQL queries on this coming data, which is real time in nature. You can just do this select stream, whatever, from this particular source stream. Let's say you have all these people coming in. Let's say again, my example of 5,000 people are joining my class, and they are inputting all of their information from however they have logged in. I have captured their date of birth. From that, I did some transformation using Lambda, that you have the DOB. From DOB, you calculate their age. So this is my transformed data, that I did not have age as a field in my data. Using this DOB, I calculated their age. And now I have this age. I just want to see people who are greater than or equal to 21. So it will filter out all the results that I am getting. So this kind of things you can do using Kinesis data analytics application. So it's as simple as that. Then you can, once you have this filter stream, you obviously change the data. You have done some sort of filtration on top of it. If you want, you can put it back to the Kinesis data stream, a different Kinesis data stream, or if you want, you can put it into a Kinesis data files, and from there, everything remains same. You know what Kinesis data files does. It saves it to one of the respective destinations. Same thing goes for Kinesis data stream. Whatever we learned, like what Kinesis data stream can send it to, you will keep on doing all of those things here as well. So that's the use case, that's how it works. And we are going to see this, but again, just to give you a glimpse of how it works, you just go and write a query like this, that select stream, get only this information, and just filter it using this age equals to 20, greater than equals to 21. And it will give you all this results like this. For an example, all of this are my, let's say, trainees joining in my class. All I am doing is, first, this is my data. This is how it will appear in my queue or in my Kinesis data firehouse or Kinesis data stream. And once I have used real-time analytics, it will filter out results for everybody who is 21 or more. So that's how Kinesis data analytics work. And obviously, example of this is to do some sort of responsive real-time analytics. You just want to uncover some real-time monitoring metrics, such as what is the response time, what is the error rate spike, something of that sort can be a use case for this. Or you just want to manage real-time gaming metrics. You want to keep on checking every 10 minutes who is what is the aggregated score, or you want to join some important gaming data like gamers account and minimum maximum and their average time playing, something of that sort. You can again do all these things using Kinesis data analytics. So that's pretty much it. Again, it's your turn. Come on, somebody quickly summarize this for me, and then we'll head over to a demo. Okay, this is one website. That's what we are using. Somebody, I forgot who created it, but I just saw it on the internet. And this guy has done a great job. So here, it's just like how you have lorem ipsum for generating fake text. Here, this person has generated a website with all the fake information as well. So here you have the name of this person, image of this person, an email address, their birthday, address, number, as well as their password as well. So every time you refresh, you get a new person with new information. So the same library we are going to be using here, instead of using a UI, we are just using a data generator API that they have created, which I have. So this is how we use it, and this is what we get. So this is one example. So as you can see, every time I refresh, I get something new. But yeah, anyway, I'll just walk you through it. So this is how it works. You already saw how we create a stream. It just shows you, it asks you for shards, and that's pretty much it. Then it gives you this option of producers. We already talked about, you have Amazon Kinesis agent, you have the option of AWS SDK, and you have Amazon Kinesis producer library as well. So these are the things you can have for your producers. So you can go to their GitHub code. It has everything on how to download or how you use it. This is how you install it. You have to do all of these options. So you want to do something, everything is provided over here. This is Amazon Kinesis agent. Same goes for your SDK as well. This is the documentation for their SDK. It explains how exactly it works. And finally, producer library as well. As I mentioned, it's a Java library. So what you are seeing, everything is in Java as well. So these are the options you have for producers, and this is what you have for consumers. As I mentioned, what you can do is you can process this data, which you are receiving it in Kinesis data stream to a Kinesis data firehose, or you can use KCL library. Again, they have their GitHub page as well. Or you can process this data in real time as well, like do some sort of analytics. The same example that I gave, which is filter everything which is ages greater than equal to 21, something of that sort. So let me just try once more if it came. If not, we'll just skip it for today. There's too much latency for some reason, but I'm not getting success. This is your AWS service, which allows you to collect, process, and analyze real-time streaming data. So it is analogous to streaming data. Whenever you hear term streaming data, like how you think about Kafka, you should think about Kinesis in the cloud. So Kinesis, what is streaming data? Going back to fundamentals. So it's the data which is generated continuously from your thousands of data storage. We saw what could be this data storage as well. You could have your video streams coming from your security feed. You could have data coming in from sensors. You can have it from your Facebook, Instagram, Twitter. All of this are example of your streaming data. And we already talked about Kinesis use cases, and not just related to the use cases of Kinesis. We saw various use cases for different services. So I'm not going to repeat the same thing over here. Now, how does AWS Kinesis work? So you tell me again, you have everything required. I have already explained. Somebody explain what is shard. And what is a record? Record is a unit of data which is contained in your Kinesis stream. So basically your data. Now I mentioned already, I already gave you an example of the train. So a record, it consists of partition key. What is a partition key? It's just used to segregate and route your records to different shards of your data stream. So a partition key, it is specified by your producer itself when you're adding data to a Amazon Kinesis stream. So partition is by default already added by your KPL, Kinesis agent, or whatever. It will take care of this. It will create or assign a partition key along with your data. What is data blob? It's again a unique identifier for each of your records. So that's all a record is. It comprises of three things: partition key, data, and a sequence number. Now, the architecture, we have already seen that in my diagrams, but let's quickly go through it as well. As I told you, Kinesis, your data could come from various sources: mobile client, traditional servers, EC2 instances. It will go to your shards. And from shards, you can again consume it in different places. In this example, they are showing EC2 instances. Once you have done something with this information, you can probably finally save it in S3, DynamoDB, Redshift, EMR, or Kinesis Firehose. Not from here. Kinesis data stream does not do that. Kinesis Firehose does that. So if you want to put something which is in Kinesis data stream, you have to put that Kinesis data stream to Kinesis data firehose, and that data firehose will send it to S3. Now, how does Kinesis work? So your data, as I mentioned, it is ingested into your shards, which are nothing but your pipelines or your containers from your producers at the speed of 1 MB per second. Again, why
1 MB per second per shard. Okay, that's cool. Same goes for writing. Whenever it is writing to all of these places, your data is streamed to your consumers after processing or without processing. That's an optional steps at the maximum of 2 MB per second per shard. Then your instance have the option of storing or forwarding the consumed data to any of these places. So this is what we are going to do. I want to do a whole example, but this is what Intellipaat expects of me. Create a stream, describe the stream, list all the streams, add data to the stream, get the shard iterator, use the shard iterator to get records, and delete a stream. That's it. But we want to do the entire cycle. I'll work on it. I'll debug that error, and that's the first thing that we are going to do tomorrow. So why AWS Kinesis? Now, you might have heard about Kafka. Who has not heard about Kafka? Okay, so nobody's answering, so I can pick anybody to answer this. Tej, what is Kafka? So what is Kafka? Kafka was originally developed by LinkedIn and it was made open source by LinkedIn in 2011. And they basically created a distributed streaming platform with 3 capabilities. Initially, it had just 3 options. It can publish and subscribe to your stream of records, similar to a message queue.
Let's have a quick quiz question, guys. And the question is, which AWS service allows you to store and retrieve data in a highly scalable and durable manner? Option A, AWS Elastic Beanstalk. Option B, Amazon S3. Option C, Amazon Redshift. And option D, AWS DynamoDB. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data Certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
Or it stores stream of records in a very durable way. And finally, it can process the stream of records as they occur, which basically means where exactly LinkedIn was using it is, you might have seen in LinkedIn, they had this functionality of subscribe to a job or subscribe to something. So that's where they were using Kafka, that people have subscribed to a topic, people can send things to a topic, and those things, whatever I am sending, whoever has subscribed, they'll get that information. That was the whole purpose of Kafka, but Kafka now, at present, after it was open source to Apache, they did a lot of the things and they made it much more better. And right now it's one of the key things which almost every Fortune 500 company uses in some place or another in one of their pipelines. So Kafka is everywhere, it's prevalent. So what AWS has done over here, so if you'll see under the hood, Kinesis, under Kinesis, you will find Kafka. That's what they are using. Kinesis is nothing but it is built on top of Kafka, but it's just that Kafka is little difficult to manage. What are the problems with this? Now, again, coming to this example, if you want to remember this, every time I like to think about some sort of analogy to remember any keys tech stack. So over here, you might have seen how it works in cafes. You go to a cafe or you find this kind of boards. A band is performing here. This thing is for sale. This is there. This kind of ads put in their built-in boards in a lot of cafes. So people, whoever wants this information to be pasted, they'll go there and put all this information there. And people who wants this information, they come, collect this information, and everybody is happy. So that's how publish and subscribe model conceptually works as well. In short, it's called pub sub model. Somebody publishes a message and whoever has subscribed to that message, they seize that message, they can process that message. So at a very high level, that's what Kafka is. if you want to know more about it, I have already given the links and you can know more about Kafka. Now, this is Kafka, but managing this overall cluster of Kafka, it's pretty difficult. You have to make sure that your software is up to date. You have to make sure that there is high availability along with auto scaling. You have to take care of all that. Then you have to make sure that you have your zookeeper node along with your broker nodes. Everything is distributed across availability zone. And then you have producers sending message to one place, consumers subscribing and getting that message. Then you should have the option of creating a topic, and then people should have the ability to subscribe to that topic. Then if something happens to your one subnet, it should be able to basically spin up another cluster, until the time you should not have any sort of downtime. It should, instead of reaching out to subnet 3, it should reach out to subnet 2, and everything should keep on going. So as you can see, there is a lot which happens with Kafka itself. But AWS wants to simplify this. They did not want you to do everything. If you want, you can do this, create your own Kinesis, not a problem. But as you can see, there are a lot of moving parts involved, and that's why it's also a managed service. They take away all this headache from your head to think about this Kafka cluster altogether, and just worry on whatever you are doing with it. So under the hood, nothing but that. But how Kinesis is better than Kafka? Because in Kinesis, you pay according to your usage, and you don't have to rent out or buy this entire hardware resources irrespective of their usage. Because as you can see here, you will need this server running, you will need this server running, you will need this server running, then you will have another server running, which will have the zookeeper node, then broker node should be able to talk to zookeeper nodes. You have to write code to make sure that happens. Then you have to write code that is inside of VPC and that sends something to a subnet, then consumers get that information. So a lot of code is required to achieve the same thing, and maintaining that, it is a lot difficult. But Kinesis, it's just a managed service. It takes away all this headache from you, and it gives you much more flexibility as well, so that you don't have to actually doing this. In my organization, we have literally a DevOps team which maintains this Kafka itself. Whatever problem we have, we reach out to them. So for us, it's like Kinesis itself, but they do a lot of things. So unless you want this entire team to manage your Kafka, you should basically go for Kinesis, and that's why they made this as well. Now, Kinesis manages and maintains all of these things which I showed you, as obviously it is a paid service, so they charge you for it as well. So that's why Kinesis is better than Kafka. Instead of just explaining it in this 4 points, I wanted to give you entire brief of how the architecture works, so that you have an idea, a fair comparison of what all AWS is doing for you. Now, what are the key advantages? It is cloud-based, divide and again, Intellipaat being Intellipaat, just giving 5 points. Scalable, manage, fast, divide and conquer. You send a message, you subscribe to a topic, whatever. So overall, what is happening here is Kafka or Kinesis to send this information. If what your question, if I understood correctly, you want to search for this person. Where is Taylor? What is the information related to Taylor?
Yes, yes. Suppose that is multiple requests in there, and I just want to search this one. How the
That is
searching will be
dependent on your
faster.
logic, but it's pretty fast for sure, because every information you know that you have it in Shards. Shards anyway is handling only what? 1 MB per second read, 2 MB per second output. Reading or filtering from this small data is anyway fast, right?
Yeah, but I'm thinking like if there is a huge data, is there how we're going to search the data? Like
Whatever data is saved in S3, if it is supported, Athena, you can query it in Athena. And that is entirely dependent on you, what kind of query you want to write. Even if, let's say, a data is map of, array of, list of string, it's your job to frame that query and just get results from it. Here, we are just sending things and we are receiving things. That's all. And that's what it is explained here as well in this divide and conquer. So Kinesis makes it so that your data collection, it is separated from data processing. So that's what Kafka does as well. That you are sending data, that's done. It will collect that data. But let's say you want to process that data 24 hours later or immediately or 365 days later. That is up to you. It has decoupled this two things from each other, data collection and data processing. And that's what makes it fast as well. And you have already seen that. Why it is fast? Because it reads 1 MB per second and it's faster to write that as well, which makes it extremely efficient for real-time streaming. And managed, as you saw, I explained it over here in this, that at the back or under the hood, all these things is what AWS is doing to keep Kinesis up and running for you. And obviously it is scalable. You just have to increase the number of shards and AWS will take care of all these things. But otherwise, just think about it. Let's say you created T2.micro instance, which is like 4 MB RAM or whatever size, right? If let's say you started getting too much data and you have to scale, again, you have to go change configuration of your EC2 instance and do a lot of things there as well. But when you're using Kinesis, it's automatically scalable. All those things AWS is doing for you. People have their own ecosystem. So for an example, my organization itself, we do not use AWS because that is our thing. That obviously Target and Amazon, they are competitors. So that thing is there. But we have this thing that we do not use AWS products. In that case, what I'm left with? Kafka. Kinesis is built on Kafka. Then Kinesis, it's much more expensive than Kafka. So if you do this over, again, it's your call or it's your organization's call to figure out if you have this tech expertise in your company to handle or manage that cluster for, let's say, X amount, or let's consider it like, let's say $100. Obviously, I'm just making up numbers, but let's say all those operations which I showed here, doing all these things, it takes $100. Okay. Now, when you use Kinesis, you will end up spending $120. In that case, we are saving some money because we are ready to do this much hard work. We have this team who can handle all these things. So obviously, Kinesis is little expensive. That's why they do all these things at what? For not for free. It's just your job to decide if you have the expertise to do all that and you want to invest your energy there. There are a lot of companies which are product facing, in terms of they just want to quickly deliver a product to user, versus there are companies which are building their ecosystem. They want to create things by themselves. They don't want to use this third-party resources, which like Kinesis. Now, features of the AWS Kinesis, I have already told you, so I'm not going to, but you can just quickly glance over it and see if you have any questions on it. I think I explained this in different visuals and graphics. So some diagrams which are present on AWS page itself. So your input, it could stream media from a lot of places. As you can see, camera devices to AWS using your Kinesis video stream SDKs or API or Kinesis agent or something. Then you can use Kinesis video stream. It will ingest this data. It will send it to a lot of places like SageMaker. I don't know what all they have written, Sega Maker, but it's SageMaker. You can run some sort of machine learning algorithms on it. You can just stream it or use all those things which I mentioned, like send you alert notification and things like that. Then data streaming, same thing. Let's say you're getting this Twitter feed, phone information, logs data, or whatever. You send it to Amazon Kinesis data stream. Then you run this data analytics on top of it. The age greater than equals to 21 example. You can send it to EMR to do some sort of other processing. You can send it to EC2. You can send it to Lambda, and finally visualize this output as well. And data firehose, as I mentioned, data firehose is as simple as it does not do anything apart from saving your data. That's all. So whenever you have this requirement that you want to save your data to S3, Redshift, Splunk, or Elasticsearch, or just use it as a REST endpoint, you can send it to firehose and it will take care of this. And finally, as I mentioned, all this data that you are getting in this stream or data firehose, you can put it to data analytics. It will query that data and it will show you that output as well. So these are some use cases which are present in AWS pages. Now, finally coming to AWS Kinesis components. Okay, no volunteers. So Amazon Kinesis Data Stream Producer is an application that put user record data into Kinesis data stream, also called data ingestion. KPL simplifies producer application development, allowing developers to achieve high throughput to a Kinesis data stream. Now it writes to one or more Kinesis data streams with an automatic and configurable retry mechanism. I already mentioned this and showed it in that differences as well. It collects records and uses this put records to write multiple records to multiple shards per request. It aggregates user record to increase the payload size and improve throughput, which is basically, for an example, it might be what, few KBs, but that's a waste of resources if I'm just sending few kilobytes. So when this goes to KPL library, what it does, it aggregates this kind of record to increase the payload size, because what is the limit? 1 MB. So it makes sure that it has data worth 1 MB or somewhere close to it, so that you are utilizing your shard. Otherwise, you are wasting it. You're paying money for one shard, but you are not using entire shard. So this library takes care of that. It does that. Now, KCL, it integrates obviously with KCL, because if you're sending something, you have to consume it somewhere as well. So, and finally, it submits your CloudWatch metrics on your behalf so that you can have some sort of visibility in how your producer is performing. I'll stop here to see if you have any questions on it. We have covered a lot of things already in my slides, but yeah, this was one new thing which I explained. Where exactly you want to send it, how do you want to send it, and things like that. Basic things, configuration. Again, depends on what you are using here. I already explained it. If you are using Kinesis agent, there is something. If you are using API, there is something. Then if you are using KPL, it's something else. The terminologies, do remember there is a distinction between a KPL user record and Kinesis stream record. They just like to confuse you with this. So let me explain what exactly this means. Your KPL user records, it basically means that your data. This is your KPL user record. In this case, this is my data. This is what I'm concerned with. Now, what is the other thing? Your Kinesis stream record, it will have this data along with two other things. What are those two things? Again, we saw it in our slides. Okay, and the next thing is batching. So what exactly is batching? As I mentioned, to have this thing, instead of basically performing a single operation on a collection of items, rather than performing the same operation on multiple items individually, it's basically, instead of me sending just one record, I collect few records and send them together. That is my batching. So batching implies sending records to the Kinesis stream. There are two types of batching. One is aggregation and one is collection. We'll quickly see both. So aggregation is storing multiple records within a single Kinesis data stream record. Multiple records under single Kinesis data stream record. So my Kinesis record, which has sequence and partition key, it will not just store this one record. It might have 10 records. And that is an example of aggregation. Now, collection, it is using the API operation, which means put records to send multiple Kinesis data stream record to one or more shards in our Kinesis data stream. So in this case, basically what we are using is, we are using API, which is put record, to send multiple Kinesis data stream record. So what we collected over here, this one, let's say I have 10 of this. This is Taylor, then there is some other person, then some other person, some other person. We have information about 10 people, and that is called as my Kinesis data stream record. So in aggregation, what we are doing, we are storing all these 10 records together, and that is called as here, that is under your single Kinesis data stream record. Now in collection, what we are doing is, sorry. So I can probably save 10, 10, 10 in just one shard itself, because my shard has this capacity of 1 MB per second. So in this 10, probably I have a record of 30 KB. Another 10 is 300 KB, sorry. Another 300 is, another 10 is 300 KB more. So that kind of makes my 1 MB. So that's an example of collection, that in one shot, I'm trying to utilize the entire space. So whoever asked this question, producer library, I already told, but this is how it works. A basic producer application, which is a Java code. So you do something like this, very simple. For this to this, blah, 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 Kinesis dot add user record. As simple as that. You have to do only this much. You take your data, you write this for loop on that data, and just keep on adding that data to your Kinesis data stream. Pretty simple. Same goes for your consumer, just like we saw what is producer library. It produces that. Consumer, it consumes that. What are the things? It connects to your stream. It enumerates the shard, which means it sees what all a shard contains. It coordinates shard association with other workers if required. So as you saw here you have multiple workers. So if required, this is able to do that much as well. They have written code for it. You don't have to do anything here. It instantiates a record processor for every shard it manages. So whatever information I've received. So for an example, I already got the data for Taylor. It will make sure that this data is not duplicated, or it will keep a track. Okay, Taylor data, I got it. Call it 1. I have already processed it, something of this sort. So it obviously pulled data records from the stream. It pushes the records to the corresponding record processor. So as I mentioned, for every record processor, it will make sure that it knows its state, where exactly is what data, and you can reference it accordingly. It checkpoints process records as well. The same thing. It keeps on having a track that, okay, out of 300 messages, I have consumed 200 messages. Is balances shard worker association when the worker instance count changes. It balances shard worker association when shards are split or merged. This we have not talked about yet, but there is an option called resharding, which means you can have probably started with 5 shards. You can have 10 shards now. You can have 2 shards now, or you can merge 2 shards and things like that. So it manages all those things. And this is some basic code, how it looks. This I'm not spending much time on. This is Intellipaat slides. This anyway you will get, so you can go through it. But it's pretty simple. As you can see, it's like set limit, get records. It's not fancy even if you do not know Java. It's pretty simple to know. Not Java, this code.
So over here, you have 2 options, standard create and easy create. So easy create, as the name suggests, is an easy option. You don't want to take care of a lot of best practices, configuration, and do your database setup as per those. That's why AWS has created this template kind of thing for you, which fills in as per the best practices. But if we do that, we are going to learn nothing about RDS. So I'm going to go with the standard create option. And over here, what do you think? What should I choose? Anything? MySQL. That's the most common one as well. So we'll stick to MySQL, but you can choose any of this. These are all the relational database engine types that are supported in the cloud. You have Aurora, which is, again, we discussed about 2 flavors. One is MySQL compatible and another one is PostgreSQL compatible. Then you have MySQL, obviously. Then you have MariaDB, then you have PostgreSQL, Oracle, as well as Microsoft SQL Server as well. Now, you know which ones are what. Some are very costly, some are open source, so they don't charge anything. All those things. But again, those are out of scope. We are discussing RDS and not this engine types like Postgre or MySQL. Now, this is a very good option. If you are installing it by yourself on an EC2 instance, you can obviously do that. But again, you have to figure out what version you want to go for and specifically download and install that version and do some updates related to that, maintain it, and a lot of things. And again, being a second level service or managed service, it takes away all this work from your hand. And here, as you can see, by default, it's selected 8.0.33. But the example that I have created, it is compatible with 8.0.28. It might be compatible with 8.0.33, but I have not tested it. So I'll stick with this one, which I showed in my last class as well. And over here, as you can see, you have few, again, template options. If you're using for production, RDS will make sure if you are using it for production, it is highly available, fast, consistent, and gives you consistent performance by making sure it is replicated in 3 places. Then it is dev test as well. So if you are doing just development, it's not production ready, and you don't want highly available cluster, you can stick to this one. And practices will, as you can see, it selected single DB. Production, it automatically selects multi-AZ DB cluster. Now, for our example, we can stick to free tier, and as it is free tier, you can try this by yourself as well, because it won't charge anything on your account. Over here, I'll call it my WordPress. And me being very lazy, I'll let my username as well as password both be WordPress. Obviously, you will not do this when you are dealing with a production cluster. It will have a very strong password. Now, these are the instance type. When you create an EC2 instance, you have the instance type as well. And as it is a second level service, it is created on top of those instances. So how much power, compute power you are going to get versus how much you are going to spend money on it, everything is dependent on this instance type, whatever you are choosing over here. For our example, we'll stick to something which won't cost us much. So db.t2.micro, because we are not going to be doing much. Now, standard, I can leave this blank itself. I am not going to be occupying 20 gigabytes for this demo. So 20 gigabytes is more than sufficient for me. Now in connectivity, we are going to choose the existing VPC. So where is that? Connect to an EC2. We are going to be connecting to an EC2. This is a new option actually. They did not have this earlier. So this is actually a good option. Otherwise, in my last class itself, what I did is I created a VPC. Then in that VPC, I made sure that my EC2 instance had the necessary security group setting to talk to my RDS instance. But this is a new option and much more convenient option that they are asking you to choose a EC2 instance, which I have already created. So it is coming up in this dropdown, and it will make sure that both are able to talk to each other without any problem. Actually, but again, you will not learn anything. So I'll select do not connect to an EC2 compute. We are going to see for whatever reasons, if you want to learn something, do it the hard way. You can remove the default. Now, under availability zone, you can choose whatever you want. It does not actually have any effect as such, but where is it? Yep, additional configuration, password authentication, blah, blah, blah. As you can see, it gives you 12 months of free tier available for you. You have 750 hours of Amazon RDS under db.t2.micro, the one we used. Or this, you have 20 gigabytes of memory. You have 20 gigabytes for automatic backup storage as well. All of this is for free. Here, you can again call your database whatever you want, but I'm going to call it WordPress. And under backup, you can uncheck this option, which is enable automated backups. Right now, we do not need backup. It's a very simple example that we are doing, and just hit create database. So that's how you create an RDS database. It's as simple as that.
As you can see, as it is a managed service, they took care of all these things for you. If you are doing it yourself, again, you will know, if try to do it yourself, you will know what all is involved in there. Now, simply suggest add-on for WordPress. Simplify the configuration of one of the points. This is few more additional fancy things that they are introducing. So they are asking us to create an elastic cache cluster that will improve your performance by 80x, and it will reduce your cost by 55%. But again, for our example, we do not need it right now. And they are asking us to use RDS proxy as well, which we again do not need for this example. But yeah, production level use cases, you can take advantage of those things as well. Now we have done all this thing. It is going to take few minutes to create this database. Till then, and I am already inside my EC2 instance. As you can see over here, I'm going to be installing the Apache 2 web server, some libraries, PHP and PHP MySQL, because we need all that. Okay, so once we are in our terminal EC2 instance, as you can see, just type this sudo apt install Apache 2, lib Apache 2, mod PHP, PHP MySQL, and give permission of yes to everything. Oh, sorry, mistyped. It is PHP. Currently, it's just an EC2 instance. To actually convert it to a web server, I need all these things. Now, what this will do is create a directory. I'll show you what that is. And we have to make some changes over there as well. As you can see, it will create cd var www. This is where you get the content, what exactly appears on your website. So just go over here, do the ls, you will find HTML. Now what you have to do is you have to do. Now we need to change the Apache configuration file in order to enable the WordPress website to work with your this particular web server. So for that, all you have to do is sudo this file called 000 default.conf etc. Hey, why it's not finding? Oh, Apache 2 sites enabled and done. After this, we'll just restart our Apache 2 configuration. So for that, sudo Apache 2 ctl restart. Now, we need to do another thing, which is put the details of a database in a WordPress config file. So for that, we'll create a new file, sudo nano wp config.php. Click on your database. As you can see, you have WordPress database available. Under connectivity and security tab, just under this endpoint, copy the endpoint which is provided over here. And you just have to change this line called define db host localhost. And instead of localhost, because right now we are not working in local, in just your laptop and just your Mac or whatever, you are working with AWS. So you have to just replace this endpoint localhost with this endpoint and just save this file, Control X.
Why? Now, what you have to do is go to your EC2 instance. In the left-hand side section, what you will find is networks and security. Under network and security, click on security groups and click the check mark next to the non-default security group among the provided ones. And it will open this inbound rules for you. Under inbound rules, click on its edit inbound rules and just click on add rule. What do you think we are going to add here? We have to discuss something called as enhanced fan out. So enhanced fan out, it is an optional feature, but it can come in your examination. So let's quickly discuss what exactly it is. So this is a feature that Kinesis data stream provide to its consumers that provides logical this throughput between your consumers and shard. And the capacity I have already mentioned, it is 2 megabyte per second when you're writing it to your consumers. Now this allows your consumer to scale the number of consumers reading from a data stream in parallel while still maintaining the high performance. What basically this means in a simple language is that this is your Kinesis data stream. It is writing some output at 2 MB per second. Now, if you want, you can send it to just one place, for an example, Kinesis data analytics, and do some analytics on top of it. Or if you want, you can do something in parallel. I think somebody asked that as well. So with the same data, let's say you just want to save this data, you want to do custom transformation on this code by Spark, and for whatever reason you want to do it via Lambda or EC2 as well, you can do all of those things together in parallel. Now, what enhanced fan out does over here is shown, which is it takes this information from this shard. It can put it to this particular consumer. If you want, you can route it to another consumer as well. And same goes for the another shard as well. If you want, you can distribute information flow from one shard to n number of consumers to allow some sort of parallelism. That's all enhanced fan out is, that you can fan out this kind of request. Now, Kinesis data firehose, we have already covered it in our slides, in my slide, sorry. In that, I've already explained it. Now, quickly, you tell me what is Kinesis data firehose and what exactly it does.
Kinesis data firehose.
So if your purpose is to store data to Redshift, to S3, to Splunk, or Elasticsearch service, all you have to do is use data firehose. You cannot use data stream there directly, because stream, as the name suggests, it streams information to consumers. It does not actually store it as such. If you want, you can have custom storage logic in those consumers, but again, directly it is not able to store information. Hope that makes sense. So this is the example. We have gone through the elaborate example, which was similar to this, where all it can store information apart from S3. So in my slides, we covered all of this, Kinesis data analytics as well. And apart from that, we covered Kinesis video stream as well, which Intellipaat slides does not talk about. Now, there's one more thing which they miss on, which I think is important for this certification, is Amazon managed streaming for Kafka. And this you will feel easy because we have covered few components of it. So over here, we are going to talk about what is Amazon Kafka. Actually, I'm not going to talk about it because I talked yesterday. So you are going to teach me what is Amazon Kafka. Then we are going to talk about how to manage a Kafka cluster. Then we'll see what is MSK cluster architecture that AWS has created. And finally, we'll compare MSK with Kinesis data stream. And we are going to see some of the use cases, and we'll end the session, or we'll end this particular topic by summarizing everything we covered. So this you have already seen. This is how a Kinesis family looks like. You have Kinesis data stream, you have Kinesis data firehose, you have Kinesis video streams, and you have Kinesis data analytics. Now, what is Kafka? You tell me that. Something different is there. I mean, this is much more managed, much more curated to cater to AWS consumers' need, and a lot of those things. So over here, you can see that it is quietly, so it's quite coupled with the AWS infrastructure itself.
And there are a lot less options of doing something which is custom or something which you can configure from your end. That Kinesis family does not allow. But let's say you have the need, you want to change few things, how you want to subscribe to a topic, how you want to publish topic, and you have your custom needs. For that, you cannot use Kinesis. It is not made for that. And that's why it becomes not useful for you. In that case, you can go for open source application, which is Kafka, or AWS giving you second option apart from Kinesis family, which is Amazon managed streaming for Kafka. Kafka, this I have already talked about, so I'm not going to repeat myself over here. I have shown you how Kinesis uses Kafka under the hood, how this cafe example works for publish and subscribe or pub sub model that Kafka and Kinesis both follows, and what exactly is required to maintain a Kafka cluster. And managing a Kafka cluster, I told you how difficult it is. Can somebody quickly summarize that for me as well? What all things are involved? Definitely for a minimal architecture, which is supported only for your local use case. I'm not talking about production use case. Even for that, you need at least 2 EC2 instances. Or if you're having a multi-EC, then at least you need 4 EC2 instances, one for Zookeeper nodes because Kafka uses Zookeeper as well. Then you need 3 instances for broker nodes, which are again 4 EC2 instances running. Then you need to have a way of allowing traffic between all of them. Then you need to create this custom VPC, which allows all of this information to flow together. And then you have other overhead, like how this works, when what happens when it breaks and things like that, and all those things. So there's too much things involved. And that's the benefit of MSK as well. So if you do not want to do all that, AWS has done all this for you. Firstly, they have done all this under Kinesis, which is much more managed. But even if something which you require, which is not that much managed, they have created this another managed service called MSK. And that gives you a overall production level working Kafka cluster or a Kafka ecosystem. So how does it differ from Kinesis data stream is very important to understand so that you can differentiate why they have created Kinesis first, Kinesis data stream, and then they have created MSK as well. And how does it differ from using the actual Kafka cluster? So somebody quickly, please read this for me. Then I'll try to explain, or if you want to volunteer, please go ahead. 10 gigabytes per second. All you have to do is increase the number of shards. So that's pretty easy, right? That is throughput provisioning model. Whatever is your throughput, you just provision it using the shards. Now, MSK, you saw it here that I gave you this example that this MSK is for just one particular, your local need or some development needs. It is not production ready as such. If you want to make it production ready, you have to increase the cluster size. You have to increase the number of instances. So little bit of configuration is required from your end. They are doing that scaling as well. But again, input is required from your end, which is little more complicated than just providing number of shards. Agree? So second point is kind of correlated that it has seamless scaling. You do not have to worry about scaling. It keeps on scaling, just spaces the number of shards. In MSK, it is not that seamless to the client. You have to, if you have more needs, let's say today you started sending topics and only 10 people are sending topics. Now 100 people started sending topic to this Kafka cluster. You have to go increase the size of that instance or just increase the number of instances. So it is not seamless to the client. Now retention, that is a big point. Now retention for Kinesis data stream that we talked about was, it is just 1 day. Maximum it can be 7 days. Or even if you want long-term retention, it can be 365 days. It cannot be more than that, right? But in MSK, this is one good example of why somebody would want to use MSK over Kinesis data stream. That over here, retention is unlimited. Whatever amount of time you want to keep that data, you can keep it. Now, another advantage, it has deep AWS integration. MSK has strong third-party tooling that you can use other tools apart from Amazon as well or AWS as well.
All right, need to stream. Okay, so Firehose can easily stream data directly to a final destination. First, the data is loaded into S3, then copied into Redshift using the copy command.
I think I taught you that, right?
Yeah, I taught you that too.
Thank you. Please read the second point and try to answer it as well. Anybody can answer. It's not just for him. Again, you need to be good at reading. And I told you why we are doing that simulated exam question is you have to pick the highlights. What is the key task at hand? You have to figure that out. So over here, the key term being real-time data. Over here, if you say Neptune, that is a graph database that does not deal with real-time data. So think real-time first, and then read the rest of the things that it wants you to store it to S3. It needs to create graphs. That's good. I'll just add on to it. So let's say we got this, let's say IoT data coming in from your Apple Watches. Apple Watches, they keep on monitoring your ECG, blood level, and all those things. Let's say you want to figure out anomaly. So what you can do is you can use Kinesis data analytics that give me the data for people whose blood rate is, oh, sorry, not blood rate, their blood oxygen is lower. Let's say this could be one example of Kinesis data analytics. And what about Kinesis video stream? We could have many more examples like what I explained, that I had a camera where I see who is at my door and do some analytics on top of it. Or I could have a license plate recognition number where you have a list of offenders. The car might have been stolen and you're trying to identify this is a stolen car. You can have those kind of analytics done on this video streams coming in from your live city cameras as well. So resharding is basically splitting or merging of your shards in order to increase the increase or decrease your throughput. So for an example, you are going ahead and you are getting a data which is 10 MB per second. You probably are sending much more data. In that case, you might want to merge two shards. Or if you are getting much more lesser throughput, in that case, you probably want to remove few shards. So in that case, instead of removing shards, what you can do is you can merge two shards as well. This is another, what do you say? The option or the ability that Kinesis data stream gives you to reshard. Either if you have 10 shards, you might want to merge it to 5 shards, or if you have like just 2 shards and you want to have another stream, you want to have some sort of resharding there or merge it with that shard, you can do that as well. It's a little complex option in this theory itself. Even I know that that is not covered here, but again, that is out of scope as well. But those options are there. If you want, you can have splitting as well as merging of shards in order to increase or decrease the throughput. And apart from that, you have Kinesis data stream management console as well. And that you can see it in the console or the CloudWatch as well, which shows you all the metrics related to it. So whenever a question comes, which is about where should I monitor this, your answer definitely is going to be CloudWatch. Now, the next question is, what compression format can I use with Firehose? This is a good question. And so do remember this. That's why I have this FAQs for you as well, so that you can grasp all this information and remember this for your certification. Again, there are certain things that you have to logically understand, and there are certain things where you have to cram that information. There's no other option. So this is that scenario. You have to remember this information. So Firehose currently supports gzip, which you mentioned. Apart from that, it also supports zip, which is the most common and the popular format for compressing something. And then you have Snappy as well. If you have not used Snappy, I would definitely recommend it. It's very good for compression. And also do remember that gzip, it's supported for everything else, but when you are loading data into Redshift, zip and Snappy are not supported. Only gzip is supported. So yeah, that's something to remember. Now, the next question is, how often does Firehose deliver data to my S3 bucket? And it might be silly to think about this. It's pretty obvious, but some people have answered this question incorrectly. And that's why I put it in my FAQs here as well. So what is the answer? This is determined by the buffer size and buffer interval that we discussed already. And I want somebody to volunteer here and explain what is buffer size and buffer interval. Correct. So this basically, again, from this, what you should infer is that there is a delay or some sort of latency when you're using Firehose. then you should be able to understand when they are asking a question about, I do not want latency. In that case, you cannot go with Firehose. You definitely have to go with Kinesis data stream. That's one. Then whenever, even if you can afford some sort of latency, you will go with Firehose. You should know the limits. How much should I wait? Or how much data should I have before sending it to the destination? So Kinesis expects you to have at least 1 MB of data to be accumulated. And I gave you that example of that API, which was generating fake user data, their name, date of birth, address, and whatnot. It was generating all of that for you. You were accumulating. Let's say you have 12 users or 12 customer information, which is equivalent to 1 MB. Once you have that, then you will save it in S3. Before that, you cannot do that when you're using Firehose. And if you want, you can have it to 128 MB as well. That is again a customizable option or configurable option that you can set. Same thing goes for buffer interval. If you think I can afford to save data every 1 minute, go ahead with it. If you think I can afford to save data every 900 seconds, go ahead with it. This is what Firehose provides. And how is my data organized in my S3 bucket? This is a very important one. It actually came in my certification examination question. So what do you think? I have shown you how exactly S3 stores data. It's a real-time data. The answer is in the name itself, that you will have some sort of partitioning based on time. So how it partition your data is first by year, whatever, let's say you are storing data right now. It will store it in 2023 month, the 9th month of the year, which is September. It will create another structure or a directory, which is September, then today's date, today's hour, whatever, whenever you ingested the data, that will be the hour. And finally, it gives it a name like this, whatever is your delivery stream name. Let's say in our example, we called it Harsh data stream. So it will start with Harsh data stream. Then delivery stream version. You will have version 1, 2, 3, whatever, till n. It will have that. Then it will have year, month, date, hour, minutes, seconds, and a random string at the suffix as well. So this is how your data is organized in S3 bucket. It's a very logical question to think about, and it can come up in your examination as well. So again, I want you guys to remember this. Again, actually, this is not something to remember. This is something to logically think of how you would want to store a real-time data. And the very last and my important or my favorite portion of whatever I'm teaching is the simulated exam question. Jayabharti, can you please read this? Okay, so the next topic is about a lot of things that you need for data migration. And here we are going to discuss how do you move massive amounts of data? What are the database migration services that AWS provides? What exactly is Direct Connect? And what is the Snow family? I really love that. So, and finally, we are going to summarize this section as well. So this is one illustration I have put out. If you have dealt with it, whenever you're moving in from one house to another, there's a lot of things required. You need to pack your stuff. You need to arrange some sort of packers and movers, and that's how you finally move your stuff from one place to another. How do you do that when you're dealing with data? So for that, we have AWS has created few answers for us. So what is the smartest way to move gigabytes, terabytes, or even petabytes level of data from your current location? It might be in your home, industry, startup, or whatever you have set up. If you're looking to migrate from your current place to AWS, what is required in order to move all of these things to cloud with minimal disruption, cost, as well as time? AWS has answer for this as well. So this is just one general rule of thumb that I have created. Don't take my word for it. You might find other answers on internet. This is just my understanding on it. So whenever you have less than 10 Mbps of internet connection, that's what I have in India at least. My internet connection is kind of like this, 7-8 Mbps. With this internet connection, what you can do is you can move around 500 gigabytes of data without any managed services or anything. You just need your internet connection, laptop, and AWS account, and you can move this much information. But whenever you're dealing with data which is much more than 500 gigabytes, In that case, you are going to definitely need internet connection with this 10 Mbps. I do not know if your country provides that or not. In that case, you have to go for some sort of managed service if your country does not provide that internet bandwidth. So there's a few operations or options that AWS provides, which are related to database migration services. So you might have a situation which is hybrid cloud storage, where you have your on-premise application and you want to do some sort of rapid data transfer to cloud. Or you could have online data transfer, which is just me. Let's say I'm sitting at home, I want to move my data. That is what I'll go for, which is online data transfer. Example of that is you uploading something to S3. And finally, AWS provides this as well. And that's where the Snow family comes in, which is offline data transfer. You're sitting at home, enjoying your meal or whatever. You just want to move your data. In that case, how do you do that? So we'll quickly see that. So when you're doing hybrid cloud storage, you can use something called as direct connect. So you will be connecting to your internet to AWS using this internet connection, which is provided to you by direct connect. And you can have or achieve a speed of 1 to 10 gigabytes per second. Here, I'm not dealing with megabytes per second anymore. AWS provides you this option of AWS Cage, where your data first goes to this and finally to customer, and then there to it's their location as well. So what they do is they provide you, instead of whatever internet speed you have, you can use direct connection, and that will increase your bandwidth to 1 to 10 gigabytes per second. And that's how you can move your data to cloud. Direct Connect allows you to do that. Direct Connect, instead of using your regular internet, it uses AWS managed internet, which has much more better bandwidth, less obstructions, less endpoints or things to move from. And that's how they do it. So even if you're using your own internet, you connect your internet to their internet, and that's how everything streamlines. That's what you can see in this diagram as well. Whatever Wi-Fi connection you have at your home, you are actually connecting to your ISP. Let's say from my use case, it's a company called X. I connect to their servers, their edge locations, or whatever they have in place to provide me that bandwidth. I get that bandwidth. Now what AWS does, they take your data from this, and first it takes that data to their edge location, which already has this 1 to 10 gigabytes of speed. So instead of using your internet, so when you're using direct connect, you're not using actually, technically you are using it, but in theoretical aspects, you are first connecting to their location, and that's how the transfer of information flows. Okay, so that's a solution for a hybrid cloud storage solution where you want to move things from on-premise to cloud. Now, for online data transfer, you have few options. We have already seen one of those, which is actually two of those, which is transfer acceleration, which is kind of same thing. You use CloudFront in order to we have talked about this, so I do not want to delve more into it. S3 transfer acceleration, I hope you remember that. Then you have Kinesis data firewalls as well. If you are moving data directly using your own internet, that's what you use. Then you have data sync. It's basically some automation to move data between your on-premise storage to S3 EFS FSX for your Windows file server. You can do that with data sync. As the name suggests, your data will be synced. Whatever you have in your location, it will be synced to one of these locations using this online data transfer. Here you're using your own internet. Then finally, you have a fully managed support for file transfer directly into and out of S3, which is using FTP, SFTP, and FTPS connections. Again, this is you're relying on your own internet. Now, that's pretty much about online data transfers. Now, they have one more offering, which is Snow Cone, which we are going to talk about. This is how Snow Cone looks like. I have put the diagram as well so that you can have some sort of reference to the list, how exactly this device looks like. You connect to this device. Using this device, you're automatically connected to AWS Internet. And that's how you collect, process, and move data to AWS Online with using this data sync option that you have over here. It's much more streamlined. Then comes the Snow family. Don't go with the illustration. This is not how it works, but this is how I imagine a Snow family will look like. So in Snow family, I would like to think about this dad kind of figure or a father figure as the biggest person in the family. Again, not being sexist or stereotypical, but that's how it works. So this person would be the snowmobile, which is the person capable of handling most amount of data. Then you have Snowball, the wife in the family, and finally the child, which is Snow Cone. This person is able to move some data using data sync as well. How it works, you have this offerings from Snow family, which is Snowmobile, Snowball, Snow Cone, and finally you have Snowball Edge as well. Now we are going to talk about all of these things. So how I would summarize this is, whenever you are trying to move massive amounts of data, forget about it by moving with your local means. Just put it into S3. It does not work that way. I told you few good options. You can do it via that multi-part upload that use some sort of threading and parallelism, and that can achieve gigabytes level of data, but that cannot work for petabytes or exabyte level of data. For that, you have to go with Direct Connect, Snowball, or Snow family related services. So that's how you move massive amounts of data, whether via some managed service or some unmanaged service. Then there are some data migration services as well, and they typically fall into one of the segments, whether you're trying to move data from hybrid cloud storage, when you're trying to move it from online cloud storage, or when you're just trying to move a lot of data which does not require any online solution and you need an offline solution for that. Finally, you have Direct Connect. Remember that Direct Connect can take data which is from 1 gigabyte to 10 gigabytes of dedicated network, which AWS provides you. If you can think about moving your data with this speed, you can go ahead with it. Then I explained it to you. What is Snow family? Snow family has a father, mother, and a child. And father is a snowmobile, which can move exabytes level of data. Snowball is the mother of the family, and it can move some petabyte level of data. And Snowball is the mischievous child, which can do both. So now we are going to learn more about database migration services. And over here, we are going to learn what are the migrating data questions which might arise when you're trying to move data. What is DMS, the service that AWS provides, and when do we use it? And what are the supported migrations from it? And how does it work for replications? And finally, we'll summarize this section as well. So yeah, as I mentioned, I am a very lazy person. I do not like too many information in my head. So I want to keep something simple and analogous. I want to do some analogy for everything. So how I would like to think is that at the time when it is Antarctica or somewhere where it's a lot cold, birds usually migrate. And it's not just Antarctica, let's say Australia, there are a few birds which migrate from Australia to India or some other location during winter, and they go back to their own place. So migration happens. So same migration is required for your data as well. So on premise, can you please read this? So these are the questions which arise for me. You could have many more, but this is what I think. When you're trying to migrate, you might have these questions. Like for an example, I do not like to name names, but there are some commercial databases. They charge a lot of hefty fees to store data in them. And for, let's say, your company decided that, okay, I am done with this commercial databases. I do not want to waste my money on this commercial databases. I want to move to cloud. This is a valid situation which came in one of my classes or one of my corporate trainings, that they were using, again, one commercial database. I'm not going to name names, and they wanted something open source. How do I migrate that? How do I put it into data lake? Because I was a usual company. Now I am trying to build some machine learning solutions. I am trying to be evolving with time. So if you're doing some sort of machine learning, the most famous solution in the world is data lake at present. It might be something else later, but how do I move my data to data lake? And I do not want to experience a lot of downtime. My company is running for last 50 years. I do not want to have some sort of downtime when I'm migrating to AWS. And once, even if I have migrated, how both of these things talk to each other, on-premise and cloud. And how do I even do that? So these are the few questions which came to me, and I tried answering or explaining over here as well. So AWS has the solution for everything. They have this data migration, they have this replication, as well as free operation that you do not experience any downtime. Even if we are doing this, you have replication that even if something fails in one location, it remains in another location. And data migration, obviously you are using, let's say, some widely commercialized database, and now you want to move to open source, you want to migrate to the cloud. So these are some use cases that DMS service provides, database migration service, that you want to migrate your applications, your business critical databases, migrate from your classic to VPC, costly and license driven data warehouses to Redshift. Redshift is definitely cheaper than those costlier options. So this is one, that is one use case, that you are spending too much money right now, you want to save some money, and AWS came to your rescue. You can do that. You just want to archive your old data. You have your data somewhere and you want to put it in S3 Glacier because you already learned it that it's quite cheap, or you want to upgrade. What you can do is, right now, whatever your on-premise solution is using, it might be, let's say, I'm again making up numbers, it is 8.3.3. But now industry has moved, everybody is using 10.0.1. If you're trying to upgrade it at your end, it's too much work. If you have that capability, you will obviously do it. You do not need AWS in that case. But let's say you do not have that. In order to upgrade to it, AWS provides you a quick plug and play kind of solutions, and you can do that. Or finally, you have, let's say, for an example, right now you are using NoSQL database like Cassandra, and you want to move to SQL. AWS even provides that. Or currently you are using MySQL, which is a relational database, and now you want to evolve with time and you want to have good OLTP connections. Your customer should have no latency, few milliseconds latency, and they should be able to do a lot of things. You want to move to some NoSQL solution like DynamoDB for that. AWS even provides that. So these are some use cases that this service provides you. Database migration service. Again, you have to remember this, where you might need database migration service. So these are some supported migrations. What you see on the left are quite big names already. In that case, you already know which ones are. You tell me. Okay, I do not want to do that. I do not want to disrespect anybody in my life, so I'll not do that for any company as well. You just tell me which one are costlier or which one are not open source and they charge some money to store data. And let's say you want to move from Oracle to PostgreSQL, which is open source. In that case, it allows you to do that as well. And think about just organization level. It is saving too much money. For sure. So DMS service provides you that ability as well. So all you have to do is just create a source endpoint. Where is your current data present? Whether it's in DB2, MariaDB, Azure DB, SQL Server, MongoDB, MySQL, Oracle, Postgres, Sysbase, anywhere. It can be anywhere, current data. All you have to do is choose your source and where you want it. Whether you want it in the same solution, but in the cloud, or you want it in a different solution. So that's what is heterogeneous and homogeneous migration. Any questions on that? So this we have already talked about Snowball. It allows you to do this much storage, 80 terabytes. It gives you 10 gigabytes network. You get an interface which is similar to S3. All of you have seen S3, and your data is encrypted at end. So you're good. Whenever you're dealing with 80 terabyte storage, Snowball is the solution. Now, it does something called as CDC. What is CDC, by the way? I know somebody will know. People are much more experienced than me here. Yep. So the key term here is delta. So let's say you have 10 gigabytes of storage somewhere in your source, and your endpoint or the target destination you want to migrate to.
it has that 10 gigabyte information already there. Now you introduce 200 MB to it. Now that will be considered as a delta, and instead of taking and moving the entire data, it just captures that delta and it is able to deliver it to the destination as well, again saving you some money. So in terms of replication, you have few options that AWS provides, which are kind of redundant at this point of time. We have already talked about cross-region replication. So you explain it to me. What is cross-region application? So again, taking the same example of US and Australia, you have headquarters in both of these places. It's just that you want employees of both location to not have downtime. You are making sure that what data you have in US, it is present in Australia as well, and that you achieve via cross-region replication. You are just replicating your data across region. What you explained failover, it's in the US itself. Instead of having just in one place, let's say Northern Virginia, Ohio, or California, you have data in these three places. So even if something happens in Ohio, you will have data in Northern Virginia as well. So that is multi-AZ, not cross-region. I hope that is clear. Cool, that's good to know. Then you have offload analytics, which means that you can replicate your data to the cloud and you can run some sort of analytics on top of your cloud databases rather than your original database that users interact with. Here, you just have some application. You do not want your users to be affected with it, but you just want to do something else with it. So in that case, your use case would be to migrate this data to AWS so that your users keep on using the same database that they are interacting with, and you just do everything else, all this analytics on somewhere else. And then finally, it's just something keeping data in sync. It's just your company has too much money, and what they want is you just want to have a copy somewhere else present as well, and you chose AWS to be your solution. That's all keeping data in sync means. Whatever you have in your current place, you just want to keep it in AWS as well. Probably you are thinking long term, later I'll use AWS, right now I'm good and all those things. It's just keeping data in sync so that later you can use it. The next thing is data pipeline. Actually, we do not need to discuss this service because a lot of the things that the data pipeline can do, now Lambda can do. But at the point when they created the service, Lambda was not there. So right now, in actual use cases, probably you will not need data pipeline. But again, we are just, as I mentioned, my scope for this is certification. And they probably might ask some questions related to data pipeline. I just want to be thorough here, and that's why I'm covering it here. But if you're looking for it in the sense of using it for your production use cases, you probably might want to skip this one. Over here, we are going to talk about what is data pipeline, some key concepts related to it, and how do you use data pipeline for your on-premise solutions, and some use cases related to it. And finally, we'll summarize this as well. So the data pipeline, as I mentioned, I like to remember things by some sort of analogy. How I remember data pipeline is using this diagram that I have in front of you as well, which is it's nothing but just a pipeline. So here you want to automate the movement and transformation of your data. You can think of it as an ETL service in a way. And right now you have Glue for ETL.
Let's have a quick quiz question, guys. And the question is, what is the concept of pay-as-you-go pricing in cloud computing? Option A, paying a fixed monthly fee for cloud services. Option B, paying for cloud services in advance for a year. Option C, paying only for the resources you use with no upfront costs. And option D, paying for cloud services only with physical currency. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
Service, you can do ETL service using EMR, you can do that using Lambda, you can do it using your custom code in EC2. So there are a lot of options now. But at the time when this service was created, those options were not there. And those options, even if they are there, they are not this managed. So whenever you're thinking about doing something in terms of moving or automating the movement of your data or transforming your data, you can think of data pipeline. It's a managed service specifically for this. There are other services as well, which I'm highlighting again and again. But what this one allows you to do is to process and move your data between compute and storage services, as well as on-premise data sources as well. So you can create some sort of ETL workflow to automate this processing and movement of your data, let's say at every 7 days or every hour or every month. You can do something of that sort with data migration using data pipeline as well. Now, it's quite simple. No, actually, I would not say simple. AWS makes it simple, but it's little complicated. Even I find it complicated, to be honest. And this is one of my least used services. I have not used this services too much in my lifespan because I find it a little complicated, to be honest. So, but again, for this certification, I do understand this service. So I just want you to understand this as well. So there are a lot of options that it provides you, a lot of sources it allows you to. So you can quickly see it over here itself, that you can move your data using some sort of shell commands. It allows you to do that. Whatever Linux command you write, whatever Ubuntu commands you write, it can take those commands, and using these commands, it can migrate your data. You can use AWS CLI commands as well. You have seen some CLI's command for cloud formation. You have seen some for S3 as well to move data, to copy data and things like that. Even you have some commands for this data pipeline as well, that, okay, you define, you have data here in source, you want to move it to this target, and I want to move this from here to here. As simple as that. You can define some AWS CLI commands. Then you can do some DynamoDB table to S3 as well. You have data stored in DynamoDB tables and you want to move it to S3. You can do it using data pipeline. You want to import some DynamoDB backups that you have created and saved in S3, and you just want to restore that. You can even do that using this option. And you can run some job on EMR cluster as well. You can define something. Again, this, even as I mentioned already, Lambda can do this. It's just that you have another service to do the same job. It's just your preference. Whether you want to go for data pipeline or Lambda, both can do this, but you have this option that you provide some sort of job on EMR cluster and it will just fulfill that job. That's all. Then for relational databases as well, here we talked about shell commands. Here we talked about NoSQL database, which is DynamoDB. Here we talked about EMR cluster, which is your big data handling. Apart from that, even if you just want a full copy of your MySQL database to S3, you can do that as well. You want incremental copy. You don't want your entire data to be saved to S3. You want some piece of this data to be saved to S3 right now, later another piece, and so on and so forth. It gives you that flexibility as well. And finally, you can do the vice versa as well, which is load the data which you have in S3 to your RDS table. It allows you to do that as well. And finally, the same thing applies for Redshift as well. Whatever you saw in RDS, you can do that in Redshift as well. Any questions?
So you just choose any of the drop-down options and then you get to build other or build the template with other options, or how does it work? Or is it just it's a matter of choosing the drop-down and you're done?
It's quite simple than what you said. It's just that you choose this option. For an example, you have data present in your RDS. You want that to be saved in S3. It will just ask you, give me your RDS database, give me your S3 bucket. It will move that. As simple as that. Not a very direct answer. There is a way of doing it, but I would say I would not use it for transformation. It can do that for sure, but it's not worth the effort as per me. Again, that's my personal opinion on this. You can read more about it, but I do not like to do transformation using data pipeline. If I am using data pipeline, I'm using only to transfer data. That's all.
Okay.
Makes sense? Again, that's a very biased personal opinion. I tried doing it, but I did not find it worth that much of my time to spend over here. Yes, you have to, again, partially correct that you have to write some code. At some places, as you saw here, there are a lot of options. DynamoDB, EMR, RDS, Redshift. Some places you have to write some code. Some places you don't even have to write some code. It gives you the everything required here in this console itself, drag and drop kind of thing. It does provide that, but not for everything. It's a very good intention when they brought this, but later they might have recognized as well that it's not worth the amount they are spending to develop this, or people, there are a lot of other options they created by the time, so that people probably are more comfortable with that option. Again, here I am giving my personal opinion. I find other options like Lambda or some other options much more flexible than this.
Okay.
So as I mentioned, it has some overlap with your Lambda as well. Data pipeline, it does, I told you, it does CDC. It captures that change that you included 10 GB of more data. It will transfer that newly coming data or the delta to the location. Lambda can do that as well. So it is able to do those few event-driven pipeline cases as well. Now, key concepts over here. This I don't like to explain because nobody understands it, and I don't go into much depth because it's not required as well. So you have data nodes. It could be a SQL Server, MySQL Server, DynamoDB table, or S3. These are your data nodes. Then using data pipeline, you can assign some sort of activity that whenever something new comes, do this. Whenever this gets added, this particular row, do this, and this kind of things. They allow you to do this kind of activities. Then obviously, as I mentioned, it has some schedules. You can run it every 7 days, weekly, or sorry, it's same thing, 7 days, weekly, monthly, or whatever, custom time as well. You can schedule it as well. And you can assign some preconditions as well, that whenever your data meets this requirement, then only do this. This is a complicated portion. If you understand, that's good. Otherwise, no need of even understanding as well, I would say. So quickly, you can see that the end destination for your data is what you have to provide here, where you want to move your data to. Then there is an action that your data pipeline initiates on behalf as part of the pipeline. As you saw, move data from RDS to S3, or move data from EMR to S3. These are the things that it allows you to do. These are the actions that it allows you to do. And then there are some preconditions as well. As I mentioned, it's very complicated when you start going much more in depth, but
I have given you few basic things. So for an example, it checks this precondition that whether this key called Harsh exists or not in my S3 bucket. If it exists, then it will take that operation. Otherwise, it will not even take that operation. Or it can check for this prefix. Let's say a bucket called 23rd of August. If that exists, it will take some option. Otherwise, it will not waste money for you. Or it will do some sort of basic check, like first check if this table exists, then try to move there. Otherwise, don't even try. Or check DynamoDB data exists. Check if this particular data even exists or not. If it exists, do this or that or whatever. If not, do not even try this. So precondition is basically just to save some time, money, resources, everything for you, that you check for prerequisites there that should be already present. Then only you do the rest of the operations. Does it make sense? That's why I've filtered out the 5 operations. It has many more operations, but just to make you understand this, what are the preconditions? I filtered out this operations for you. Do you think you understand this? Again, as I mentioned, this could be a one use case that your users or consumers or customers, they are using one of your database table or many of your database table for your day-to-day operations. But whenever you want to do some sort of analytics, you can do that using your data, which is you have moved to AWS using this data pipeline. And another one is remotely executing stored procedure, which means just running this scheduled task. So that's the whole purpose of data pipeline. As I mentioned, probably I'll not use it today, but you should understand this for sure when you're dealing with AWS ecosystem and when you are appearing for this certification. So data pipeline in a nutshell, what it does is allows you to automate the movement and some sort of basic transformation of your data. There are some key concepts that I mentioned, that you have your data nodes. It could be your RDS server, DynamoDB server. Those are called as your data nodes over here. Then you define some activities where what you want to do. You want to move from RDS to DynamoDB to somewhere or S3 or whatever. And then you have some preconditions as well, that first check if this table exists, then make this operation. If this S3 bucket exists, then make this operation, just to save you some time and money. And then you can do all of this scheduling as well. And finally, we saw that you can use data pipeline for your on-premise as well. It takes your bash script or Linux commands and it just runs that on your local or on-premise itself. And the use cases we saw, if you want to move data to cloud and do analytics, you can do that. Or you want to do some sort of remote executed stored procedures, scheduling movement and things like that, you can do that as well. So with that, we are done with this another section. And the next thing that I want to talk about is Lambda, API Gateway, and CloudFront. CloudFront, we kind of discussed. What is new to us is Lambda over here. So far, we are hearing Lambda a lot, but we have not actually seen what is Lambda. Anybody want to guess what is Lambda? You have the definition in front of you. Upload something to an S3 bucket. For an example, you upload your image and you have a logic in place that whenever you upload an image, it creates a meme on top of that image. That is your Lambda function. It can do that. And it can do a lot more than that. It is entirely limitless and up to your imagination, whatever you can think of. So Lambda is that. Basically, what do you say? Code as a service. You are worrying about only your code, what is required. So for now, when you run a code, you have to think whether my Mac allows to run this code or not, whether it has Python installed or not, whether it can handle this much data or not, or whether it has this much memory in it or not. You have to worry about all these things. But when you're dealing with Lambda, all these things goes away. You just have to worry about your code and it will make sure that it is able to run that code. That is Lambda. What is API gateway? It's just a serverless API that you can use in order to create RESTful APIs, which are your HTTPS and WebSocket APIs. It allows you to create that. And we have seen that example as well. We saw that one API which somebody has created that creates fake data for a user, their image, name, address, and all those things. That's just an API. They are giving you all that information using an API. Now, this is one example of Lambda integration, how it works. So you have some event, as I mentioned, you have this image coming in, it goes to your S3 bucket. Once it is in their S3 bucket, it creates this event. And what is that event? I got an image. It is proclaiming that information. Lambda gets to know that, okay, you got something new. Let me run this code, whatever I have in me. It runs that code on top of this new event. And finally, it saves somewhere or do something on top of that. So that's all Lambda is. And we are going to do a demo on Lambda as well. Do not worry about that. So again, Lambda has pretty good integration. I have my own website, where I teach my own personal students, not via Intellipaat or something. That entire website runs on Lambda, and I'm running it for last 2 years, and it has cost me nothing. 0 rupees, $0, whatever. I've not paid anything for it. It runs free because of Lambda. Lambda is quite cheap. Specifically, I'm not using it for much. I'm using it for my own purposes. It has good amount of integration. I already gave you example that I have some recording of myself in MP4 format, and I want to introduce that to other people as well, which do not accept MP4 format. They want it in MKV format, or they just want my audio, they want it in MP3 format. I use Lambda to create this logic so that it gets transformed from one format to another. It gets saved to one bucket to another. All these things are taken care by Lambda itself. Then you have integration with Redshift as well, that new data, new row gets populated in Redshift. You do this. You do some sort of transformation with that data. Same thing goes for DynamoDB. Same thing goes for your IoT event. Something comes from your Apple Watch or Fitbit or Gram or anything, Garmin. It takes care of that information and it does something on top of that data. It has all these integrations as well, which you are seeing here. And these are some of the common ones, which at least I have personally used. There are much more. So Lambda has good amount of integration. Can you please read the use case of Lambda here? And finally, to create cron jobs, you can use your Lambda functions to start some daily jobs that you have some data coming in every day and you want to retrain your machine learning model every day and you do not want to do it manually. So you can create this cron job that whenever you get this new data, take this new data, create a machine learning model and save the results, artifacts or whatever on S3. So Lambda can do a lot. This is just an introduction to Lambda, I would say. Here in this section, you need to know some sort of limits. So for an example, when you're driving on a highway, you have, let's say, again, this is a very low limit, but this is the only image I found on internet, which I could use. So let's say you have this limit that you can drive under this particular limit. Same thing, you have some limits associated with Lambda as well. So what are those limits? Please read this for me, then explain it. Okay, so the demo code I've already given the CloudFormation template.
So that will create everything for you, an EC2 instance. All you have to do is give it create a Kinesis data stream. So for that, as you can see, I have already created few in my account, but all you have to do is provide the name, demo Kinesis stream, and just click on create data stream. So it's so simple. I'm not going to do it again, but yeah, as you can see, this is my Kinesis data stream, and this is my EC2 instance that has the code which I'm running. So it's a pretty simple code. What it does, as I mentioned already, this is an API that generates random user. All you have to do is provide the region name and whatever is your Kinesis stream name over here. And using a Boto3 library, which is a library created by AWS, it is able to send this to your Kinesis data stream. As you can see, this is as simple as this. You do this client.put record, provide the name of your stream, what exactly the data you are providing. So here I'm providing a data which is random user data, and partition key. And partition key, as you can see, I am randomly generating a partition key, which is nothing but a UUID to this Kinesis data stream. Now, how do I confirm if the data is coming? And before even that, how do you actually send data to it? So we have already talked about the producers. You have Kinesis agent, you have AWS SDK. One of the options of sending data, you can explore this and this as well. And you have their GitHub pages as well. Same goes for consumers. We talked about all the different libraries. So these are the ways of sending or receiving data from a Kinesis data stream. Now, how do you check if you're getting data? Just go to monitoring, and as it suggests, it keeps on monitoring whatever is happening with your Kinesis data stream. So as you can see, there is one small dot over here, which tells me how many get records I have so far in terms of MB. So as you can see, I have around 400 get records, and this is my incoming data. Some data is being generated, but obviously this is not very intuitive. So what we are going to do is we are going to create a Kinesis data firehose as well. Now click on, now here it is again a simple thing. Either you can directly put the data, or you can take data from Kinesis data stream. If I want, I could have sent this data instead of Kinesis data stream to Kinesis data firehose. But as I've already done that for Kinesis data stream, here I'm going to choose my source as Kinesis data stream. So this shows you two things, that whatever data you are getting in Kinesis data stream, you can put it to Kinesis data firehose directly from there. And finally, we have already talked about all the places it can send data, which includes Redshift, S3, and as you can see, they have included few more new options as well. HTTP endpoint, then we had Splunk. So right now, I am going to be sending data to S3. And if you want, you can provide your custom name. Otherwise, it will generate one random name for you. I'm going to keep this one. And if you remember, we talked about few options that you have when you are using Kinesis data stream, that you can enable some sort of transformation. And that is done via AWS Lambda function. But right now, I do not have that. So we'll not do any transformation. Or if you want, you can convert the format as well. So for an example, your output format could be Apache Parquet or Apache ORC, and that is done via Glue. But right now, we are not going to change the format as well. Finally, it is asking where do you want to save the data? To my S3 bucket, but I do not have any S3 bucket. So let's go and create one. Kinesis demo bucket 09092023 should be globally unique, and create bucket. Now let's see if it is appearing here. Nope, because I have to refresh. And here comes my bucket. just choose this bucket. Partitioning, if you want, you can enable partitioning and blah, 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 a lot of things. You can have custom rules for that. Like how do you want to create partition in year, month, date, hour format, or something else. You can define all those. Then this is what we talked about, buffer size and buffer interval. So to quickly show this example, I'll choose the buffer size to be the minimum. Same goes for buffer interval. And if you want, you can compress this data directly as well. I'm not going to be compressing this data. And if you want, you can encrypt this data as well. So that's a data fire hose. Now, just to see if it is working or not, we have to wait for 60 seconds. You won't be able to see it like this, but as you can see, it has a picture of that person and in three different ways. First one is a large picture, second is a medium picture, then you have a thumbnail, then the name of that person, last name, title, date of birth, age, gender, date, and a lot of things. And same goes for so many other users as well. So this confirms that your entire flow is working. I'll stop my EC2 to stop generating records. Okay, looks like there are no questions. So that's the end of your Kinesis demo. Kinesis app. This as well. KBS S3 NTDMA. Done. Now, after this, you can write. Earlier, they had this option called the SQL Weaver that they had changed, and now they have converted it to Apache Flink. So, for an example, we talked about Kinesis data analytics. If you want to do any analytics on top of this, you have to create this notebook, and then you can run your usual SQL queries, Python code, whatever you want directly on that. What is the file format? File format is by default, it is saved as a compressed file. If you want, as you can see, we had the option of converting file format directly via it, and it saves it either as a Parquet or ORC. Yeah, so as you can see, I was working on it. Lot of tabs I opened, but I couldn't make it work finally. So yeah, I'll give you an introduction to this demo. So in this one, what I wanted to do is I wanted to create a fully working serverless reminder application using services like S3, Lambda, API gateway, step functions, and SES, and as well as SNS. Now, for this certification, you do not need to know what exactly is step functions, you do not need to know SES, and you do not need to know SNS as well. But as I mentioned already, there are a lot of prerequisites for this certification. At the initial day itself, I told you, there are certain assumptions that you might know this if you have given some certification or you have worked on AWS. But even if you do not know, I told you I'll kind of give you a walkthrough of all these things so that you are kind of prepared for all the assumptions that AWS has from you for this certification. So basically, we are going to be building a serverless application. And what this application does, as I mentioned, it's a reminder application. So this is the UI for that. And as you can see, I have used nothing but our S3 itself to generate this URL for me to host my website, which I do for most of my sites as well. So this is my S3 bucket, AWS demo, Hirsch, blah, 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 blah. It has this get.png, some logic for error.html, some logic for whatever you are seeing on this page, and a basic CSS for this page, and finally a JavaScript for this page as well. So all it is supposed to do is I type something over here that what is I want to be reminded about. I'll actually show you. So how many seconds it should wait before sending this message is the first parameter it asks for. So let's say every 1 second. Second is hello from Harsh. And finally, you provide the email address or a phone number as well. And it sends you an email there that, okay, there is a reminder about these things which Harsh want to remind you about. Obviously, I'm reminding myself here, but you can put anybody's email or an email of your entire team or something of that sort. And it does that. And it has all these things, email, SMS, as well as both.
Sure.
Okay. So as I mentioned, it's just a reminder application. And for that, I have unnecessarily created this UI page and I have unnecessarily put this cat image. But it can do this job of emailing and SMSing you basis whatever you're writing here. Now we are going to see how exactly that is done. As you can see, this is the last portion I'm working on, when which I was not able to figure out that it is giving me this error. Yikes, there was an error and there is a type error, which means there's something wrong with the code which I have written, which I have to figure out. So, but yeah, apart from that part, everything else is working and I can show you everything else as well. So first is we need Lambda function. For creating a serverless website, you need a Lambda function. For that, how we are going to do is that first go to obviously Lambda. And you will see that I have already returned 3 Lambda functions here. Hey, why it's not showing third? Yeah, 3 Lambda functions. But let's say, suppose I have to do it from start. How you will do that is just click on create function. I think I've shown Lambda, but okay, let me show it again. You put something email. I already have taken that name. So email 2. You choose the runtime, whatever language you're comfortable with. I find it Python very easy. So Python, and you just have to give a role, whatever it is supposed to do. For an example, this Lambda is supposed to talk to API gateway. So create a role that allows it to talk to API gateway, which I have already done. And I'm calling it Lambda runtime role. So I've just selected that role and click on create function. Okay, now, obviously, I'm not going to write it again. I'll show you the code for it, what exactly I've put here. So go to email. And as you can see, it's a pretty simple code because AWS has good integration. That means they have done all this other task, which I don't have to do. Here, I just have to do is call this application called SES. And SES is nothing but it sends email. That's all this service does. So for that, it requires few things. It requires a verified email. Then it requires a destination, which is again a verified email, which I'm providing here. And finally, whatever is the message. So I want to send a message, a reminder from your reminder service. This is my reminder service. And body will contain whatever I am getting information from here. Whatever I'm going to type here, it will take this information. As you can see, data, event, message. It will figure out, okay, this is my new event. And I just have to pick this message, and whatever is the message, it will pick that. So this is my pretty simple code. And if everything works, it should give me success. That's all it is supposed to do. And then after that, you just deploy it. And you can test it here itself if you want. All you have to do is provide whatever it asks for. It asks for an event, it asks for context. So you can use this test option, and then I bring it here. So that's my first Lambda function. Then if you gave attention, it says it needs a verified email. How do you get in verified email? For that, you need to go to SNS. And is it open here? One thing we have done, if you click on this email, this Lambda will be called. Now, what is the next thing that I'm supposed to do? You guys tell me.
Come on, it's pretty simple. Answer is in front of you.
Create the function for the SMS. Yeah.
Absolutely. So the next thing that we are supposed to do is go to Lambda, do the same thing, create function, choose Python, but I'm not going to do that because I've already done that. And again, as you can see, it is pretty simple. Whatever number, phone number you are providing it here, it just takes that and it sends a message to that. And how it does that? Using a service called SNS. And it's pretty simple. As you can see, sns.publish. You provide the phone number, you provide the message, and it will send that message. It's pretty simple. So otherwise, you might have to create your own logic of how do you send a message to an email. But right now, AWS has given you that. Why not use it? So this one is pretty simple. Now, the next function that I have to create is called API handler. And can you tell me what exactly this one will do? Website I have created, it has a button. How does it know I have to reach out to Lambda function? That the logic is written over here in your API handler. Again, I'm not going to explain the code, that is out of scope, but it does all of these things. Check if this button is pressed, that button is pressed, if you are getting a correct response and all these things. And this API handler does. So that is your third Lambda function. Now, I created one more thing, and which is out of scope of this certification as well, but I'll quickly show you what that is. So that is called as step machines. And step machine is an amazing functionality that AWS has provided, which is, instead of explaining, I'll show you. So you write a code, something like this. How you use actually CloudFormation templates. It's kind of similar to that as well, but this one is more for creating flows or how you want things to happen. You can make that happen using step functions. Inside step functions, you have this option of creating this state machines. And in this example, what exactly I have done starts from somewhere. So AWS calls it start. Then there is a wait state I have provided that it waits for this much time before doing something. So if you remember in our website, we have option of providing how many seconds you want to wait for. So let's say I provided 1, it will wait for 1 second. Then after that, it has already built-in function called choice state. It chooses something. So in our website, we have two options. Either we want to send an email or we want to send a text message. So it chooses for that. And then we have an option called both as well. So here, if I have chosen email, it will reach out to this Lambda and the Lambda will do its job and it will do something. Then if I've chosen SMS, it will send that, it will reach out to this SMS Lambda, it will do its job and so on and so forth. And AWS again gives you this option of creating this state called parallel state, that it will do two things together at the same time. Here, if you have chosen both, it will reach out to both the Lambdas simultaneously, but parallelly, so that both can go together. So it will reach out to email Lambda, it will reach out to SMS Lambda, and finally it will give its final state, whatever is the, if it was successful, if it is not. In our case, right now, it is not successful. So it is going to this end state with a message of error. Otherwise, it will go with a message of success. So is this clear what state machines or state function does? You don't have to know this, but yeah, I thought of it came, so I thought of showing it to you. So this is how you create it. I have created the same thing here, then exported it as a PNG. You don't have to, again, know exactly what it is doing, but it has all these options that I have created, and it is pretty simple to create. Either you can code it or you can design it. So you can put it, okay, I want to reach out to EC2 instance, so you can put it EC2 instance. If you want to reach out to Lambda, you can put it Lambda here, and so on and so forth. And then it has all these things which I'm using. Do something in parallel, pass this information to the next one, do something wait for some time, provide a success message, provide a fail message, and so on and so forth. Okay, so that is your step function. So this is what I'm using. And if you'll see my code, this is where I define, okay, you have to reach out to this Lambda function. How do I define that? Everything in Amazon has an ARN. So I provide this ARN over here. For text, I provide the SMS Lambda ARN. For email, I provide the email Lambda ARN. And that's how it knows where exactly it has to go. So this is your step function. And finally, the last thing that I want to show is API gateway. So API gateway, it is a pretty simple thing. All you have to do is come to API gateway. And what it does, it creates, maintains, and secure your APIs at any scale, which means it is a pretty useful service. It allows you to create APIs. So over here, I have already created this API. Oh, it is going out. Anyway, I think it logged out. That's why it is happening. But API gateway, it just allows you to create APIs, this ARN. It does not create a URL, it creates an ARN. An ARN is found just here. This function ARN, you have this ARN. So this one is how you create an API. They have already created an example API. So if you want to play around with that, you can do that as well. Or you can create a new API. That's what I did. I called my API reminders, description, nothing, endpoint, regional. You click on create API. After that, it asks you to provide what is the method. So in your case, you will create a method. We have to create a post method because we are posting something from our page. And integration type would be Lambda, that we are going to reach out to Lambda. Then you will choose your Lambda function. Right now I'm in different accounts, so that will not come up in the dropdown. If I was in the same account, it will show up here that you want to reach out to this account. And here we will reach out to our API handler Lambda account. So this is how we say that, okay, this website will go to this API gateway, and then it will do rest of the tasks that it is supposed to do. So that's pretty much it, what I wanted to show. So here we saw how Lambda works. Here we saw how API gateway works. And we saw a few other services that you were not supposed to see, which are SNS, SES, and state machines or step function. So we can use this various services to do things like process our data, collect our data, and store our data, and also serve it to our users as well. So we are going to talk about all these three services as a quick overview right now. So Lambda is an event-driven service which allows you to run your code in AWS without managing any sort of infrastructure. You already saw it that we did not have any servers, we did not have any EC2 instances, we were not doing anything. We just put our code and that code was running without us to worry about anything. So obviously, if you're aware with any associate level certification, or if you have done some work in AWS in the real world, you are most likely worked with Lambda at one point of time or other. It's the most common and the most useful service as well. It's a pretty fantastic service to use to basically just write functions or write code in the cloud and run those things to do a specific task. So basically, it's a great microservice. It allows you to decouple your infrastructure, and it decouples from application to really just accomplish a single task. As you saw, one Lambda was just sending email, another Lambda was sending just SMS. You can use them both together using something else, but in terms of code, they are doing just their own job. And the pretty important thing here is that you only pay for the function time as it runs, and you can pretty much have it interact with any other AWS service in AWS. Now, it's a pretty versatile service to use. And if you're going to be a data analytics expert within AWS, you need to understand how to use Lambda, how it connects with other services, how you can process data with it, how you can collect data with it, and finally, how you can store data with it as well. So basically, what I wanted to say here is it's a great service to know about when you want to be a data analytics expert.
Now, the second one is your API gateway. It's a serverless API, as you saw again in the demo, that we can use to create RESTful HTTP and WebSocket APIs. You don't, again, have to run your own Spring Boot application to create that, or you don't have to do any fast API or Flask or anything of that sort. Everything is handled at the backend. And that's why it fits into the picture of serverless applications that AWS allows you to use. Now, so that we don't have to manage any sort of infrastructure at all to set up this API. Otherwise, if you're creating that API on your own, what will happen? You need to first write the code, how exactly that entire API will work, how all these components together will work together, and how finally, once you have done everything, you have to Dockerize that particular API, put it into some server. And if much more users are coming, you need to have 10 servers, 20 servers, whatever n number of servers, and you have to scale and do all of that. But right now, with API gateway, you don't have to do any of it. You just saw it, you go there, click on create API, you provide it whatever name you want. We called it reminders. And then inside it, you can keep on adding that, okay, I want to do this task, that task, I want to get some data, I want to post some data and things like that. And the entire thing will scale seamlessly. So that is your API gateway. And basically, you can essentially create endpoints and allow them to do different things. For instance, trigger Lambda function, make HTTP request. You saw that we were triggering a Lambda function using this API gateway. Now, you can finally, last thing that we want to talk about, and we have kind of talked about already, is CloudFront. And you can utilize AWS as a content delivery network. CloudFront is nothing but a CDN service, and that stands for Content Delivery Network. And that allows you to deliver data and videos, files, application, APIs with very low latency. The entire purpose of CloudFront is to reduce the latency for your end users, be it image, video, any sort of files, or even APIs. It can reduce that latency. Now, what happens is this edge locations or CloudFront edge locations, they are spread out across the globe, as we have seen already. And so instead of going to the source every time you want to access an application or access some data or files, what it does is it allows you to contact an edge location where the data has been cached. So again, CloudFront, it is a content delivery network or a CDN that allows you to deliver our data faster to our end users. So here we talked about how Lambda is an event-driven service, right? Give me an example of that. Happens using this event-driven service is that event comes in to AWS, and that event triggers the code to run that we write in Lambda. And the simple example of that is firstly what we saw. What was the event? We clicked on that button. Okay, so clicking on that button was an event. Something happened when we clicked on that button. It reached out to API handler Lambda, where I had this logic that, okay, whenever both button is pressed, do something. Whenever email button is pressed, do something. Whenever SMS button is pressed, do something. So that's how event-driven pipeline works. So look, whatever is happening, reach out to that particular trigger some basically other data collection pipeline down the road, or do some ETL job. And so let's talk about how this events and what actually happens. So let's say, suppose in this case, as you can see on the diagram, we have an event, and whenever an event is triggered, we have some event data that also comes out of the actual event that occurs. And what happens is that this triggers the Lambda function. So the event data is passed into the Lambda function, and then the Lambda does some sort of processing that you saw. It does some type of action, and then some results come out of that Lambda function as well. And this results either land on some destination, or it can trigger another event. For an example, I could have created my website in such a way, anytime somebody clicks on email button, do the email, and save that data, whatever they have mentioned in that box in that web page, to S3 as well. That could have been my second Lambda button. I could have done something like that as well. So things like S3 events, DynamoDB. What can be an example of DynamoDB? What should be an event when you're using DynamoDB as a trigger? Absolutely, as simple as that. In S3, you can have something like new file is added or a new file is removed, do something. In DynamoDB, it could be a new row has been added or deleted, then do something, make some event happen. In Kinesis stream, so whenever streaming data is coming through Kinesis, you have seen the demo of that as well. Let's say your logic is something like this. Every time you get 10 MB of data, do something with that data, convert it or take some information, parse it, figure out what is the age of everybody, because you have their date of birth, but you do not have actually age. So your Lambda can do all that kind of logic from your Kinesis stream. So that could be an example. We already saw that we were sending data from EC2 to Kinesis data stream. And from there, you were taking that data to Kinesis data Firehose, and then we were saving it to S3. Instead of that, you can save it to Lambda. And that Lambda will does the job of figuring out their age, for an example. And finally, it will save this data after figuring out whatever you wanted it to figure out to S3 or somewhere else as well. So this is a few examples of how all this trigger works. And you can also trigger events through Redshift as well, whether a new table is created or a new data comes into Redshift. And you can do a lot of that with IoT as well. So AWS IoT is another service which allows you to manage IoT devices which are spread out throughout the edge. And you can have Elasticsearch. Elasticsearch can also trigger an event, and the same with the data pipeline. And these are not the only services that create events. These are just some of the most important ones that deal with data analytics. And if you look into AWS, almost everything can trigger a Lambda event. So look at all of these places that data can be stored, data can be triggered. So data can be moved throughout the AWS environment, and all of these different services can trigger events that can trigger your Lambda function. So let's talk about some different use cases where you might want to use Lambda. You have given me some, I have given you some, and these are whatever I wrote. So let's say you have a fleet of servers that are continuously creating logs. And what we can do is use the combination of Lambda and Kinesis to capture this real-time, basically real-time process and transform this logs and store those into things like S3 for real-time application and notification. So these logs are coming in. Maybe you want to do some sort of transformation to them before they land off to into their final destination. Or you want to create real-time application, let's say with your CloudFront and API gateway, to be able to show users different metrics that are happening with their applications. Think about creating your own version of CloudWatch. You can also create ETL pipeline. So the data is coming into AWS, whether it's to S3 or whether it's into Kinesis or things like Redshift or RDS. You can trigger Lambda function for various events and process that incoming data. So because a lot of our times data is not in the format that we want to have it in, either a service or service A or to a service B, in that case, probably you want to create some sort of cron jobs that you set up your Lambda function to start daily batch jobs that you are currently basically doing manually. So yeah, that. And as I mentioned already, Lambda function is a new thing. And we already discussed data pipeline. And I told you that time that data pipeline is probably going to be outdated and gone from AWS, because you can do the same thing that data pipeline can do using this third point, which is create cron jobs. So yeah, it allows you to schedule various events that may need to occur. And here, that is how you will see the overlap with the data pipeline in certain scenes as well. API gateway. So you, in this Lambda, you can just click on add trigger and you can add that trigger where exactly you want to trigger it. So
Okay.
this Lambda will be triggered using API gateway. You can add S3 as well. This will be then whenever something comes to that S3, this one will be called. So it's pretty simple. Just come to the Lambda, you have this trigger and you have this destination as well. That whatever is the output, where do you want to save it? Both things here in the same page. Time something will, and it will give you all these options. That in DynamoDB, when do you want that event to be triggered? When something gets added, when something gets deleted, when something comes to a specific this column, things like that. It has all this granular level of control as well. Just play around with this option called add trigger.
Okay.
It has this logs, metrics, alarms. So it does not exactly has notification, but it has all this alarms. Something happens, something goes out of 80%, that creates an alarm and things like that.
Okay.
Here. So CloudWatch, all the things that you are getting in EC2, it comes here in alarm section. Logs is the most prominent thing. Everywhere something, like for an example, in my app, here what was happening? It was giving this error. Where exactly this error will show up? In my logs. Then I can figure out, here it is just showing me this error. What exactly is the issue, on which line it is coming and things like that. Okay. So here we'll continue on and talk about the part 2 of this Lambda, you can call it, API gateway and CloudFront. So over here in the last section, we saw or went through an overview and what some Lambda events and integrations are within AWS. In this particular section, we are going to start talking with Lambda limits. So as you have all these limits, you are going to know what exactly are the Lambda limits as well. And that is pretty important for your certification and even in general practice as well. So we'll dive in and talk about a few different serverless architectures that we can create with these services. There are some limitations that happen with Lambda. So let's go ahead and talk about some of those limits. And it's pretty important to remember this limits because it may come up on exam where you basically need to understand what the limitations of Lambda are and whether a Lambda is a good fit for whatever processing task or whatever scenario they have given in your certification. Now, let's say, for example, you have some processing task that takes longer than 15 minutes. In my example, I was clicking on a button and it was sending an email. That's a pretty simple task. Few seconds, probably not even 1 second, and it will do its job. So definitely Lambda was a good fit there. But there could be something which requires a lot of processing and it cannot be finished in 15 minutes. So any task that lasts longer or that processing task basically takes more than 15 minutes, then if you're using Lambda for it, well, sad news for you, it's not going to work out. So all of your basically bad jobs or all of your processing needs to be under that 15-minute mark for you to invoke a Lambda function and the request and the response payload to go through. And the second thing, your response or the request payload, it cannot be greater than 6 megabytes. That's why you can see if you have data, which is whatever data you are going to pass to Lambda, it should be 6 megabytes for a synchronous function or 256 kilobytes for an asynchronous function. Now, few people might know what is synchronous, few might not. So I'll kind of give you an example of that as well. So if you're running Lambda functions synchronously, in that case, as I mentioned, it cannot be more than 256 kilobytes. And if you're running asynchronously, so what happens with synchronous invocation is that what we do basically in synchronous is that we wait for the function to process that event and return the response. Okay. And with your asynchronous invocations, Lambda basically queues up that event and can send invocation records to a destination. Now, basically, the difference between them is simple. Synchronous, I have sent you hi. And this class does not reply back to whatever I ask. So you guys are all example of asynchronous. I say something, I don't get anything from you. My job is done. I just said something, I gave this lecture, and nobody responded. That is the example of asynchronous call. Synchronous, I am sending hi, you are sending me hi back. That's an example of synchronous, that I am sending something from here and then I'm checking whether that was delivered or not. That is an example of your synchronous in, again, very high level overview, layman's term. So all these two calls, these are the limits. Please keep those in mind. Now with many of the services that integrate with AWS Lambda, and we are going to talk about this in just a little while, but what they do is they batch up a lot of requests in batches, in larger batches basically, and then process those with a single Lambda function. And that is invocation frequency per region. So what should be that frequency? That is 10x for your concurrent. Instead of it creating 10 Lambda functions, what it does, it collects this information, what is coming 10 times. Oh, I see the same thing he wants. It will not create 10 Lambda functions, or basically, I'm choosing the wrong word. Lambda invocation function you have already created. The code you have written, that is called as Lambda function. Every time that code runs, that is called as invocation. So what it will do, instead of executing it 10 different times, it will execute it just one time by queuing up all this 10 different calls. In all those 10 calls, you're doing the same thing. So what it will do in just one call itself, it will send 10 requests. And that is basically the number that you're seeing here. So basically the amount of requests that you can make per second. And the number to remember here is 10 concurrent executions. Now the other variable depends on where the event is actually coming from. So it is coming from a non-AWS source. Is it coming from an AWS service like S3, DynamoDB, Kinesis? And you're running it asynchronously or synchronously? And are you waiting for the response back, or are you letting the function run and then getting that response back when it's complete? So it depends on all these factors. So like I said, the main thing to remember here is that it's 10 concurrent executions per second. Now, these aren't the only limits that Lambda has. I have given you that study guide, and it has the link in the section of Lambda that points to all of the limits. But in my opinion, these are going to be some of the most important ones, and the ones that you need to understand, diagnosing your questions and finding out if a Lambda is a good fit for your data pipeline or data analytics application. But if you want to learn more, you can go through that link. Otherwise, I think this much is sufficient enough for this certification. I also want to touch on how Lambda and CloudFront and API Gateway can allow you to create a serverless application. And I kind of showed you that already. And this, I think I've taught you that. I remember showing you this example. Unnecessarily made me repeat everything. So bad. So yeah, I told you that these are all some websites which are all serverless and which I have created. And with this website, I wanted to show you an example of one such website, how you can create a serverless website. All of these websites which I have created, they are basically created in the similar fashion itself. This I know, I remember now. I've taught you all this. Unnecessarily wasted my time. Correct. No, actually everything is correct. I just wanna explain a little bit more about this last point. So over here, we can basically, the point to remember or understand here is that you can have multiple Lambda functions associated with a Kinesis stream event, which means basically you can have up to 5. Now, as we are more producer and the data starts growing and growing faster and faster in coming into Kinesis stream, so the number of shard that needs to be scaled up. So what happens is, for every shard, a single Lambda function is triggered. And when there is high volume of traffic, we want to process the records as fast as possible. And now, since only one Lambda function and one invocation can happen at a time, we need to figure out a way to scale up our Kinesis stream to be able to handle more data. And we do that basically by creating just more shards. And that's how we scale your Kinesis data stream when more data starts to come in. So therefore, we'll have multiple Lambda invocations that will occur. And now the way that we scale up our shards is just by updating the shard count API call. Another way is by using something called as So this is what I was explaining. One shard can invoke one Lambda function. If you want to invoke more data coming in, you want to process that data more, all you have to do is increase the number of shards, and every shard will reach out to one specific Lambda function stream. And that is by splitting our shards. So what this does is basically it creates two new child shards by splitting the partition key space of your parent shard. So as you can see here, we have two parent shards, and here we have four child shards as well. So what happens is Lambda is not going to start receiving any records from your child shards until all of the records have been processed from your parent shard. So here we have a parent shard and they have split off into separate child shard. So the Lambda invocation are not going to occur until all of the records are out of your parent shards. And then it will start processing the child shard record. So you might get questions on your examinations about how to scale up your Kinesis data stream. Know that adding more shards is the way to go. And there is also another way to scale your Kinesis data stream with Lambda is by splitting your shards into child shards. So that's the one concept that was remaining and I wanted to explain. So let's quickly summarize whatever we covered. So we discussed each of the services and their purposes. We saw a lot of them in demo as well. So we talked about Lambda, API Gateway, and CloudFront. We talked about the various types of events and integrations that Lambda offers. We know that it's an event-driven service. We also need to understand the various types of events that can trigger Lambda functions and how we can integrate it with other services. And we talked about Lambda limits. So we talked about function timeouts. We talked about the invocation payload size, as well as the invocation frequency. And finally, we dive into the few serverless architectures that can help us put all of these services together in order to create some pretty amazing applications, which are serverless. And finally, we talked about how we can integrate Lambda and Kinesis together and how we can scale up Kinesis by using parent and child shards. So that is it for this particular section. And hopefully you gained a little bit understanding of AWS Lambda, maybe a little bit about API Gateway, and also CloudFront and how they could possibly fit into an event-driven pipelines and serverless application for our data analytics processes. So yeah, that's pretty much it for this one. Now, finally, this is a section about how do we compare our options. Now, over the few sections, we have talked about several different services that can help you to collect your data, move your data, or migrate your data into AWS. In this particular section, I would like to propose some questions that you might need to ask when thinking about the data migration process. And if you get scenarios on your examination, you can ask yourself these questions as well to help you to diagnose what services or what set of tools you might use in that situation. So I would like to introduce the 4 W's of data migration. So firstly, the question that we ask is why we are migrating data to AWS. Now, this might be a silly question, but it's important to ask because it can dictate which service we are going to be using. Now, we might ask, okay, what are we migrating then? Are we migrating production data, backup data, compliance data, file system data, maybe some end user data? And this list goes on and on of what type of data we want to move. It's also important to know what applications this data is attached to, meaning this is the application. Is this application able to even run in the cloud? And is it a requirement that the application needs to run on-premise? These questions can help you understand if we need to move our data into AWS. So for an example, if our application is not able to communicate with, let's say, S3 API, then why would we even use S3 to store our data, right? And of course, one of the most important things we need to answer is, okay, where's the data going? Is it going into Redshift S3? Is it going into something like DynamoDB or RDS? And these questions are going to be important to answer whenever we start to think about migrating our data. And finally, the last W is when does the data need to finish? Now, if you ask any stakeholder, they are going to say as soon as possible, right?
Now, as fast as you can get into the cloud, but knowing the deadline of when the data needs to be moved and needs to be accessed is going to be super critical to understand. And there's actually one more that I would like to ask. AWS has recommended 4 Ws of data migration, but actually it's 4 Ws and the 1 H of data migration, and the 1 H is how much data do you actually have. And this one is an important as well. So this means that you might need to look through the cracks and crevices of your data. You might have servers lying around that have some file system with important data on them, because you might have data that's just hidden somewhere and that's been forgotten about. So you need to make sure that you understand actually how much data you have. And the important question that we need to ask is how much network capacity we have as well. And this is again super critical to understand, because this can help us determine if we need to use an online or offline migration service, or possibly utilize larger bandwidth using services like Direct Connect that we have covered in the previous section. So asking these 5 questions are going to help us understand, okay, where do we need to migrate the data? How long does it need to take? What actually we might use, and where is this data going to sit once it's actually in AWS? Now, it's important to understand how much network capacity you would actually have. And I would like to show you this graph, how long it would actually take to move your data into AWS. And I have given you the link in the previous section as well, the study guide section. That kind of goes through the same graph as well. And this graph I have taken from a reInvent video that AWS talked about, and I have given you the link of that as well. So as you can see, if we have just small amount of data, let's say 1 terabyte, 10 terabytes, 100 terabytes, as you can tell, that is a small amount of data. When we are talking about trying to move, petabytes or hundreds of petabytes of data, and depending on your network bandwidth, it will determine how fast that data can be moved into AWS. And as your data grows, you can start to see how long it would take to move more and more data depending on your network speed. So you can see here, moving a petabyte or 10 petabytes of data with 100 megabytes per second network bandwidth or 1 gigabyte per second could take years to move. 34 years, 3 years. These are pretty absurd numbers. So using your own internet bandwidth, it is going to take you to some far extent, but not for all the use cases. So this will kind of give you an idea about what type of migration you want to go for, offline or online, or some other hybrid connectivity into AWS. So it's critical to understand your network bandwidth, and this is going to help you understand which managed service that you might use, or which services that you can use to get your data into AWS. So in a previous section, we talked about hybrid cloud storage. This is basically utilizing Direct Connect. This 3 things we talked about: hybrid, online, and offline. And choosing a service, as I mentioned, it depends on online if you have rapid data transfer or some sort of file exchanges, or if you have some long distance uploads, you can use all this thing. S3 transfer acceleration. We have talked about all of these things. In some data migration, we have talked about go-to services, database migration service. But if your data is in this range, 10 petabytes, 1 petabyte, all of these things might not help you, or even if it helps you, it might take 124 days or 12 days or whatever. And if you can't afford that, in that case, you have to go for offline methods. This is basically where we talked about shipping the data onto the physical devices like Snowball, and then shipping that device back to AWS for them to plug in and move the data into S3 through their fast connection network cables. So, sorry. We can schedule regular intervals for the data to be moved into AWS. We talked about various file exchanges that we could use as well if your application needs that service. And finally, if you want to transfer data over long distance into S3, you can utilize S3 transfer acceleration. We also talked about migrating databases. So if you need to migrate databases, this is your go-to service to do heterogeneous migration as well as homogeneous migration from one database platform to another. Then we talked about streaming data into AWS, and Kinesis Data Firos is great at taking your streaming data and loading into its final destination, whether that's S3 or Redshift or Splunk or Elasticsearch. And remember, we can transform the data before it lands onto its final destination using Lambda as well. And finally, we talked about this offline migration, and this is where Snowball, Snowball Edge, and Snowmobile come into play. What we can do is load your data into those physical devices. How much data over how much network bandwidth can go for how much time period, and what you need to ask yourself to figure out what service you might use, whether it is online data transfer, offline, or some sort of hybrid data storage connectivity. Now, I would like to conclude this with few FAQs which might come up in your examination. And this is the last section of this particular module. And this is basically, I like to call it checkpoint. So here we'll quickly go over the summary. We'll talk about some facts and questions. Then we'll end this with a simulated exam question that I ask in every module to get your brain thinking if you do that. Now, we talked about various ways of how you can get data into AWS. We talked about online data transfer, offline data transfer, migrating databases from one to another, migrating from homogeneous to heterogeneous solution. And then we talked about all this network speed, kind of manipulating what kind of service you might have to use. And that is going to help you determine online versus offline. And we talked about direct connect there. Direct connect is going to be one of those services that you might want to use if you want a direct connection into AWS, if you have a low network speeds and you want speed of the transfer from your on-premise into AWS. If you're using dedicated connection, it can provide you a capacity of 1 gigabyte to 10 gigabyte of network connections. Then we also have hosted connections, and we didn't talk about hosted connections in depth, but just know that if you want to use third-party services as a direct connect hosted actions, then we can use 50, 100, 300, 400, 500, or even 10 gigabytes of speed per second. So you're not bounded by just 1 gigabyte and 10 gigabyte. You can actually use a hosted connection to vary those network speeds. And remember, hosted connections are through AWS partners. Now, another important thing is, well, how much is setting up a direct connection going to cost you? What exactly you are built for? Well, that's actually two separate charges to remember whenever you are setting up a direct connection. First is the port hours, and then it's the data transferred out of AWS. Remember that data transfer into AWS is always free, but the port hours and the data transfer out is going to cost you something. So a transfer in inside AWS is free for all locations. It is $0 per gigabyte, but the transfer out, it is going to be dependent on the source region and the direct connect location. And it can range from 2 cents to 19 cents per gigabyte. So this table basically right here shows you the port per hour rate. So you can see this, that for a 1 gigabyte connection, it's going to cost you 30 cents an hour. That's for every region but Japan. And then 10 gigabytes per second, it's going to $2.25 an hour for every region but Japan. And as you can see, the port hour rate for Japan is just a little bit less than all other regions. So that's all you have to, again, understand what exactly you are charged for. You don't have to remember these limits, but you have to understand that here what you are charged for. Then we talked about offline data transfers. So if you're not wanting to use a direct connection or transfer data over internet, we can use offline data transfer as well. And that's where the Snow family comes in, meaning we can load our data into one of the Snow devices, ship that to AWS, and they are loaded into S3 for us. So whenever we use the Snow family, how quickly can we migrate X amount of data? So that is a typical question that might be asked as well. Well, AWS says that typically you can transfer up to 100 terabytes in about a week. Now with the Snow Mobile, you can actually transfer up to
1 terabyte per second. So that means that 100 petabytes of data can be migrated in just a few weeks. So here is a table that kind of goes through each of the Snow services, Snow family services, what they are used for as their use cases, as well as the storage capacity. Now, of course, Snow Cone is going to have the smallest storage capacity, but it's really used as an edge computing device, as I told you earlier, and very little data transfer device. Now, if you want data transfer, we want to transfer a lot of data, but we don't want to have petabytes and petabytes of data, then Snowball storage or just Snowball may be our best option. Now, if you want to have edge computing as well as data transfer, in that case, you have to go for Snowball Edge. And of course, if you have tons and tons of petabytes of data, and that's where we might have to use Snow Mobile. So we then talked about our database migration service, and we talked about the supported migrations that are offered. So we can have database migration service to do heterogeneous migration as well as homogeneous migration. So we know that we can use database migration service for one-time migrations, but what about continuous data replication? Well, data migration service is great for this as well. So you can capture the changes from the source and apply those to the target database. So if you do decide to use database migration service or DMS, what actually it is going to cost you. So this one tells you about that. So here, all the data that is transferred into DMS, as I mentioned, is free. From DMS to RDS or EC2 instances that are in the same availability zone, that's also free. So remember that data that is transferred within availability zone, that is going to be free. Anytime your data leaves an availability zone or a region or outside of AWS, that's when you are going to be cost for. And then we talked about data pipeline and how we can set up schedules and automate some of the migrations as well as transformations of your data. So what are some of the standard activities that data pipeline gives us out of the box? So it gives you a few things like copy activity, which as the name suggests, it just copies data between S3 and any of the JDBC data sources. You can have run a SQL query and copy that output into S3. We also have Hive activity, and this one allows you to execute Hive queries pretty easily. Then we have EMR activity, which allows you to run EMR jobs within your data pipeline. And we also have this shell command activity, which allows you to run any Linux shell command, migrate, transform, change, or manipulate your data using data pipeline. So these are the standard activities that data pipeline gives you out of the box. Then there was one thing which is preconditions. So what are some of the preconditions that data pipeline gives us again out of the box? So we can check to see if there is any data inside DynamoDB table. So basically, these are some checks. It won't do anything unless these checks are fulfilled. So first one is whether DynamoDB table exists. Then if that S3 folder exists, if that particular prefix exists, and some shell command exists as well, basis your needs. So there are some preconditions that data pipeline gives you with all of these things. Now, for me, the first answer seems incorrect just because you don't necessarily need to create a Hive job to create some metadata catalog for your schema in Oracle. You can actually do that with Glue itself. So they have introduced, so basically it seems a bit redundant that you're using two services which are going to actually do the same job. So that's why I'm going to go ahead and mark that one as out for sure. It's also redundant to set up the EMR have job at all when you kind of do all that with Glue already. And then if we read answer B, it doesn't really say anything about making the transformation. So changing some of the data types and addition of new primary keys. So that one is incorrect because of that. Now we are left with C and D. And you guys already answered C. So let's see. Now looking at C and D, to me, database migration service seems like a perfect scenario where this data might be used. So let's read answer C just to make sure that everything is covered. So we can use database migration service. We can define the table mapping rules. We can go ahead and define the new data types and the new primary key. So bam, that requirement is hit. We can then use the database migration service test to move the data from the Oracle instance to the RDS instance. Bam, that requirement is hit as well. And then we can ensure that the change data capture is being used for the ongoing replication. That means that the Oracle database isn't going to go down now with answer D. There's nothing that states that Oracle database is not going to go offline. So because of that, I'll go ahead and mark that one out as well. And as you guys correctly said, we'll go ahead with the answer, which is C, which is the correct answer. So whoever answered that right, that's a good one. And that was a tricky one as well, little bit. And yeah, these are the kind of questions that you can expect as well. So hopefully that was a good exercise and that got your brain thinking, apart from just listening to me on how you can diagnose some of these questions and where some of the answers fit into the requirements and the scenarios. Now, I hope you learned something new through this section and getting your data into AWS. So after this, we are going to start another big section, which is to introduce data or introduction to your EMR. And that's a big one. So here we are going to cover Elastic MapReduce or EMR. And now this service plays a huge role in data analytics and data processing and big data frameworks. So you need to have a good understanding on the various services that you can use, the various scenarios, and it's going to come up on the exam and tons of questions as well as the answers. So you need to make sure you understand EMR inside and out. Now, if you're following along, we have talked about how we can collect things like streaming data, data from other sources, or data from on-premise. We talked about how we can move that data into AWS. We have also talked about various ways that we can prepare or transform that data. Now we are still talking about data preparation, but now we are moving along data analysis as well. And that's why that section is marked here as well. We can use the EMR architecture and the Hadoop framework to process and analyze massive amounts of data. Now, this service is expensive and it uses a lot of compute power as well, but it gives you the ability to process massive amounts of data in a short amount of time. So if you're ready to learn more about EMR Hadoop framework, let's quickly get started. And before that, I'll just drink some water. So here in this section, it is about Apache Hadoop and the EMR software collection. And as I mentioned, there are certain things which are expected out of you. This is one among them, that you're here to learn AWS and not Hadoop, EMR. But again, as I mentioned, I'll try to cover and bring you on pace with whatever is expected out of you. So before we dive into talking about Apache Hadoop and the actual software that's installed and configurable within EMR, we need to talk about the basics first. So the basic here is MapReduce. So what we'll do is we'll talk about MapReduce, and then we'll talk about distributed file systems. We need to make sure we understand these concepts before even moving forward with EMR. Then we'll talk about HDFS or Hadoop Distributed File System. Then we'll talk about Elastic MapReduce, which is what we have to talk about, the main thing. But before that, as I mentioned, we need to have some sort of foundation for the people who might not know all these things like MapReduce, Distributed File System, HDFS. So that's where we'll actually start talking about the thing in concern, which is EMR. We'll talk about then different storage options that we have within EMR. And then finally, we'll finish this particular section with a summary. Now, it's important to understand what MapReduce is if you are not familiar with Apache Hadoop or EMR. And we'll start off by talking about Elastic MapReduce or just MapReduce, not Elastic MapReduce at this point of time. And MapReduce is basically a technique that data scientists can use to distribute your workloads across many different computing nodes so that they can process different data and process and get the information back quicker than just doing it on a single node.
So let's take a look at this example of MapReduce. Again, oversimplifying things here. So, so imagine I asked you a question here on this particular slide that can you tell me how many Google Cloud icons there are? And what about AWS icons? Just disregard any of the Azure icons with the little triangles, but you can tell me how many there are now. Obviously, this is very simple. I'll give you time, 10 minutes, you can count them and you'll give me the answer. But in a one glance, can you give me that answer? On top of that, let's imagine there were not this many. There are hundreds of thousands of this. Your eye would not be able to determine how many there are. So what we could do here is we can create a MapReduce function, and a MapReduce function that we are going to create is basically going to catch all of the AWS icons as well as this GCP icons, and finally it is going to disregard any of the Azure icons. So can you tell me now how many there are? In just 5 seconds. Nope. So with your MapReduce function, what happens is your workload is distributed across many different nodes. So
let's have a quick quiz question, guys. And the question is, in AWS, what does a virtual private cloud VPC enable you to do? Option A, securely connect to a physical data center. Option B, share resources with other AWS customers. Option C, isolate and control your network environment within AWS. And option D, provide a public-facing web server. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
You can imagine that this orange node is going to process this particular information. Then this red node is going to process only this information. And the green node, it is going to process only this information. Now the red node is going to process this information, and the green node is going to process all of these icons or this information, whatever it is. So what happens in MapReduce is that the workload, first, it is split evenly across these nodes. That's the first thing. So the processing power can be used individually. Instead of assigning the entire processing power to the entire process, you first split the workload and then you split this processing power individually as well. Now you can imagine this can be scaled to hundreds and thousands of nodes if needed. In this example, we have just 3 nodes. Now, once the orchestration of breaking the data apart has occurred, in that case, what will happen is each of these nodes is going to apply their map phase. And this is where each node counts the various icons. This is your map phase. Every node will count this various icons. At least in this MapReduce function, or whatever processing needs to be done, whatever is in this MapReduce function, that will be done. In this one, it is just counting. So this is known as your map phase. Once the map phase is complete, then the reduce phase happens. And in this case, all of your data, it is going to be congregated basically on a single node where the reduce actually determines whatever needs to be processed. So in this case, it just counts the number of icons. So you can automatically see AWS has 50, GCP has 45. And now again, if I show you that picture of all the icons, you would have not been able to tell me just right off the bat, right?
And this is known as the reduce phase. So there's a lot more going on under the hood, but for a simplistic understanding of what map reduce means, it's essentially breaking apart a processing task over many different nodes, having a map phase where some processing happens or some counting happens or some filtering or aggregation or some what all this kind of task happen, aggregation, filtering, counting, things like that. And the reducer phase is where all of this data is congregated onto a single node. It can be multiple nodes, but in this case of EMR, it's congregated on a single node. And the output of our map reduce function is finally determined. So now we understand the idea of map reduce. Anybody has any question on map reduce? And for understanding, you can just consider it single. It's definitely going to be number less than your number of nodes working on those tasks. Okay, so as this is clear, let's talk about distributed file system. So just imagine that you have this two huge files with tons and tons of data. You can imagine this being, let's say, gigabyte file or many gigabytes file within a distributed file system. So here you have a primary node. Now in some context and in some literature that you might read on internet, you might hear this things being called master nodes. Now for my section, my teaching, I do not like to call them that. I call them primary nodes, but if you read them master node somewhere, both are same thing. So just know that primary nodes and mean the same thing as master node. Now on a distributed file system, these files are actually broken up, but they look like single files on your primary node. So they might look something like this, but these files are broken up into multiple parts. So they might so just imagine that we have some secondary nodes. Now you might also hear this being called as slave nodes, but for this particular section of my training, I'm going to call them secondary nodes throughout this course. And what happens is that these files are split up across the secondary nodes. And not only they are broken up across the secondary nodes, they are also replicated. So if you see here, this is one file, which is some 100 gigabytes file, which is file 1. What happens is it goes to this 1, this 2 goes to 2, 3 goes to 3, 4 goes to 4. These are all very big files. Now, apart from that, what happens is that it creates copies of this as well. It creates multiple replication or copies of this broken up blocks or broken up files. So what this does is allows us to say, lose one of the secondary nodes, but still you will have a copy of that data. And that's what makes distributed file system so resilient and so powerful. So just like everything that Apache does, they actually built out a piece of open source software that handles the management of distributed file systems for us. And this is where Hadoop comes into the picture. So HDFS, it stands for Hadoop Distributed File System. And this is nothing but just an open source software that helps run distributed file systems running on many computers or many clusters to solve problems involving mass amounts of data. So HDFS is highly fault tolerant. Why? Because it replicates the blocks across many different computers. It provides you high throughput access, and it's suitable for application having large data sets. So this is where Hadoop shines. But the problem with setting up an Hadoop cluster or HDFS cluster is that it can be pretty difficult. Because just imagine doing all of these things on your own, that you are sending one big file and your Mac somehow figures out that, okay, I have to save this file in 10 different Macs. And then if Harsh asks me, give me that file, I should be able to work on those all files in 10 different Macs and finally give him the consolidated file in this one Mac itself. It's a pretty difficult task. Even if you're not doing on one Mac, if you're doing on an entire cluster, even then
setting up all this cluster and all these things is pretty difficult to do. There's a lot of headache, lot of maintenance, lot of management that goes up into setting up a successful Hadoop cluster. And this is where Elastic MapReduce comes to the rescue. So Elastic MapReduce, or EMR, is a fully managed AWS service that allows you to spin up Hadoop ecosystem. Now, not only you can store data on HDFS, but some other storage options as well, which AWS gives you. Otherwise, HDFS is the only option. In AWS, you have little bit flexibility in that. So what it does, as it is a fully managed service, it allows you to spin up your Hadoop ecosystem, and it allows you to save your data on other storage as well, apart from HDFS. So we have HDFS, we also have EMR file system, and finally you have data that goes into S3. So it is called as EMR FS as well. So these are the few options that you have in terms of storage. Now, we are going to talk about all of these storage options over the next few sections, but just know that you can store your files in HDFS, you can store them in S3, or you can store them on the local file system. Now, Hadoop, it isn't the only piece of software that runs on an EMR. There's actually a plethora of applications and open source software tools that you can pre-install, or you can install and configure yourself on EMR. And when I say install and configure, all you have to do is literally check a box. You don't have to actually install it. AWS does it for you. So you just have to mention, I want this installed, I want Presto installed, I want Jupyter Notebook installed, I want you installed. You just check those boxes and EMR takes up of the installation. They take care of the maintenance. They make sure that it's up to date, and they make sure that all of the software systems are able to communicate within one another as well. And again, each of these software systems do different things. So we have, in this example, Apache Spark. That is for ETL and big data processing. Then you have Hive, which is another ETL service. You have Presto, and this is SQL query engine that you can use, and Athena is built on top of this Presto. And we also have Jupyter Notebooks. If you want to have code sharing, or if you want to write Apache Spark programs right within your EMR cluster, we also have Apache Pig, and that is for large data analysis. We also have things like Zookeeper, HBase, U, and of course the Hadoop distributed file system. And these are not the only softwares that can be installed onto EMR. There are tons of them, and whenever you create your cluster, all you have to do is pick and choose what you want to install. So let's quickly take a look at this in the cluster, the console itself. So in console, if I'll go, where is my AWS, blah, 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 blah. I'll call it MR. Then it asks you for a version. As you can see, they keep on updating all the possible versions that are being released. They keep on giving you all those versions. All you have to do is select one of the version, and then you can point it to an S3 folder where exactly you want to save those logs and blah, 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 blah. Here, as I mentioned, choosing application is pretty simple. All you have to do is click on this. I want Spark, I want this, I want that. It will create everything for you. All you have to do is provide instance group. You want as I mentioned, it's a second level service, which means it is built on top of EC2 instances, but they have done much more on that. So here, your job is to choose whatever is the size of instance you want. This is your primary. This is your core node. Then you have task nodes as well. And that's how you set up a cluster. And then there are a few options which we are going to talk about, but not now. And what else? All you have to do is check all these applications that I want Hadoop, I want Hive, I want you, I want Spark. All you have to do is check on these options.
And that's pretty much it. And so with this, we have kind of done the introduction of EMR. So quickly summarizing what we talked about. So we talked about what map reduce was, and we talked about the mapping and the reducing portion. But really, it's the splitting, mapping, shuffling, and the reducing of your big data to produce a desired output. There are a few other things as well, but we talked about mapping and reducing, which are the most important ones. So this is how large files are split and replicated across many nodes. We then talked about HDFS or Hadoop Distributed File System. And this is an open source piece of software that makes it easy to run distributed file systems. And then we talked about EMR, and EMR is a fully managed Hadoop cluster in AWS that stores, processes, and analyzes big data. And we ended on talking about the storage options that we get in EMR. We talked about HDFS, we talked about EMRFS, and then we talked about the local file systems, how we can use instant store volumes or EBS volumes here. So that is pretty much it for this particular section. And yeah, if you have questions, please, like for an example, as I mentioned, Lambda is one of the ETL options. But let's say you are dealing with the data which cannot finish whatever it is supposed to do in 15 minutes. In that case, you cannot go with Lambda. Lambda goes in that option. There you are left with EMR, or you are left with this thing, Glue. Both can do their job for this particular scenario. But Glue is only made for ETL. So if your job is only about ETL, stick with Glue. Glue is made for that task. EMR, it can do ETL, but it can do some custom and other workloads as well. So depending on how much, again, as I mentioned, EMR is the most costliest one. Glue, it is a serverless service. So if you want to save money and if your job is related to just ETL, you should definitely choose Glue and you should not choose EMR. If your job is, again, what do you say? ETL related, but it is not a job which is a bad job and it will keep on running for half an hour or 1 hour. In that case, you should not even choose Glue. You should go for Lambda. So again, the answer boils down to how much you are willing to spend and what is exactly is the use case and how much time it is going to take in terms of processing. For an example, Glue, it can do wonders there, but your job needs to be, what do you say? Work on data which is what petabyte level. Terabyte level, Glue is fine as well. Even for petabyte level, you will feel that okay, Glue is actually costing me more than keeping a EMR cluster. So again, there's no one answer for anything here. So more like, for an example, you're dealing with data which is, let's say, video data or image data. For that, Glue might not be an appropriate option. It can do to some extent, but EMR is more made for that. If you're dealing with any data which is relational or NoSQL kind of data, for that Glue works. Whatever EMR can do, Glue can do as well. But this kind of niche use cases where you are dealing with image related data, video related data, EMR has few more capabilities in terms of that. So here we'll start off by looking at the EMR architecture. We'll talk about primary nodes and their features. We'll talk about core nodes and their features. We'll also talk about task nodes and their features. We'll then talk about single availability zone concept, meaning that EMR has all of its cluster and all of the EC2 instances that it is comprised of in a single availability zone. We'll talk about EMR storage options in detail. We already talked about them. Then we'll end this up with a summary. So let's quickly take a look at the EMR architecture. So this is how the entire architecture look like. A simplistic diagram. It can be much more complex as well. But in this example, you have an EMR cluster, which is in a, so this basically entire cluster is spun up in a single availability zone. Now, every single EMR cluster has a primary node, and it can have 3 primary nodes actually. So it's either a single primary node or 3 primary nodes. And this primary node, it manages all of the components in your distributed applications. Now, whenever a job needs to be submitted, or some processing or some MapReduce task need to happen, this is where the core node comes into play. And this core nodes are managed by your primary nodes. And the last part in the EMR architecture, as you saw here, is your task nodes. So that's it. That's pretty much the EMR architecture. But a lot of moving parts are there. But overall, that's all it is. A primary node or a maximum of 3 primary nodes giving instructions to core nodes. And then you have some helping task nodes as well. Now, to perform some sort of task nodes are optional, by the way. And what they do is they basically add power to perform more parallel computational tasks on the data. And they basically help out your core nodes. That is their job, to help out the core nodes. Now we'll go over each of these sections in detail over this section. But I'll start off by talking about the primary node first. Now, like I mentioned, majority of the time, you will have a single primary node. And until recently, you had the ability to have multiple primary nodes. Now, whenever you launch a cluster, you will have the option to choose between 1 primary node or 3 primary nodes. And the reason why you would have multiple primary nodes is so that you don't have a single point of failure. So if one master node fails, the cluster uses the other 2 master nodes to run without any interruptions. And what EMR does is it automatically replaces your primary node and provisions it with any configuration or bootstrap actions that need to happen. It does another primary node. So all it does is remediate the single point of failure. The primary node also manages the cluster resources. So it essentially coordinates the distribution of parallel execution for your different MapReduce tasks. You can think about it as the boss that's handling out tasks to its various employees. And it also tracks and directs the HDFS. So the primary node knows how to look up files and track the data that run on this core nodes. So the primary node is also responsible for the YARN resource management. Its job is to centrally manage the cluster resources for multiple data processing frameworks. So all of these frameworks that it uses, if it is primary node job to allocate to manage all of those data processing frameworks. It also performs monitoring and health on the core and task node. So its job is to make sure that the status of the jobs that are submitted, they are in good health, and that the core and task nodes are up and running. Now let's talk about what are some core features for core nodes. The core node features are, well, what they do is they run tasks for your primary node, as simple as that. So the primary node manages all the tasks that need to run on this core nodes. And this can be things like MapReduce tasks, Hive scripts, Spark applications. The core node is also responsible for coordinating data storage. So it knows about all of the data that's stored on the EMR cluster, and it runs the data node daemon. This means that it breaks apart all of the files within your HDFS file system into blocks and distribute that across the core nodes. And finally, we know that we can have multiple core nodes, but we can only have one core instance group. And we'll talk about more about this instance group later, or what instance fleets are in just a little while. But just remember for now, just keep it in your brain that you can have multiple core nodes, but you can only have one core instance group. Finally, let's talk about task node. As I mentioned, some feature of the task nodes are, firstly, they are optional. They are optional helpers, meaning that you don't actually need to spin up any task nodes. whenever you spin up your EMR clusters. You can run your EMR clusters even without task nodes as well. They are optional and they can be used to just provide parallel computing power for tasks like MapReduce or Spark applications or any job that you might run on your EMR cluster. Now, one thing that's important to remember is that they don't store any data. This means that data can be added or removed on the fly from your cluster. This is a very important point to remember. Task nodes are basically to ramp up any extra CPU or memory for compute intensive applications. Basically, think of it as your gym trainer. It does not come and help you unless you are not able to lift too much weights. So when there is too much pressure on your core nodes, then only this task node will come as your gym trainer and it will help you lift that up. But obviously, they are not going to build your body for you. You have to do that by yourself. So the analogy to remember here is that they do not store any data. This means they just can be added or removed on the fly from your cluster depending on the need. So this can help ramp up any extra CPU or memory for your compute intensive applications. Now that we talked about the features for primary nodes, core nodes, and task nodes, let's talk about single availability zone concept. So why does EMR clusters only reside in a single availability zone? Any answer to that? You guys can figure out, guess. Okay, so the main reason is your block data replication should happen faster. This means that you can find your files faster when you are trying to find them on HDFS. Also, the communication between nodes. So whenever core nodes are processing back and forth, they're able to communicate faster. Also, the need to access the metadata, as well as the easeability of launching a replacement cluster. So if let's say one of the nodes goes down or has some sort of overload, that is when that is why it is a single easy concept. Now, we talked about some various storage options that we have, either storing data onto our Hadoop cluster or our EMR cluster, or how do we access data from outside the EMR cluster to kind of act as a hybrid HDFS system, and that is your EMRFS. And we'll talk about them in a little while. Let's quickly look at all these various storage options. So what I would like to do now is go through each of this and talk about some of the benefits and some of the usages where we might want to use this various file systems. So the first type of storage options that we have is local file system. And this is just the instance storage associated with your EC2 instances of the core nodes. And these are located on the disk that's actually attached to the host machine. So to the EC2 instance that the core machine resides on. So if you are aware about EC2 instance, EC2 is installed on some disk. So that disk is basically called instance storage, and local file system is referring to that only. So it is associated with wherever is your core machine resides on. The speed and the size is determined by the actual instance type that you decide to spin up. And this might be used for very high input-output performance. That's the only use case. I mean, not the only, that's the major use case they have, because their data and the compute both are in same places. So in this case, if you have a requirement which requires high IOPS at a low cost, in that case, because it uses caches, buffer, it has scratch data as well. So that is an important use case of local file system or instance storage. But there is a demerit as well, or a con as well, that if you shut this down, you are going to lose the instance storage data. So that is a negative which you have to keep in mind. We also have a local file system or an extra EBS volume that we can add on top of HDFS. So this is used to extend your HDFS, but these volumes are ephemeral as well. And of course, we have our HDFS or Hadoop distributed file system. And this is a very, very fast and efficient way to accessing data on a distributed file system. But just know that this is ephemeral, meaning if we terminate the EMR cluster, we are going to lose the data that's on our SDFS. And SDFS is really best used for caching results produced by your intermediate jobs that we run on our EMR cluster. And finally, the most appropriate solution that you will probably want to use is EMRFS, which is usage of basically, it gives you the best of both worlds. It gives you whatever SDFS does, but it gives you the persisting ability that S3 offers. It has also other features like encryption, consistency, versioning, all the things that S3 offers. So once you terminate your EMR cluster, you're not going to lose this data because obviously it's in S3. It's not in EMR or SDFS kind of thing. So most often you are going to use S3 to store your input and your output data whenever running EMR tasks, and intermediate results can be stored onto SDFS. Now in the further lectures, we are going to talk about how we can copy data from S3 to our EMR cluster if we need to. But for now, just understand that these are the basic storage options that you have with EMR, and you'll choose one of these options whenever you're setting up your EMR cluster. Whenever you're trying to process and store your data either in EMR or use S3 for input and output of your data.
Yeah, that's pretty much it. Thank you, Dibendu. That was a nice recap. So after this, I am going to talk about different EMR operations. And what I have done is I have broken down this into 5 different sections. And the first section, we are going to talk about transient and long-running clusters. So to give a lesson breakdown on this particular lesson, we are going to talk about transient clusters, and we'll also talk about long-running clusters. So in a previous section, we talked about how Elastic MapReduce is a collection of pieces of software that run on a managed Hadoop cluster. And if we dive into the AWS console, this is what exactly it looks like. So if you go to AWS console, this is what you will see. As I mentioned, EMR, Elastic MapReduce, is a managed service. And here in the console, you can create a cluster by selecting the create cluster option. And then we have different options over here. And you can see all the different frameworks or software applications that we can install onto our EMR cluster. And as I mentioned, installing them is as simple as checking all these boxes, and it will install all these things for you. So if you want to install something onto your EMR cluster, what you can do is you can check the ones that you want and uncheck the ones that you don't want. And you can also select from a drop-down the list of different versions of EMR that AWS has released. And each of these have their own versions of all of this software installed as well. So instead of having to spin up multiple EC2 instances to create a cluster and then installing all of these libraries or all of these pieces of software manually, you can do it right here within the AWS console or the SDK or the CLI, and just choose the pieces of software that you want. And AWS is going to make sure that they are up to date and they are working as a collective and integrated software collection. So in this section, what we are going to talk about is transient versus long-running EMR cluster. So we saw that we could create EMR cluster in the console, right? Like this, you just select all these things, provide the name of the cluster, and it is going to create a cluster that's always running, or it can be transient as well. Now, when you think about transient, definitely. So transient basically means it is temporary in nature. So example of that or an analogy of that I have used here is something a firecracker. You put on a firecracker and it just does its job, and after that it's gone. So I like to call that a transient cluster. And long running is something, the image that you see over here is the Machu Picchu, and that is here for a lot of ages, and that is still a structure over here. So that is an example of a long running cluster. So transient EMR cluster is something like, for an example, so
For transient cluster, just think about a firecracker that goes off whenever it's some parade or whenever a celebration is happening. It's very quick. It doesn't last a long time. And then think about long running EMR clusters as being something that is ancient, something that's been alive and been, an old civilization that's been long lasting and running for a long time. And on the right hand side, this is the Machu Picchu in Peru. And these are some of the oldest Inca ruins in the world. So think about transient as being something that's fast and that only has one job and one process to happen. And when it's done, it's done. And think about long running as something that's continuously running, that never stops. And that is a process that is always ongoing. So let's take a look at some of the scenarios where we might see a transient EMR cluster being created. Let's imagine that we have some task that needs to run every single Friday of every week. And we need to produce some graph or some metrics to show our boss, or boss's boss's boss, or the CEO of the company. Let's say the most important person, and we have to run some EMR cluster to be able to process the data. And let's say that this analytic process needs to show the amount of users or the percentage of users that are using your application, and then what type of operating system they are using. So you can imagine that the log files that come in from requests from all of your users have this particular operating system that they are using to access your application, and all of that stored into, let's say, S3. Well, what we could do is create a transient EMR cluster, and that EMR cluster can be created through AWS CLI, the API, or we can create it in the console itself. We could then create a Hive script and run the script as a step within a EMR cluster, and a step is just used within a EMR cluster for a unit of work. So it needs to accomplish some tasks, and this Hive script is actually going to read the log data that is stored in S3. So this is all of the access logs that has all the information about all of them users and what operating systems they were using. We can then use the Hive script to congregate this data to determine what operating systems they were using, and then return the percentage of users that were using that particular operating system. So we can output the results into an S3 bucket, and then when all of this is done every Friday, this is going to be ran. And then once it is complete, then we are going to go ahead and terminate the EMR cluster. And that is the important and vital information here, which is we are terminating our EMR clusters. So that's what your transient cluster is. As soon as the process and job is ran, the cluster is terminated. So whenever we create an EMR cluster, either within the CLI, the API, or the console, we can create steps that run as soon as the EMR cluster is spun up. So if we take a look at what this looks like in the console, so basically it will do all of these jobs, run the site scripts, then save all of this data into S3, and then finally it will terminate this instance, as you can see over here. So this is basically a transient cluster. And if you look at how it will work exactly in the console, is something like this. Here you can choose from all of this different settings. We can either choose a Hive program, a Pig program, or a Spark application, a custom jar, or any other streaming program. And then we'll go ahead and select a half program, and we'll add that step. Now, what we can do is add the location for the Hive script. We can then tell it where the input data is. So what S3 bucket the input data is in. We can then tell it where to store the output for the Hive query. And then we can go ahead and select any of the options for the actions on failure as well. So whether to terminate the instance if it fails, or go ahead and continue running the instance if it fails. You can see here that it says after the last step completes, go ahead and put the cluster in a waiting state, or auto terminate the instance. So these are the options it gives for a transient cluster. This is what we would select if we wanted to create a transient EMR cluster. So a long running EMR cluster reminds me of the mascot for a certain battery brand. I'm not going to say the name of it, but the batteries keep going and going and going and going. You have seen the ad, I'm assuming. So that's what long running EMR clusters are. They're continuously running and they have their own costs and benefits. So let's take a look at some of the considerations that that might need to happen, that basically might need to be made whenever you are comparing using a transient versus a long running EMR cluster. So if you have a total number of EMR processing powers per day is less than 24 hours, then you can probably benefit by shutting down your clusters or terminating them, and you're not going to use HDFS as your primary storage, then transient EMR clusters may be your best option. And also if your processing jobs are intensive and iterative. Now for the long running cluster types, if you're frequently running processing jobs, and that's where you benefit from keeping the cluster running after a previous job is run, then this might be the best option. And if your processing jobs have input output dependencies from one another, so if you run a job and then it has an input from another job and an output to another job, and that job runs the output of the previous job, then you might benefit by running long running EMR clusters. Although this is rare, it might be more cost effective to store your data in HDFS rather than S3. And finally, if you have requirement that requires high performance input output that HDFS provides. As I mentioned, what is the benefit of choosing HDFS as your storage? It gives you high performance input because it is in the memory. It is closer to your compute wherever it is happening instead of going to S3. So if you have that kind of requirement, you will choose HDFS. Then you would want to use a long running cluster over a transient cluster. So these are some considerations that you might need to make when choosing a cluster type. And this is the end of this section. I'll just pause here to see if you have any questions on this about transient versus long running clusters. And this is what you provide here. As I mentioned, what you do is you provide whatever name you want to give this. It could be any arbitrary name. You provide where exactly is the script located. For an example, you have this Hive script which reads from one table, then it does some operations on this data like filter it with where clause and all those things. And finally, once you have all this filtering, give me the result. So that would be the input location of the script. You provide the output location where you want to save this filter results as well here, and it will save all these things. And this one defines what exactly you want to do if there is some failure. If there is any failure, whether you want to stop this program completely or you just want to keep going. Any other questions? Okay, I'll take that as a no. The next option that we have is, how do you choose an instance type? I already told you, it is a secondary level service. And you tell me now what it is based on. Which service it uses is the primary, as this primary service, EC2. And EC2, you do have to choose instance type, right? You choose T2.micro, M3. whatever, and all those things. You choose that. So here in this section, we are going to see how do you exactly choose that instance type. Again, a high level overview. Ideally, you should know this, but as I mentioned, my job here is to make sure that even if you do not know EC2, you do not know about instance type, what you can expect from this certification, and just prepare you a little bit about it. So this becomes an important question, that which instance type should I use for my EMR cluster? So in this section, we are going to talk about choosing an instance type for your core nodes, for your task nodes, and for your primary node. Now, in the last section, we talked about transient clusters and long-running clusters. And in this section, we are going to cover cluster instance type. So you might be asking the question, which instance type should I use for my EMR cluster? Whenever we provision an EMR cluster, the instance size of our nodes is important because you might have workloads that are CPU intensive. We might have some that are input, output, or memory intensive. So there are tons of different instances that you can choose from. And here is the documentation for EMR. And that gives you a list of all the different instance types that you can use. And obviously, I can understand it is pretty overwhelming. And don't worry, you do not have to memorize all of this for your examination. But it's good to know some of the instance types that you can choose from and what their jobs might be for various EMR tasks. Now, whenever we are choosing an instance type, we are really choosing it either for the primary node or for the core or task nodes. we can bunch core and task nodes together because the primary node isn't going to be super compute intensive. What is the job of primary node? Actually, it is not doing any job in as such. It is just giving job to your task node or core node. So you can save some money by giving it a basic instance type, because whatever it is supposed to do, it can be done on lower instance type as well. And yeah, that's how firstly you save some money. So the primary node does not have to be large computational requirement. So the cluster with, let's say, 50 or fewer nodes, you might want to use the M5 family. And for the clusters with greater than 50 nodes, you use the M4 family. Again, these are some recommendations by my experience. You might find something else over the internet or whatever other trainers or something. This is as per my experience, that whenever you're dealing with a cluster which is 50 or fewer nodes, you can choose M5 and save some money. And if you have more than 50 nodes, then definitely have to choose something which is M4 or M3, something like that. But M4 worked for me, and that's why I put it here as well. So it just really depends on the type of processing. Now for general purpose, which is a good balance of CPU, disk space, and input output, maybe you want to use the M5 for batch processing or high performance computing or CPU intensive machine learning, not GPU intensive. So CPU intensive, I'm saying. So you might want to use C4 or C5 or even C1 now for graphic processing or GPU intensive machine learning. The class that is important is the G2, G3, G4, P2, and P3. These are all containing the GPUs. So if your application actually it's a machine learning application, for an example, all these LLMs, they are definitely built on GPUs. All this ChatGPT, Bard, or whatever you see, all are built on all this GPUs. For that, definitely you have to choose among this. Now, actually, Amazon has created new instances as well, specifically for that. But again, this slide is before that time. So till then, you used to use all this, either G4, G3, or P2, P3, things like that. All of this contains GPUs. Now, for your Spark applications with a lot of memory caching, you might want to use R4 or the R5 family. And now for the dense storage and the map reduce job that require high input output performance and higher IOPS, you might want to use the H1, the I3, or the I2, or the D2 family. So again, you are not going to have to memorize this, but it is important to understand the different types of processing that you can do on EMR and how some of these families fit into these pictures. Now, it is important to remember that AWS limits you to 20 EC2 instances per region. And you can request a limit increase on that just by contacting AWS support. And yeah, that's pretty much it about the section about choosing the right instance type. Obviously, it can go on, and it can be a 3-hour lecture in itself. But again, for this certification sec, you just have to understand that for what kind of task, what you can kind of accommodate with this kind of. So just remember that general purpose, M5 is fine. For batch processing, C kind of instances are fine. For GPU, G3 or P2, P3, I find. For Spark application, which requires memory caching, R4, R5 are good. And for large IOPS performance, you have to choose H1, I3, D2 kind of instances. We talked about transient clusters, long-running clusters, as well as choosing an instance type. Now, this is extremely important, so pay attention here. How do we exactly choose the right number of instances? In this section, that's what we are going to talk about, that choosing the right number of instances. So if you have asked this question, good for you, good for me as well. But if you haven't, you should have. That how do I pick the right number of instances for my EMR cluster job? Now, since we learned in the last section that instance type and which instance type are best for the particular EMR jobs, and then pairing the best instances with the right number of instances will help us to, in our EMR cluster, to handle any workload and amount of data that needs to be processed. And it is important to understand that an undersized cluster will be slower, and an oversized cluster is going to lead to unnecessary cost. both of the situation we want to avoid. So it is important to get this number right as you are creating your EMR clusters. So basically tuning your EMR clusters as well as processing and sorting data from EMR. So we'll take a look at how we can choose the right number of instances for a primary node versus our task nodes. Now with the primary node, you're probably going to be okay with just one primary node. But as I mentioned, you can also have 3 primary nodes. And this is a newer feature that helps customer maintain availability for their primary nodes. This is introduced just now, 1.5 years ago. Before that, you only had the option of choosing one primary node. So in this case, if a primary node goes down, AWS will automatically detect that, and the traffic will start flowing through the new primary node. And what happens is the primary node will be torn down. It will be terminated, and then it will be spun back. As you can see, let's say something happened, it can be torn down, and then they will replace it with a new node altogether. It will come online. Now, when you're choosing the right number of instances for your core nodes and task nodes, you need to find out if you're going to be doing a lot of processing, so running tasks, or you're going to be storing a lot of data in HDFS. And if you're going to be storing a lot of data and you're going to be using which storage option are going to, let's say for an example, you're using EMRFS. Are you going to be using HDFS instance store? Are you going to be using EBS volumes for HDFS? Or are you going to be using a combination of instance store in EBS? So the right number of nodes really depend on how much data you have. And if you remember from the last section, the data is replicated across the nodes. So this means that you have files that are very, very large. Then those files are copied across multiple instances as well. So you need to take into account the large files, and you need to make sure that you have enough room on each of these dedicated instances to store those replicated files as well. So you need to make sure you understand the replication factor, and that's what you have to understand specifically for this certification and even for general use cases as well. So obviously this can be adjusted depending on how many nodes you have, but by default within EMR, the number of core nodes, if the number of core nodes 10 plus, then if your replication factor is 3, you have, if you have, let's say 4 to 9 nodes, then the replication factor is going to be 2. And then if you have 1 to 3 core nodes, then it's only going to have a replication factor of 1. And remember that you can override this default replication factors by editing something called as SDFS site.xml file. And you can do this whenever you launch your cluster, or you can do it after your cluster is launched as well. So that's a good tip to remember. So it really depends if you are using EMRFS to store your data, or if you are using SDFS to store our data, or if you're using SDFS, it means you're using instance storage or EBS volumes, or sometimes a combination of both. And we would use HDFS over EMRFS if we have high input output requirement. So HDFS is going to be a bit faster, as I mentioned already, with higher input output rather than EMRFS, because that data is stored onto S3 rather than directly on this Hadoop cluster. So let's look at one example to solidify this understanding. So our example is, we have high input output requirement. So first you tell me, for high input output requirement, which storage should I use? Definitely. So this means that we are going to use HDFS, and we need to store 3 terabytes of data on your HDFS cluster. So whenever we are creating a EMR cluster within the console, we have the option of choosing the master node sizes, the core node sizes, as well as the task node sizes, and also the number of instances that we want to run. I showed you yesterday in the console that you have the option of choosing 10 instances, 2 instances, whatever you want. You can also see that we can choose a purchasing option, so that either on demand or spot. And we are going to talk about spot instances in a later section. But for now, let's just consider using on demand. So if we select the instance type for the core, we can see the various instance type that we can choose from. I gave you the list already, M4, P3, G1, all those things. We have all different kinds of instances we can choose from. And we have all of this for different processing, different machine learning, different types of dense storage. And let's say I chose the i3 extra large, and that is going to have 950 gigabytes of SSD storage. So if I'm going to multiply that by 5, so as you can see, i3 has 950 SSD. And let's say if you multiply that by 5, anybody wants to do the calculation? If not, no problem. I'm going to do that for you. So 950, let's say you chose this i3x large, that is 950 gigabytes, as you can see in this screenshot. And that is, if you are having 5 nodes, it is going to give you 4.75 terabytes of data that we are able to store. And since we chose 5 nodes, that means the replication factor by default is 2. So in order to calculate the SDFS capacity, we have a total of 4.75 terabytes of total storage across the entire cluster. And we have a replication factor of 2. So basically, this means that the SDFS capacity is going to be 2.375 terabytes. And that is not large enough for our 3 terabytes of data. So here it is not able to accommodate the overall replicated data. Data it can accommodate easily, and that's what is the easy part. But you do not have to just take that into account. You have to take the replication factor into account as well. And I gave you this calculation over here. How much would be the replication factor depending on the number of nodes you have. So 10 plus 3, 4 to 9, 2, 1 to 3, factor of 1. Here we have 5. That means it falls in the factor of 2. And basis that, we are doing the calculation over here. And that does not suffice for sure. As you can see here, this means that SDFS capacity is going to be 2.375 terabyte. And that is not large enough for our 3 terabytes of data that we have. So the SDFS capacity is not enough. So it's important to take into consideration the replication factor and how much data you need to store across your nodes. So in order to elevate that issue, let's jump and see what we can do to add more storage to our EMR core cluster. So in order to add more storage to our SDFS cluster, what we can do is, these are our options. We have a couple of options. We can either add more instances. Instead of 5, we can add 10 instances. Here I chose 5. Instead of that, I could have chosen 10 instances. Okay. And so what we can do is, we can add extra EBS volumes to add more room onto our SDFS file systems. And we can also increase the size of the EBS volumes. And we also have the option of just changing the core instance type. Instead of i3, I can choose i5. And i5 will have more than 950, something like that. I'll take that as a yes. So we can just change them to a specific instance type that has more instance storage by default. So more data that comes onto your EC2 instance automatically. So these are our 3 options. We can increase the number of instances, we can add more EBS volumes, or we can change the instance type. These are the 3 options you have. So probably if you're asking this question, would I benefit from a larger cluster size with smaller nodes, or a smaller cluster size with larger nodes? And this is a topic of debate between data scientists everywhere. Nobody has the correct answer. So you have one data scientist that says no large cluster with smaller nodes is going to save you more money. But then you have another set of data scientists that will say no small clusters with larger nodes are going to be your best option for, let's say, processing or saving money. And it is a debate that is going on between data scientists all over. And even I do not know the correct answer, but again, as per my experience and whatever AWS documentation I have read, and I go by whatever AWS documentation says. So this might be basically mean using 500 small nodes, and then this might mean using 250 larger nodes. So what is the best option? Well, AWS suggests using a small cluster of larger nodes, and there are a few reasons behind it, and I like those reasons. That's why I take them for their word. So let's take a look at them now. So this is what they say. So AWS is suggesting this, that you should go with a smaller cluster of larger nodes. And why do they say this? And I agree with this as well, that what basically this allows you to do or gives you flexibility is that it reduces the failure possibilities. If there are less moving parts or less nodes, that definitely means that there are fewer instances of your nodes failing. It also reduces the amount of maintenance as well. Again, same logic, less moving parts means less maintenance in order to ensure that the cluster is working properly. So that is pretty much it for this particular section. And hopefully you learned a little bit more about maybe what you would need to do to choose the right number of core nodes or task nodes for your EMR clusters. And if there is some problem where you can probably take risk and avoid, maybe have some failures as well. So again, it is very, what do you say, problem that you're trying to solve specific thing. But yeah, obviously there are failures. If you have not chosen the correct number of instances, probably you will have downtimes. And again, downtime as well, it depends on a lot of factors, like how much, what do you say, bandwidth of a team you are working with, how quickly they can resolve this, how quickly can they restore all this problem. So if your problem statement can afford that much downtime, you will try to risk all these things, like choosing less number of instances, not going with a higher instance type. But what, again, as per my experience, for example, I worked with American Insurance, and their problem statement was pretty straightforward. We can incur some cost, but we cannot afford any sort of downtimes. And this problem statement I'm talking is when it was COVID time and they wanted us to build all this chatbots for them, which they can handle all these things automatically and things like that. Their requirement was pretty straightforward, that we can incur some cost over here, but we don't want any sort of downtime. So for me, that time, there was no option of taking any risk to save some money at all. But if you're working for any other problem which can allow you to do experimentation risk, you can try other options as well. And that's why I said there are 3 options, but I have worked with 2, depending, because right now we are talking theory. When it comes to production, solving industry-wide problems, what either becomes critical is either saving money or solving the problem at hand as efficiently as possible. And that's why either it's choosing the right number of instance type is the thing, or choosing a bigger instance type is the thing. Yep, that's bang on. And that's what our next topic is about as well. Here is what you save the most money as well, the spot instances. But again, if your use case allows you to do that or not, you have to figure that out on your own. So that's what we are going to talk about in this section, about whether we can use on-demand or spot instances for various scenarios and workload types whenever we are spinning up and using our EMR clusters. Now, this is a pretty cool features that we can take advantage of whenever we spin up our EMR clusters. We can actually run reserved instances. Again, I am assuming here that you guys know about EC2 instance type. So I'm going to just talk about all of them. So here you can actually run reserved instances, on-demand instances, or spot instances. But in this section, we are going to kind of compare and contrast why we might want to use one over the other. So over the last few sections, we talked about transient and long-running clusters. We have talked about different cluster instance types, as well as choosing the right number of instances. And in this particular section, we are going to talk about demand versus spot instances. And again, if you are working in industry, you might have been able to figure out in theory all of these things. Feels okay. I have the either black and white situation. I can save money by choosing this. I can just make it more efficient by choosing this. But that's not how it works when you're solving an industry-wide problem. you have to find that balance. And that's what does this certification testing you for as well. That if you're anybody can be a data engineer, data analytics expert, but whether you are a good one or not depends on if you're able to find that balance or not. And that's what they are testing you. And if you are clearing the certification, that's what tells to your whatever is your output audience, whether your company managers, stakeholders, or whatever. And that's what it is about. So there are different reasons why we might want to use on demand versus spot instances. So let's take a look at some of the scenarios where we might want to use one over another. And so if you're running long running clusters that have predictable variations in compute capacity, basically, you know what the compute capacity needs to be, such as a data warehouse, basically. Now, you might have requirements for a cost-driven structure, meaning that you need to run a transient cluster because lower costs are more important than the time to complete it. So the lower cost is more important than the actual time it takes to complete the EMR jobs. You also have data critical scenarios, meaning that if you lose any part of the data, then that's not acceptable. So you need to make sure that all of the data is persisted on HDFS and protected from sudden terminations. And finally, you might run EMR clusters for application testing. And this means that you're actually testing new applications and preparing them for production environments. So most of your EMR scenarios are going to fall into one of these categories, again, as per my experience. So let's go ahead and take a look at what type of instances we would want to run for each of these scenarios. So whether we want to run an on-demand instance or a spot instance. So now for long-running clusters and data warehouses, we need the data to persist, right? That's the job of data warehouse. You want your data to be persisted there so that you can do some sort of business intelligence on top of this. Now we have a good idea of what the computational capacity is going to be. For example, let's say at the end of every week or the end of every day, all of the data scientists in the company, they submit an EMR job. So we know that at a particular time, let's say 4 p.m., 5 p.m., getting towards the end of the day, whatever time they submit this job, the compute capacity needs to expand to handle all of the jobs. This means that we can add task nodes here to add more computational power to the EMR cluster. So for our task nodes, we could use spot instances in order to save some more money. Or we could set up instance fleet. Now, I haven't touched on what instance fleets are yet, but this is something that gives you the ability to use spot instances if the capacity is available, and then switch to a on-demand capacity if the spot instances are not available at the price that we bid on. So depending on the importance of your workload instance, the fleet might be a better option. We would use the on-demand instances to handle the normal capacity, and then we could use the spot instances to handle our peak load requirements. So I'll give you an example from my own experience. What used to happen was, when I was learning all these things, when I was appearing for my interview and I was doing my postgrad, that time my job was, again, as I mentioned, I was a machine learning engineer at that point of time. And I had to create all these capstone projects which were related to computer vision. And if that time nobody was paying me, I was paying from my own pocket. In that case, I want to solve those computer vision problems, which involves processing a lot of videos, lot of images, and I have to come up with solution that I need to present it to my company, whatever I was interviewing for. In that case, my requirement was not something which industry demands, that, okay, you need to complete it without any fail and this kind of thing. My job was to just complete that somehow, and I had time in my hand. So what I used to do, definitely, I'm an insomniac, so I used to be awake by 2 a.m., 3 a.m., things like that. I used to submit those jobs into spot instances. And what spot instances allowed me is you can just submit this. Let's say I used to bid them for like 50 cents, $1, something like that. And my requirement for GPU. If you have experimented this on your own, if you try to experiment this on your own, a GPU instance costs you around $16 an hour. And that is pretty much, I don't know about your income or whatever your country you're in. For me as a grad, I was just not earning that much. I was learning something and I have not gotten the job, anything. I'm just learning. That time $16 an hour was a bit much. So I was using this spot instances, and that helped me do the job, which was actually $16 an hour. I got that for 50 cents, $1 an hour, something like that. Again, I'm just giving some made up numbers over here. I do not remember the exact numbers over here. So the point that I'm trying to make over here is that you could use spot instances to handle your peak load requirements. Same goes for your Amazon sales and all those things. Whenever you have this Prime Day, Cyber Sale, and all this thing going on in Amazon, what we used to do is we used to have this capacity of a lot of spot instances that, okay, our customers can ask for anything. We do not know if how many customers are going to be asking. It could be 1 billion, it could be more than that. So what we used to do is we used to have all this spot instances readily available as a task nodes, so that if there is any requirement, I can just add on to it so that I can save some money, but still provide that computational power. And that is basically to handle your peak load requirements. In Amazon, we used to call it peak period. October to January was used to be our peak period. So in this case, basically what I'm saying is, let's say that money is a huge factor. We want to save as much money as possible. And obviously in this case, if you have guessed it, you guessed it right, that you could use spot instances for all of your different nodes. Because we are going to be running transient clusters at this point, we are more focused on saving money than the actual time it takes to complete. But just keep in mind that losing partial work was acceptable here. I could lose some work. Spot instances, the nature is that you lose something over here. So let's say that the spot instances price exceeds whatever you have bid. Let's say you have bid $1. That means you're going to lose any data that's on that EMR cluster. So just keep in mind, and this is where data critical scenarios come into play. You also, of course, want lower costs, but losing any partial data is not acceptable at all. We can't lose any data if the instances within the cluster gets terminated. So what we could do on the primary and the core node is run on-demand instances to make sure that any data that is persisted within HDFS, and we could use spot instances for our task nodes to handle any spikes in the workload. And finally, with your application testing, the entire cluster, it can be run on spot instances to save your testing costs. So the most important thing to remember here is that if you want to save money, then use spot instances. If your data is super important or the instances are running the entire time, then make sure you use on-demand instances for your primary and core nodes. And then for your task nodes, you can still use spot instances. Now, it looks like you would always want to use spot instances in the task nodes, right? Well, that's really up to you, and it will help you save the most money in the end as well. And you would mainly want to use this to handle any extra compute capacity or peak hours or anything like that you would need to basically handle any extra workload that comes into your EMR cluster. So that's pretty much it. You can go through this table and ask me any questions that you have on this. Yeah, we have been talking about EMR a lot, and we are almost at the last section of EMR. And this is where it becomes critical about whatever you have seen so far, how EMR architecture works, all this operation happens on EMR, how exactly you monitor this thing, because that becomes important as well. And as I mentioned, you have the option of resizing your cluster as well during this peak loads, not peak loads, and things like that. In this section, we are going to deal with that. So here we'll talk about monitoring and resizing our clusters. Now, over the last few sections, we have talked about transient clusters,
long-running clusters. We talked about choosing an instance type, choosing the right number of instances, as well as using on-demand versus spot instances for various scenarios and types of EMR cluster jobs. And in this section, we'll talk about how do you monitor and resize your EMR clusters and what that entails. And finally, we'll kind of end this section with a summary over everything that we covered in the EMR operations topic so far. Now, again, if you're familiar with the associate level certification, you know that CloudWatch is the go-to place for monitoring your AWS resources. And there are several different CloudWatch events that we can use to monitor your EMR clusters. So if we take a look at what this looks like in the console, we can actually create a CloudWatch event rule. And what we can do is select the EMR as a service, and we can go ahead and select the event type. As you can see here, the event type that I'm choosing is state change. What do you think a state change means? Correct.
System down.
Oh, yeah, that is correct. So we want to know if any of our EMR cluster, the state got changed, whether that's an EMR cluster being spun up, whether that's a job that's being completed or errored out or terminated. We'll go and select the state change option here. Now, if we select a state change, we have the option to select from many different types of state changes. So for example, we can create an auto scaling policy that scales up a cluster during high demands, and that kind of answers your last question as well, that it does have all this auto scaling features that EC2 has as well. You can use that using this CloudWatch events. So maybe for your non-peak times, you can have this small cluster and you can have this event in place. What it will do is it will just gets notified that, okay, there is much more demand, some state change happened, and accordingly, it will trigger this auto scaling policy, and that will scale up your cluster during high demands, and you will get notified as well. Now, if you're adding more, if the EMR cluster or the auto scaling group is adding more EC2 instances, we can also create steps or jobs within our EMR cluster. And if the state changes on those, whether they are completed, whether they are terminated, we can get notification for that as well about all this cluster state changes. So basically it will answer you whether your cluster is up and running, is it terminated, is there some sort of error that happened. So there are many different types of state changes that we can choose from. And I have already given you the link about this in the study guide for this section about CloudWatch events, about the events that we are allowed to set for EMR. Here, I'm just giving this example. Now, let's go ahead and select let's say, step status change. And what we can do is figure out if that job that's being ran is either canceled, pending, canceled, completed, failed, pending, or currently running. And what this does is this gives us a good understanding of what's actually being done on the cluster, the processing that's taking place, and whether the job is completed. That way, we can tell our bosses, okay, we have processed all this massive amounts of big data, and we have an output now, and we can show it to you. So we can go ahead and select, let's say when it completes, and once it completes, the CloudWatch event rule can then trigger another event. And this event might be anything, but let's say it's an SNS topic. As you can see, I'm selecting SQS topic that basically sends an email or sends a text message. We saw in the demo that I showed you yesterday, the step function was either sending me an email or sending me a text message. So about the same thing, you could have a trigger, or you can have a trigger of a Lambda function that, let's say, spin up another cluster that uses the output data from your original EMR cluster. These are many different targets that we can invoke whenever the CloudWatch rule event occurs. Okay, so here we know that
we can create CloudWatch events in order to trigger on a certain state changes or certain steps within our EMR cluster. So let's go ahead and take a look at some of the important metrics that we might want to follow in order to scale up your cluster, or if there is a need to add more instances or needing to scale down your cluster. So if you want to track the cluster progress, we can use this metrics listed here in this orange section. And what this will help us to do is determine the number of map and reduce tasks that are currently running on the cluster, as well as the number of map and reduce tasks that are remaining for a particular job. We could also track CloudWatch metric that help us determine if one of our clusters is idle, it is not doing anything. That means it is live, it is costing you money, but it is not running any task. So monitoring helps you that way. If you are monitoring this closely, you can save some more money here, make efficient use of your resources. So this basically means that we are being charged in the EMR cluster only for something it is doing, and if it is not even doing any work. Another important CloudWatch metric is that you can use more storage for HDFS. What we can do is monitor the HDFS utilization metric, and this is the percentage of disk space that is currently being used. What we can do is trigger an event that fires once a high percentage of capacity you use, let's say 80% of the capacity used. We will fire a trigger that basically says or sends you an email, something like that, says, hey, you are running out of space in HDFS. You need to add more instances, you need to add more EBS volumes, you need to do something to make sure you have enough room for all of your HDFS data as well as replication. So this is very important. As I mentioned, all of these things, more or less, you have to do it manually, but you can use this CloudWatch metrics to lessen that workload. It will send you that email so that you know what to do next. You can go ahead and increase that HDFS utilization because of this metric that they already provides you, which is very convenient for.
Let's have a quick quiz question, guys. And the question is, what is the primary purpose of an in-memory data store in AWS? Option A, to store data permanently for long-term archival. Option B, to process and analyze data in real time. Option C, to create virtual private networks. And option D, to store backups of virtual machines. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data Certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
A managed service you are using. So this is just some of the important ones which I felt are important for you to know. And these are going to be super important to understand once we are talking about auto scaling. And not only we can monitor clusters with CloudWatch metrics, but we can monitor clusters with an actual user interface as well. So if you go into EMR documentation, you can see all of these links for this various UI components that come installed already. You don't have to do anything. You just go to your EMR cluster and that gives you all these links. So what happens is Hadoop and other applications that we have installed on our EMR cluster, it also publishes that user interfaces as website that are hosted on the primary node. So a lot of this stuff that we can do using the command line by basically you can SSH into this primary node. We can also do through using this user interfaces, and they are a bit easier to work with. So if you want to enable this user interfaces, what you need to do is use something called as SSH tunneling with port forwarding with SOX proxy setting. And again, I'll make sure I have already given you this link. I think I have already given you. If not, I can give you this link again, which talks about this. Just check the study guide, which I have given. I think I have provided this already. And what it does is it gives us a better understanding on how to set this up on your EMR cluster. In your EMR cluster, and let's say you want to resize your core node or add some task nodes. What you have to do is just click on this hardware and you can see all the nodes that you're running on this cluster. And if you want to resize the core nodes, all you have to do is you can just resize and then select the number of nodes that you want to run. And then if you want to add some more task nodes, you can just add more task nodes here itself in this screen. Select the instance types, we can select the number of instances, we can go ahead and add those. And since we resize the core node, for example, it's as simple as that. I can change it from 2 to 5 and it will just add 5 instances. And over here, as you can see, it will give you this message which is saying resizing, and it will take some time because again, it needs time to spin up. So it will show you this message called resizing. And here we requested 5 and you can see it's provisioning. Excuse me. So it is provisioning all of the task nodes. And so this is obviously going to take some time. And after a while, you can see here that all of your nodes are running within the number of nodes that we have requested. As you can see over here, all of them are in running state now. So 5 and 5. So now we can also decrease the size of our task nodes. And if you want to select resize, we can go from 5 to 2 as well, or 5 to 3 or whatever. And then it is going to just give you a little pop-up that says you are shrinking your task group from 5 to 2. Then EMR is going to be smart about it, and it only terminates the instances that do not have any MapReduce jobs that are currently running. And if we decide to go ahead and decrease the number of instances running on a core node, we get this little warning, and EMR basically is saying that, oh, we are going to do something happening in this nodes that are marked for removal. Are you sure you want to remove that? So they are going to, even before that, they are going to replicate that data across the other core nodes. So that is how we would resize our clusters manually. Now, the thing that you need to remember is that you cannot have less core nodes than the replication factor. And that's an important bit to understand. And that I'm trying to explain with the example over here. So thing to understand here is that you cannot have less core nodes than the replication factor. Now you tell me what is the replication factor, how that can be changed. First, you answer me that, then I'll tell something. So we already talked about replication factor. So over here, the thing to know is we cannot resize less than the replication factor. So first, we would need to change the replication factor, and how that is done is I already told you by hdfs site.xml file, and then you have to restart the name node daemon. Then we could change the number of core nodes manually. So this is everything that we have to talk about manually. So far, whatever we talked about, it was for manual things. Now, as I mentioned, it is a second level service. It has a lot of components from EC2, and EC2 supports auto scaling. Same goes with EMR as well. So let's go ahead and talk about resizing our clusters using auto scaling. So with EMR managed scaling, what you can do is you can automatically increase and decrease the number of instances in your core and task nodes basis the workload. What you can do is set a minimum and maximum limit for the number of instances. Basically set a minimum and maximum limit for the number of instances in your cluster nodes. So master nodes don't scale though. What you can do is create a custom auto scaling policy, and what that looks like is something like this. So whenever we are creating our EMR cluster within the console, we can select cluster scaling, and then we can either use a EMR managed scaling, or we can create a custom auto scaling policy. So we have two options. And if we select EMR managed scaling, what we have to do is set the minimum, the maximum, the on-demand limit, and the maximum core nodes that we want. And this will automatically either decrease
and increase the number of instances depending on whatever workload you have. So that is the EMR managed auto scaling. Now for your custom auto scaling policy, it looks a little bit something like this. We would basically select the minimum instances and the maximum instances, and then what we actually want to scale out and scale back in depending on the metrics within your CloudWatch. So those metrics that we talked about a few slides before. So if we dive a little bit deeper, what we can do is set the minimum and maximum instances for our core nodes and task nodes. We can then set this scale out policy and scale in policy. That is completely customizable to any of the CloudWatch metrics that you want to follow, whether it has to do with your memory utilization, CPU utilization, or it has to do with the amount of space that's left in HDFS. And finally, you can set a scale in policy as well. So what needs to happen if a certain threshold goes below or above a certain point, you can, get rid of some of the core and task nodes to save some money. So let's say we wanted to add a brand new rule for a scale out policy. And that rule would look something like this. What we would need to do is set the minimum and maximum number of instances that need to be spun up or needs to have a certain capacity when this scale out rule is hit. What we do is give it a rule name. We would say, okay, we want to add this many number of EC2 instances. We can then set the CloudWatch metrics that we want this rule to be triggered on. And what we would do is give it some comparison operator like this. Where is it? Yeah, like this. So we would give it some comparison operator greater than or equal to or less than or equal to a particular value. And as long as that value is met for an evaluation period for a specific amount of time, then this rule is going to get triggered. And we can also have something called as cool down period. And cool down period just determines the amount of time that must elapse between a scaling activity. So for an example, if something is already happening, it is already the load capacity is 70%. You have set the rule that whenever it goes below 80, reduce instances. And you have set cooldown period as 60 seconds. What this basically going to do is, no matter if in that 60 seconds, if the load is already 90%, even in that case, it is going to wait for 60 seconds because you have set the value for cooldown period. What I'm saying is, let me try to annotate it. So your rule is, whenever let's say, again, it could be any CloudWatch metrics, but let's say here it is my CPU utilization. Okay, so I have set a rule, CloudWatch rule, that whenever my CPU utilization goes less than 80%, remove one instance. Okay, and your cooldown period, I'm just calling it CDP, is 60 seconds. Now what happened is, the capacity right now is 70. Okay, what it is going to do? What will it do?
So if you set a cooldown period of 60 seconds, it will still wait for the 60 seconds before reducing it.
So don't just go to cooldown period. I'm going to explain that. Just tell me right now the capacity is at 70%. What ideally is supposed to happen as per the rule?
It has to take out on CPU, right?
Correct. Now, in this 60 seconds, right now, I have waited for, let's say, 45 seconds. And all of a sudden, my capacity is 90%. So that's what a cooldown period is. So if in 60 seconds, something like this happens, it is not going to make the actions of adding one more instance, because your rule is either reduce one instance when it is less than 80 or add one more instance when it is more than 80. So what it is going to do, it is going to wait for, it will remove one instance, then it will wait for 60 seconds.
Now for 60 seconds, it is not going to perform any operation, no matter it is 80%, 90%, 70%, whatever. It is going to wait for 60 seconds, as you have set that as your cooldown period. Then after 60 seconds, it is going to check this again. Okay, is it 70 now? If it is 70, it will keep that one removed instances. But if it is 90 now, it is going to add one more instance again. Let me tell you why we provide this. So we provide this cooldown period basically to allow a cluster to kind of make sure that your cluster is available and it is also stable at that point of time before even checking for something rude. Otherwise, this cooldown period, if you are not providing, if it is 0, what will happen? 1 second it is 70%, it will remove one instance. Next second, the requirement came 90%, and that can happen in real world scenarios. It has to add one more instance. We do not want that. We want a cluster to be stable as well, at least for a few seconds, to either add something or delete something from it, right? Files. So Hadoop split each of the files into multiple chunks. So let's say we have a large file and it splits into different chunks of smaller sizes. After splitting the files, a single map task processes each part. So if you are using Hadoop as the underlying data storage, the HDFS framework has already separated the data files into multiple blocks. And since the data is already fragmented, then Hadoop uses HDFS data blocks to assign a single map task to each of these HDFS blocks. So whenever we are using Hadoop on our EMR cluster, Hadoop either splits the files or stores the files in HDFS, or we can have the files stored in S3 as well. And if it is stored in HDFS, then the files are split into chunks automatically. And if they are stored into S3, then the files are split into multiple HTTP range requests. So whether we are using HDFS or S3, the compression algorithm that we need to have a splitting available, so that's very important when it comes to choosing a compression algorithm. So in this example, we have a large file that we are using some compression algorithm on, and it doesn't allow for splitting. So that means that a single map task is going to be mapped to that file. But if it does allow for splitting, then that means that we can have multiple HTTP range requests when moving the data from S3 onto our EMR cluster. So if the compression algorithm that we are using allows for the files to be split, then EMR is going to process the chunks in parallel. So this is important. So you might be asking which compression algorithm are actually splittable. Well, there's a nice little table which I have put down here for you for a good understanding of which algorithms are splittable versus those that are not splittable. It also lays out the compression ratio and how fast it can decompress those files. So for an example, if you are trying to save space on our HDFS cluster, in that case, what can happen is we can use something called as gzip or the bzip compression algorithm. And if we're trying to save time, then we might use the LZO and snappy algorithms. And I have put down here in terms of splittability, which ones are good. So bzip and LZO, they are good for splittability. And if you're trying to save time, then we might want to use the LZO and snappy algorithm. And it's important to recognize which algorithms are splittable. So these are going to be the best algorithms to use if you want to map multiple map request tasks to a single file, because these files can split up when they are moving from S3 onto our EMR cluster. So now you might be asking the question, why is the compression so important for our files? Well, if I have to give you an example, let's say somebody who is a huge packing and hiking nerd. And this is all the gear that you will use whenever you decide to take it out for the woods for a few days and just relax by a river or by a top of mountain. And the compression is important in this case, or in this sense, because I have to get all of this gear into this bag right here. And you might think, can all of this gear even fit into this bag? The answer is yes, it can. And you can see that this person right here is sitting on a mountain where he is backpacking. Here's the bag where everything is compressed down and made smaller into a single large bag. So when we have lots and lots of data that's stored in S3, compression is going to be important. So let's go ahead and talk about the 3 benefits of file compression. Well, first of all, it gives us better performance basically. This means that the less data is transferred between S3, the mappers, the reducers. It also gives us less network traffic, meaning that since you are transferring less data and you have less network traffic between S3 and EMR, and finally, it's going to reduce storage cost as well. So the smaller compressed files means less storage. So you end up paying less for your data storage. Now, EMR accepts a lot of data file formats. So let's go ahead and dive in and talk about the different file formats that we can use within EMR. So we can, of course, use text files. This can be your CSV files or a tab separated files or JSON files. And these are commonly used really everywhere. In the previous sections, we have talked about Parquet or ORC as well. And Parquet is basically going to be the column-oriented file format. And this is commonly used in Hadoop ecosystem in Hive, HBase, MapReduce, Pig, and even in Spark. And it is one of my favorite formats as well. There are others as well, like ORC and Avro as well. But I prefer Parquet for, again, personal biases. This is a file format created by Apache specifically for the Hadoop ecosystem. We can also use ORC file format, and this is optimized row column file format. And this is a highly efficient way to store Hive data. EMR also accepts sequence files, and these are flat files that can consist of binary key value pairs. And the last file format is Avro. Avro is a row-oriented data serialization framework that's also created by the Apache Hadoop project. Again, if you do not know this, this is expected out of you. But so far, just know that these are the highly, efficient formats that you can use with your EMR cluster. So what happens is it uses JSON for defining the different file data types and protocols, and it serializes the data into a compact binary format. So understanding the file formats that we can use as well as the compression algorithm will give us a better understanding of how large our files need to be. So they need to be just a couple of megabytes or a couple of 100 megabytes, or they need to be gigabytes or even terabytes in size. So according to AWS and EMR best practices, we can look at the algorithms that we are using, whether they are splittable or not, and then determine the file sizes. So if the compression type does not allow for splitting, then Hadoop is going to assign a single mapper to process our data. So what basically that means is that a single thread is responsible for fetching that data from S3. And since a single thread is limited to how much data it can pull from S3 at any given time, this is the throughput, right? So the process of reading the entire file from S3 into a mapper becomes a bottleneck for our data. So the best practice is to have a file size of 1 to 2 gigabytes for algorithms that does not allow splitting. Now, if splitting is available for a compression algorithm, then we can have file sizes from 2 to 4 gigabytes. and these are going to be your best practices. Now it is important to note that we need to avoid smaller file sizes. So 100 megabytes or less. We need to kind of plan here for fewer larger files. So typically you want your file sizes to map to your block size that you have set within your Hadoop and EMR. Now, since those files are going to be fed into a mapper, sorry. Now, since those files are going to be fed into your mapper, your block size has a fixed cost, and you want to utilize that over large volumes of data to maximize your overall throughput of your cluster. So remember, block sizes and file size needs to be kind of about same. So if you have a smaller file, what options do you have in that case? Well, your first option is that you can reduce your SDFS block size. So you can set it to 1 megabyte. The default is to 128 megabyte. Other option is to use the S3 discp command. What it does, it's a very helpful command. It combines smaller files together so that you can take a lot of smaller files, which are, let's say, 1 MB, 1 MB, 1 MB. There are 128 files of that size. You can combine them into a single large file. So let's dive in and talk about the S3 discp command. So the S3 discp command is again just an extension of discp command. You should know discp command, and if not, I have given you the links in the study guide. What it is that it is optimized to work with AWS and particularly S3. So this CP, it is created by Apache framework, while the S3 discp command, it is created by AWS. And as I mentioned earlier, it's just an extension of this discp command that has been optimized for your EMR and S3 workloads. So what it does, it allows you to copy files within a cluster, or from one cluster to another, or from S3 onto your SDFS cluster. It also allows you to combine smaller files into larger files. So we can help you to copy data between S3 buckets, or S3 to SDFS, or SDFS to S3, kind of vice versa. And the way that you can run S3 discp is either by using a step within your EMR cluster, or you can run it into your primary node. And we are going to give you a demo of this as well. So probably next time when we are meeting, then it will solidify your understanding. But for now, just understand S3 discp command is an extension of a discp command. It allows you to combine smaller files into a larger file. And you can run this as a step command, which is a transient cluster, or on your primary node for a long running cluster as well. Now, this command and tool, it comes up all over the examination. So just make sure that you understand its purposes and where it can be used. And yeah, that's the end of this section, everyone. And let's go ahead and jump into the summary. So we started off by talking about how Hadoop split files. We found that the files are split into smaller chunks, and a map task processes each chunk. We then talked about different compression algorithms, so gzip, bzip2, LZO, Snappy. We talked about why compressing our files is important for better performance, of course, for less network traffic, as well as reduced storage costs. We then talked about the different file formats that EMR takes, which is text, Parquet, ORC, sequence files, Avro. We then talked about the various sizes that our files need to be for best practices. So it really depends on your compression algorithm and your time constraints. We then talked about the S3 discp command, which is essentially a tool used for copying files and combining smaller files into fewer larger files. So that's the end of this particular section, everyone. Hope you learned a little bit more about file compressions, different file sizes, and also the S3 discp command. And yeah, unless you have any questions, we are going to continue talking about EMR, and that's the end of EMR as well. After this, we'll move on to our checkpoint, and we'll talk about some facts and questions about EMR, as well as diagnose and exam simulated question. See the AWS blocks. And again, personally, I'm saying a lot of my career is driven by the AWS blocks. Whatever blocks I see on AWS, I try to recreate it on my own or just go through the blog, whatever I can. Most of the times, even I'm not able to follow everything along because either it is too expensive or it is too much work. Probably it's above my pay grade. I'm not understanding everything. But even if you go through these blogs, you'll get a lot of understanding. And here you can see some of the use cases and the overall architecture diagram as well, where exactly you can use EMR. So to give you an example, this one is an example, which one I followed, not this one. This is Apache Hoodie. Yeah. So EMR as a serverless step function. So over here, you are a developer, you have all these logs coming in. Those are ingested via your Lambda function that goes to your Kinesis data firehouse, and you save that everything into Glue. Finally, you persist the Parquet file that you are getting from Kinesis data firehouse to what we have already seen. The same example that we have seen, we were sending our data to Kinesis Kinesis data stream. From there, we were sending it to Kinesis data firehouse, and from there, we were putting into S3 bucket. But before that, they are putting into EMR. And what they are doing is they have some logic for aggregating this logs and doing something with this log using EMR. It will give you an overflow. And even if you want, they give you a code itself, which you can try it out. So for an example, if you see, first it's all theory about it, but somewhere they might have given you the code as well. Yeah, like this, clone this GitHub repository. So they take you running a data processing job on EMR serverless with AWS step function. The step functions I talked about in the demo, and another new thing, which is using Terraform, which we have not talked about, and it is out of scope as well. But this one has the entire code, how to do everything. It gives you the overall flow as well as the architecture. Congratulations, everyone, for making it to the checkpoint in your EMR or Elastic MapReduce section. We'll go over some important FAQs that I think you will need to know for appearing in this examination. We'll also go through a simulated exam question as well to figure out what the requirements are and which answers we can use to solve those requirements. So let's get started. So a big question that a lot of people ask, and at the beginning of the section, I talked about how expensive EMR was. Well, I think I have told you already. If you, again, somebody asked me this question, whether I should go for EMR, whether I should go for Glue, or whether I should go for Lambda. The choice or the answer boils down to the cost. More or less, it is, again, as per my experience, mostly like 70% of the time for your company or for your even own self, the choice boils down to the cost itself. You will choose something that is probably less expensive. And EMR, I think I have told you that EMR is expensive. Well, how much the EMR costs then? So EMR is expensive for sure. And here you pay for the EC2 instances that are running in the cluster. And you're also going to pay for the S3 usage as well. So you have the option of using dedicated, reserved, and spot instances to save some money on EMR. I have not covered reserved instances, but I have told you that even choosing reserved instances is an option. I do not find them personally. Again, this training, obviously, you're getting trained from me. So there are a lot of personal biases here. My personal biases is never to go with, or not never, never is a strong term, but probably not to go with reserved instances for EMR. And that's why I've not taught you about those as well. But that is an option as well. And the pricing for EC2 and the S3 are built separately. I've already given you the training on how do you calculate pricing for EC2, what you are charged for S3, what you are charged for, whether you are using storage class, which is intelligent tiering,
or Glacier or retrieval cost or all those things I have already told you. So those cost applies here as well. So if you're using S3 to store your data, so basically, firstly, as I mentioned, your price for EC2 and S3, those are billed separately. You're going to be charged per second consumption of each instance type with a minimum of 1 minute charge. So if you're using S3 to store your data, there are 4 components that you need to remember, and it's the storage pricing, the requests that you're making, and the data retrieval pricing. You'll also pay for the data transfer as well as the data management if you're using something like intelligent tiering. All of those features that come with S3, you're going to pay for all of those. So make sure you check out the instance type pricing listing as well as the cost to store data in S3. I've already given you the link in the study guide pointing you to the documentation regarding the cost of both of those services. The next question is, what security measures can I use for the communication between EMR and S3? How do we know that the communication between these two services is secure? Well, EMR always uses HTTPS to send data between S3 and EC2. And you can also encrypt the input data before uploading into S3 and decrypt it whenever EMR fetches the data from S3. So these are some security measurements that you can have in place to make sure your data is secure. So the next question is, well, how can I prevent unwanted users from viewing the data on EMR during a job's execution? Well, whenever you spin up your EMR cluster, there are 2 security groups that are set up, one for the primary node and one for the secondary nodes, which is your core node and the task nodes. And this security group by default only allow communication to each other. So there is no outside traffic allowed by default unless you allow it by yourself. So for example, if you want to SSH into the primary node, you would have to open up the right security group settings to allow that access in via SSH. What you can do is reconfigure them to allow the access in that you need a particular job or a particular set of users. You can do all those, but by default, it is secure so that it can talk to only each other. Now, the next question is, well, how can we configure custom settings on our Hadoop cluster, things like Hive settings, EMRFS settings, as well as the application variables, environment variables, service ports, any installed artifacts, or where your logs files are located, or where the artifacts for the log files are stored. How you can configure those? Well, what you can do is have predefined bootstrap actions to configure your cluster whenever it starts up. So if you remember, we did this demo about Kinesis data stream, and I provided you with a CloudFormation template. And that CloudFormation template by default creates a EC2 instance that has this bootstrap action to send data to your Kinesis data stream. So something similar you can provide or use with your EMR cluster as well. So whenever it starts up, those configuration will be made, and you can apply this in the console to CLI or via SDKs, either by shorthand syntax or by a configuration object in a JSON file. So there are a couple of different ways to customize your Hadoop settings. Again, more information about this I have given to you in the study guide, which I showed you already, which will tell you how do you customize your Hadoop setup and configuration. Make sure you check it out. So whenever we use EMR, we need to use core nodes over task nodes and vice versa. So when should we use core nodes versus when should we use task nodes? For this, again, I have already taught you this, but to summarize it, remember that core nodes, they persist data in HDFS. That means this is where the underlying data in HDFS is going to live, and they have a reserve capacity that is required until the job completes, and the task nodes can be added or removed on the fly. and they do not contain any HDFS. So these are ideally used on a temporary basis. So just when you need to beef up your processing power, basically, you need task nodes. All right. So those are some important FAQs about EMR as per me. So let's go ahead and jump into a simulated exam question. So now what I'm going to do, you are kind of already aware about the process. I'm going to present you with the exam question. We will read through it. We'll go through each of the requirements and then we'll take a look at the answers. Okay. So as I read this question, I start to notice some important features that we need to highlight, like the ingestion of streaming data from devices. So it needs to be stored in the data lake and it will be used by the EMR cluster. Also, know that the biologists in a company are going to need to run business intelligence analytics on them. Now, there is a requirement that we need to compress the data, and that's important. And we need to efficiently collect the data. So I'll go ahead and read the answers, and then you can diagnose what the correct answer is. So the the answer A is to create a Kinesis data stream. Actually, can you read this as well? Or if somebody has answered, you can start posting in the Q&A. As I read even about this, I can write off the bat that the S3 discp command is more efficient than your discp command. So maybe answer A is a way for us to accomplish this, but it is not the most efficient way. And as I read the answer B, MKS may not be the best option for this specific scenario. And if we have all we have is a single Lambda function polling for topics, then we might have some bottleneck into EMR. So let's go ahead and mark that one out as well. Now, the last two just differ by the Kinesis producer library and the Kinesis client library. And also the Kinesis client library is installed on an EC2 instance. And again, I see a bottleneck here as well. So I'll go ahead and mark this one out as well. So here the answer C is the correct answer. What we would do is have the KPL installed onto the devices, have it put into your Kinesis data stream, load it into a Kinesis data firehose, and deliver to S3. And finally, we can compress the data by using the S3 discp command to move the data into EMR. So that's the correct answer. And let's see who got this right. I feel very few people. Actually, only one person. What did you say, Jayabharti?
C only.
C only. Okay, then two people. So Dibendu and Jayabharti. So that's the correct one. And I hope you understood, people, whoever marked D or something else, why that is an incorrect one. If not, feel free to go ahead and ask me questions on that. These are the kind of questions you can expect in your certification as well. So my job here is to familiarize you with those kind of situations, so you don't find it offbeat that, oh, this is the question, Harsh never taught me about this. So these are the kind of questions you can expect. Again, I am trying to cover as much as possible, but as I keep mentioning, there is some reading required from you. For an example, if I have to teach you about DisCP, that is half an hour to 1 hour lecture in itself. But that is not the job. Here, you have already been introduced about the expectation. They already expect you to know this. If you do not know it, it's not their fault. Ideally, you should know this because this is a specialty certification. Once you clear this certification, you are validating that you are a good data engineer or a good data expert. So all these things you need to ideally know. If you do not know, that's not a problem. Obviously, nobody can know everything. Actually,
Even after I cleared the examination, my luck or whatever, my preparation went right. When I started teaching this, I actually learned at least 5 to 10 more things about it. So obviously, there is nothing that you can learn everything before appearing for this certification. All that is required from you is you give your best. You try to cover whatever is being taught. Again, as I mentioned, this course I've literally created in such a way that I would wanted somebody to give it to me. If this was given it to me, I would have probably spent few more hours preparing for this certification. So it was created with that intent. If you even don't have this, I mentioned again, everybody, whatever we are covering from my slides, I'm pretty sure even whatever, how much audience we have, let's say 20 odd people, I'm sure 80% will clear this certification with only this much information. But again, I want to be thorough. I would like all of you to clear this certification. And that's why I've given you that exam guide. If you cover that exam guide as well, I am damn sure you're going to clear this certification for sure. But I just want that little bit of work from you. I would really love you already, even though I was not supposed to share my email ID and all. But yesterday I was doing a demo. There I showed you the verified email. And in that verified email, you saw my email address. So I would like to hear from you once you have cleared this certification that, okay, you were able to clear this certification. I would be so happy to hear that. So yeah, that's the intent of creating this simulated exam question as well. So over here, we are going to be talking about using Redshift. And Redshift in our steps for success, if you remember, it is going to be the first service in our data analysis section. And this is probably the first place where we can perform some large scale data analysis and start to produce some output for the data interpretation step. So what is Redshift? Redshift is a data warehousing service. It can warehouse data at petabyte scale, which means that we can store a huge amount of data in Redshift in a way that it is still queryable. And that is a big thing. You can save a huge amount of data in S3 as well, but it should be in a way that it is still queryable. S3 allows you to query it using Athena, but how much data you can actually query, that is kind of a question. So in a Redshift, your data is stored in such a way that it is still queryable. And that's really the power of Redshift. And it's not just that it can store petabytes of data, it can index and query that data as well, which Redshift cannot, which S3 cannot do. So that data remains usable. So we can store petabytes and exabytes of data in S3, but we would have limited ability to actually do any data analysis on it. It's just a data lake. You just dump your data into S3. Whether that data is actually able to be queried or not, that's questionable. But in Redshift, that is not the case. So that's when we talk about what we use a data warehouse for. So we are going to collect, catalog, and query data. So if we look at the Redshift here, and we have an application architecture, we'll talk about what all of these services are later in the section. All of these services are going to basically emit data. So just the simple example, we have already collecting what could be a huge amount of data depending on how heavily used our application is. And we can collect all of the data artifacts that come off of all the services in Redshift and perform analysis on our application. We can perform analysis on the operation, the performance, the general usage, everything about our application we can collect in Redshift. And then we would be able to write queries to perform analysis of that data. So Redshift is one of the core services for this examination or certification. So we are going to be spending quite a bit of time with it. So this section is mostly theoretical, but do not worry, we'll get hands-on with the Redshift a little later on. So yeah, let's quickly get started with the Redshift architecture. So here we are going to talk about what a Redshift cluster is, what a node is, what a slice is. We'll take a look at the Redshift query process and how that works in the Redshift architecture. And then we'll quickly summarize what we have talked about in this section. When we look at the Redshift cluster, we can see all of the elements here, and basically those elements are shown in this diagram. Within this cluster, we are going to have nodes, just like you had nodes in EMR, you are going to have nodes in Redshift as well, which are either going to be a leader node, which there is a single node, or a worker node. The leader node manages the schema, it manages the data warehouse metadata, and it will perform all the query planning and query script generation. So the worker node are going to actually perform query execution and slice management, as well as storing all of the data within the slices, which we'll talk about here in a minute. So this probably should look pretty similar to EMR architecture as well, apart from the fact that here we have new introduction of slices. So when we look at a node, these are the individual compute resources that have storage attached for our Redshift cluster. So these are again EC2 instances for the most part. There are 3 types to choose from, and those types do become important on your data analytics examination. So first, we'll see those. So first one is dense compute. So unlike EMR, you don't have all those options like P2, G1, IA kind of instances. Here, you are restricted to some instance types, and they have categorize those into this types that we are going to talk about. So far, you see 2 in front of your screen, but I'm going to show you one more, which is kind of a wildcard entry. So first we have dense compute, which is, as the name suggests, geared towards having more compute and memory than storage attached. So the storage attached to this nodes is also going to be faster. So these are generally used in use cases where we need to perform queries very quickly. We want near real-time analytics. In that case, you will use dense compute. So we also have the dense storage node types. These are going to have slower storage, but quite a bit more. So the total capacity in these tables is the total capacity that is capable for a cluster. So if we have 128 DS2X large nodes in our cluster, we will have 2 petabytes of storage. This is how we get the petabyte scale data warehouse with Redshift. Anything larger than 2 petabytes, and we are going to need to stand up a second cluster and manage that in our application layer. But that's probably pretty unlikely. 2 petabytes is a huge amount of data. So finally, we have this new wildcard nodes that I talked about. They are called as RA3 node. And this is at the time when I took all this information and put it down into slides, they are going to have the same amount of storage associated with both types. So the storage on this is backed by S3 and uses a local storage cache to provide hot data for our queries. So basically, what this one AWS has tried to do is, this one, as I mentioned, are for compute. This one, they are for storage. But some people might have applications which require compute as well as storage. And in those cases, RA3 are the best suited because they uses S3 and they uses local storage in order to provide cache to provide hot data for our queries. So this storage is also going to auto scale with your usage. So we get a total capacity of 4 to 8,000 terabytes for this node types, with the maximum nodes per cluster for each node type. These are really cool, and they kind of split the difference between the dense compute and the dense storage. So here we get the faster compute and more storage than what is available for dense compute. We can experience a little latency with our queries here if the storage cache on these nodes themselves do not have the data. But that is, again, that is acceptable. It is working on cache, as I mentioned. So unless somebody has made that query for the first time, that cache is not going to be available. So it has to be retrieved from S3, but generally they are going to perform faster than your dense storage while having more storage available than the dense compute. So they kind of are a trade-off between both. They work with both the good scenarios. So after this, let's take a look at what slices are, which are different from your EMR. So slice, what is slice? Well, a slice is going to divide the compute and memory and storage of a node into separate pieces. And so if you recall from our table in the node breakdown, there is default slices per node type. So the smaller typically are going to come with 2 slices by default, and this can be adjusted. Each slice has its own compute, memory, and storage associated with it, and we are going to manage this through data distribution. That is where, and we'll talk about this quite a little bit more, but later. The important thing to remember here is that each slice, it's its own separate piece of compute, memory, and storage. So if you have to think about it as the name suggests. Everything is in the name. Slice. You have an entire computer. This slice is what? Nothing but one slice of that computer. It will have the compute of that computer. It will have memory of that computer. It will have the storage of that computer as well. So that is slice. So this slice are going to receive a query script from your leader node. They will execute that script and they will return the results. That's what slices do. So managing slices is a lot of what we'll need to do when we are designing a Redshift cluster. So when we take a look at the Redshift query process, we have a query cluster that's going to have one leader node and several worker nodes. You have a single node cluster. So the leader and the worker will be in the same node. So it will just separate the leader off into a slice. And what will happen is we'll have a user that sends a query to the leader node. The leader node, it will generate a query plan. Then it generates execution scripts to complete that query because it knows where all of the data is stored in the cluster. The slice themselves, they do not actually store any table data. They just have data and they know where that data is. So those execution scripts are going to go to our worker nodes. The worker nodes will go to their slices, and then they will each have a piece of data that they need to return, which will come back, and the leader node will combine that data into a query response, and that query response will go back to our end users. So if you can see here, or if you have observed, it's much similar to how the entire distributed computing or HDFS works or MapReduce works. But instead of that, they have kind of introduced this new concept of their own, which is slices. So here, the leader node is responsible to generate the plan. The leader node generates what to execute. Then it sends the code that your worker nodes needs to execute, and that worker nodes, they do their own part in their own slices. They give the results back to the leader node, and the leader node will combine that data into query response, and that query response will go back to your end users. So that is the Redshift query process at a very high level. So as you can see, we have generated the SQL statement, and that we ran that SQL statement as well, ensuring that our table has been created. Now, open another query editor or just use this one itself. Table AWS service logs dot CS optimize 2. What do you think this one will do? Now we'll do select count all as row count from AWS service log dot this. As you can see, it clearly returned my results that I have around 2 lakh logs for this. So let's try a few more queries. Let's see the data. What is the data exactly about? So this is my data. As you can see, this is how you get a log from CloudFront. It tells me that this is my CloudFront who requested that, what was the request type, what was the status of that request, where it came from. Like this was from a Mozilla Fire browser. I'm using that. So all those details. Now let's just run few more queries and we'll call it enough. Okay, so now it is able to order that as well. And finally, we'll run one more query to see how many bytes of data came to my CloudFront. Sum of bytes as total bytes from okay. So as you can see, it's just 1 byte of data which I simulated for this particular demo. So that's all for this particular demo. Basically, that's all. Athena, few things that you need to know in terms of theory. Yep. So we'll start talking about Glue data catalog, and this is what we are going to cover. What is Glue? What are the Glue use cases? What are the various Glue components? And finally, what is Glue data catalog? So these are the things that we are going to cover in the first part of this Glue section. Okay, so let's break this definition down. So basically, it says what is Glue. So Glue stands for serverless ETL service. So serverless, as we have been discussing, what does serverless means is there are no servers that you need to provision. Obviously, there are servers, but you don't have to worry about provisioning those servers. AWS at the backend takes care of all of it. And finally, it's a fully managed service as well, which means there's nothing required from your end in terms of updating it, managing it, patching it, things like that. Finally, ETL, if I think you guys know better about ETL than me. So it stands for extract, transform, load. So what do we do here? We categorize, clean, and enrich your data and move it from various data stores. For an example, you might have use case to take it from your on-premise databases to Redshift, let's say, and you can use Glue in between to do some transformation to that. So there are some use cases to Glue. Can you please read this? I know it is like very light to read, but yeah. So first one is about querying data from S3. So just now in the demo we saw, let's say you have a massive data lake in S3 which contains your customer feedback data. What you can do is, right now we saw that you use Athena to basically query that data. But at the back end, what happens is this. Let me show you this diagram. Yep. So when we query data in S3. So this was my last demo. What we did, we had Amazon CloudFront. All of our CloudFront logs were saved in our S3 bucket. We used Glue there. I used Glue there to optimize my CloudFront access logs to save it in a certain way, because this one, the raw data that we get as logs, it is not that human readable. So I made some transformation using Glue. And finally, I was able to query the data using Athena. So what happens is Athena at the backend by default uses Glue. First example that we saw, that Glue allows you to query data in S3. Now the second thing or the use case of Glue could be in order to join data for a data warehouse. So for an example, same example, you have some data, clickstream data in RDS and some customer data in S3. What you can use is you can use Glue in order to join and enrich your data by combining this two or by joining this two. And finally, all this process results will go and be saved into Redshift. And finally, you can use Redshift Spectrum to query your data, or you can use QuickSight to visualize your data as well. The last use case of is just to keep a centralized data catalog, that no matter what we are using, S3, Glue, or sorry, Redshift or whatever, you just want to keep a metadata of everything, whatever tables you have. So you can use Glue for that as well. What are the components of Glue? The first one is Glue Crawler. What happens over here is you can have data in S3, DynamoDB, RDS, Redshift, or even a database on EC2. You create a crawler. Crawler, as the name suggests, it goes and crawls your data. For an example, this is your S3 database, S3 data lake. It is going and crawling, seeing whatever is there. And basis that, it creates a data catalog. And another interesting thing about Glue is that it does not even just create a catalog. It allows you to give the scripts, which are pre-written code given to you in Scala and Python. So it's basically a drag and drop kind of thing where you say, okay, I want to do this rename, or I want to transform this data, or I want to do some operations on it. And it generates that for you automatically. And you can just run this code to get your final results either in Athena, EMR, S, or even Redshift. So that's how Glue Crawler works. So yeah, so for an example, you're working in US East 1A region and your AWS account is global. So what this means to say is a Glue is a regional service first. It's not a global service, but for that particular region, it provides you a centralized repository. And what we mean by a centralized repository is that all of your table, as I mentioned, it could be in Redshift, it could be in RDS, it could be in S3 as well. All you want to do is just keep the metadata. So for an example, you don't want to keep that data because your storage costs are too high. What you can do instead is, for whatever reasons, you just want to keep the metadata of it. So it allows you to keep that centralized repository. So just assume that you're using AWS ecosystem and you are using a lot of components like EMR, S3, Redshift, and various others. All of your data is spread across all these things. You just want to have a centralized place to see the metadata, what all tables I have. It provides you that. Even though your data is present in, metadata is present in Glue data catalog, but you still need to, if you want to query a table, you need to provide the input. In this case, it was S3, it could be something else as well.
Okay.
Okay, and in this next section, what we are going to do is we are going to talk about schema conversions, and we'll finally summarize it as well. So basically how it works is Glue allows you to convert semi-structured schema to relational schemas as well. And what I mean when I say that is, you, let's say, have a semi-structured data. And if you want to convert and save it into a, let's say, RDS, you can do so using Glue. And how it structures the data is something like this. So for an example, you have this A column, then you have B1 and B2, and then C, you have nested structure. You have C contains X and Y as well. And D is just an array. So how does it store is something like this. So A will be a column on its own. B1 and B2, it will separate them and create two columns. C, as it contains nested structure, it calls them C of X, C of Y. Two more rows will be created. And finally, for you will have the primary key and foreign key kind of values. So it allows you to convert your semi-structured schema to structured schema as well. What we did is we read about what is Glue. So it's a fully managed ETL service which allows you to categorize, clean, and enrich your data. Then we saw the various use cases of Glue. So you can query data which is present in S3. You can join your data and you can create a centralized data metadata catalog as well. And then in terms of components, we saw that it has data stores, source data store, whatever is your source, S3, GDBC connection or whatever. And then you have crawlers. Crawlers allows you to read the data and fetch the metadata of it. Then it gives you the option to save this, and that is called as data catalog. Then there are a few other things like jobs. You can create glue jobs as well, which we are going to talk about. And finally, you can have an output data store as well. For an example, your output could be S3 again. And glue data catalog, as I mentioned, it is a persistent metadata store, which acts as a centralized repository. So let's quickly do one demo on it to solidify our understanding. Diagram in the theory we discussed, the crawler goes, sees whatever is there in S3, and it creates this data catalog. And then you can run some jobs on top of it as well. Right now, we are not looking at the jobs part, but till here we are done, the data catalog portion. So for that, all you have to do is go to data catalog, go to database. This is my database, which I created for this glue demo DB. And as you can see, it has created a table called glue crawler demo bucket. And it is able to figure out whatever is there in my actual data, which is, you have seen this data already. It is a picture, name, date of birth, gender, registered, something, and a lot of other things as well. So it went there. It is able to figure this schema, and it allows you to give the partition as well. What is the partitions? What are the indexes? And some metadata about it. What is the format of it? What is the output format? And things like that. So this is your data catalog, and this is created using glue crawler. If you want, you can edit this schema as well. For an example, you do not want to call it picture anymore, or you want to add something to it, you can do it here as well. So here we'll see what are the glue jobs, what is the workflow overview, how it works, like we saw for the crawler, the theory of it, and finally, how do we create these jobs? So how do I like to think about this is basically a process of sewing. So what do? You take a fabric, you make some patterns, tools, and some sewing kit you have, whatever, you do some changes on top of this fabric, and then you get the final result. So this analogy I would like to use for glue jobs as well. So you start off with a fabric, which is analogous to your input data. Then you do your sewing, whatever sewing kit you have, pattern tools, whatever embroidery you want to make, you do that. That is equivalent of glue job. The things that you were mentioning, data, duplication, null values, and things like that, that is done in the glue job. And finally, you have the output data, which is the enriched data, which is your final result. So what is a glue job? It is just a job. That is the business logic. Whatever is your logic, you want to remove null values, you want to fill them with something, and create this ETL pipelines in the AWS glue. So let's see how it works. So far, we have created this data catalog, as you can see over here. Now we'll create a glue job. And glue job, as I was mentioning, it allows you to use Scala or Python to do all of these changes. And it generates some code for you as well, at least a boilerplate code. And then you can, if you want, you can run that code, whatever it has generated for you, or you can edit that code as well as per your requirement. And just like crawler, it can be on demand, it can be scheduled, or it can be an event-based trigger as well. And finally, you have the enriched data. Over here, we have this database already created, table already created for that. So basically, we have this data catalog. So we can start off with the next portion, which is my actual ETL jobs. So what do we do? As you can see, they give you a lot of options. If you want, you can write your code in a Ray script editor, which is a very fun thing to do with some boilerplate code or an existing script that you might have. You can write your code in Scratch or just upload an existing Jupyter notebook. You can have a visual blank canvas as well. It's a basically interactive place where you can do some drag and drop and things like that. Or you can have a Spark script editor, or you can have a visual with a source and target, or finally a Python script as well. So for now, my source would be S3 and my target would be S3 as well. Then, as you can see, whatever you are doing here, it creates a script of it. It already gives you this code to run. If you want, you can download the script, edit the script. Or if you want to add some things, not this, where is it? Actually, they keep on changing things. They used to, actually, I'll try the old UI. I've used the old UI. Yeah, this one. Actions. So as you can see, they allows you to do all of these things by default. So for an example, what it can do, it can change schema, it can do some joins, it can do a SQL query to transform data, it can detect sensitive data, like if you have some credit card information or things like that. It can evaluate data quality as well. It can fill in the missing values. So let's say we choose this. Fill missing values. And let's say I have missing values in this name.first data field with missing values. And if you want to change it to something else, you can do that. Or there are a lot of things as well. Like for an example, I want to drop null fields. I have that as well.
Can you call another job inside this?
Yeah, definitely. Anyway, the whole thing is it can do a lot of other things like this by default. And once you select all of these things, it can do is run generate this script. So over here, you want to call it whatever you want. I'll call it Harsh demo run. I'll choose the same role that we created earlier, the master role. You can choose the type of this ETL job. So this is my Spark job. You can select the language. It is either Python or Scala. I'm going to stick with Python. Then you have the option of choosing the worker type as well, how many workers you want, whether you want to generate insights and things like that, and few other advanced properties as well, but we'll not look into that. And just click on save. Oh, sorry, I have to do one more thing, which is, okay, so that's pretty much it. You click on run, your job has been started. You can see the job details as well here. It will run, it will say whatever is the transformed output to wherever is your output location. Here I have selected as over here. Now we are going to discuss what are the few output file formats it supports. So it can give you output file formats in JSON, CSV, ORC, Parquet, Avro, and even compress those as well into gzip and bzip. Now the workers you asked, this is the explanation about workers. So by default, these are the three ways you can run your job. You can run your Apache Spark job, you can run a Spark streaming job, or you can run a Python shell script as well. And these are the minimum DPUs or maximum DPUs you can have for that job. And when I say DPUs, it's basically data processing units, or in simpler words, workers. And this is some pricing details about the workers, how much running one per DPU cost you. It is the most common region dependent, but most common is 0.44. In some regions, it can be higher than this as well. So now coming to worker, and it's one of the most important thing. So let's consider this example that you are running a glue job, which is using Apache Spark. By default, as you saw in my demo as well, it was using 10 DPUs. And for one DPU, we are charged 0.44 per DPU per hour. Let's say you run that job. My job is pretty simple, so it will run for a few minutes and it will give me the results. But let's say your job is running for 30 minutes. In that case, how much you are charged for? Half an hour. How much would be your pricing? Half into 0.44. So basically 0.22 per DPU. And now you're using 10 DPUs. So what is the cost? $2.20 per job. Now, so let's say we want to run this job with some more DPUs. So let's say if you wanted to run this job, rerun this job with more DPUs,
we could just select the job parameters and just increase the number of DPUs. And for an example, let's say 25. The default is 10. So let's go ahead and do the calculation for this as well. So as you can see, if you are using more DPUs, your job, which was running for 30 minutes, it got finished in just 10 minutes. And your charge 0.073 per DPU, which means this one, even though you're using more DPUs, you are paying less, and your job, it is getting finished instead of in half an hour, it is getting finished much more faster. The job runs basically faster, and it is essentially just throwing more compute power out at your glue job. Now, depending on the job type you selected, you can select the specific amount of DPUs or a particular amount of DPU, and the default and minimum things I have shown you already. And what do you think will happen if I'm running it for more DPUs? So the answer is maybe. That is the correct answer. Usually I don't like that answer, but in this situation, maybe is the correct option, because this is more of a hit and run, and it comes with your experience running your Spark jobs. So over here, we were running with 10 DPUs. We were charged $2.2 for this particular job. We gave it more compute. We said, okay, instead of just working with 10, work with 25 DPUs, and it ended up costing us 1.82 cents per job. So it looks like that already a second run with 25 DPUs is going to be a cheaper option, and it actually runs faster. So let's take a look at the third run as well. And we are still running an Apache Spark job type. We'll use 75 DPUs. So the triple amount of DPUs from the second run. And it is going to cost us the same per DPU hour, right? So this particular job takes 6 minutes to run. But the thing is that over here, 6 minutes, that is going to cost you, you're using for this much you are charging per DPU. And for this job, when you are sending it more DPUs, it is costing you $3.30 per job. So here you have to figure out what is important to you, whether you want to finish this job in 6 minutes for $3.30, or you want to finish it in 10 minutes, which is good enough, and pay this much. Okay, awesome. So obviously it is clear that our second run is the best, which is 1.82 per job. It is giving us results in 10 minutes, and it is kind of cheap as well. Apart from this, you can have CloudWatch metrics to determine if your DPUs are under provisioned or over provisioned, and using those, you can make decisions like whether you are choosing whatever number of DPUs, are those correct or not. So it's not completely hit and run. You can have this monitoring enabled, and using those monitoring, you can make decisions like how many DPUs are perfect. So few things about glue jobs, few good things about glue jobs. First one is that glue jobs run in isolation. As you can see, this is a very nice place, nice cottage. Though it is horror, all the horror movies are based on this kind of cottages. But as you can see, this is very isolated. The same way your glue jobs run on virtual resources. All the resources needed to run ETL jobs, they are provisioned and managed in its own isolated service account. So it is much more secure. It is isolated. Now, what a glue job needs? It needs input data sources, you saw, output data source targets in your VPC. And in addition, you provide IAM role, VPC ID, subnet ID, and security group. And that will make sure only right people have access to this job. Now, your traffic, it is governed by your VPC, whatever rules you're setting, whatever networking policies you're setting in your VPC, that is going to determine if Glue is able to fetch data from, let's say, your on-premise cluster or not. Okay, all of these things, they can be audited using CloudTrail as well. So this brings us to the end of Glue jobs as well. Here, we discussed that Glue jobs are nothing but just a business logic that performs ETL works in AWS Glue. Now, workflow overview, you saw you have various options. If you are familiar with Spark, or you are familiar with your PySpark or Scala, in that case, you can just run your code if you want directly in the console. If you want, you can upload your script. You have various other options as well. And it gives you that very cool features that it has this already machine learning enabled in it. So you don't have to create that flow that, okay, whether my data contains personal sensitive data or not, it can detect those things for you. And various other transformation, by default, the most common transformation, it gives you as a drag and drop and generates the script for you as well.
Then we saw the output data format and what is the use of DPU. DPU is nothing but what is actually running this jobs, what we are running. And then we saw that all your glue jobs are isolated. The next thing is glue job bookmarks. Over here, it is pretty simple concept, but it comes in your examination questions and even in your answers as well. So let's say you have this many files present in your S3. You ran a glue job and you are doing all these things, drop irrelevant fields, changing column names, compress outputs, and things like that. Now, let's say you added few more files and you just want to run this job. The question is whether it is going to work on all these files or not. So the answer is no. It is just going to capture. Okay, I have already worked and processed all these files. It will have that CDC thing. It will capture the change and it will just work on the remaining jobs if your job bookmarks are enabled. So that's pretty much it. It's a pretty simple concept. It's just a way to process new data without reprocessing old data to save you some money, and do not rerun jobs on a previously ran data as well. So there are a few options. You can enable it, disable it, pause it. If you want to make sense of the data, what you have, you will make sure that your data is little organized. Otherwise, you will not be able to understand what all it is giving you. And usually that is the case. We do not do all of these things manually. You have all this S3 folder, data lake folder created by some sort of transformation, some ETL job, some place, whatever raw data, somebody at least made sure that they are putting data there. And usually it is organized. Okay. So what is Athena? It just allows you to query your data, which is present in S3, and then run standard SQL queries on top of it. We just saw the demo, so I'm just not going to do this. But another thing is Amazon federated queries. So you can not just query data which is present in S3. It's a beta feature, but it can just come up in your certification. You do not have to worry about it much, but as it can come, I have covered it. So not just S3, they enabled all these other options as well. PostgreSQL, HBase, DynamoDB, Redshift, SQL. You can run queries on that as well. Just remember that it allows us to, it will give those options as a beta right now. Then output format, what it can do, it can allow you to CSV, TSV, JSON, text files, Parquet, ORC, as well as some compressed files, so that you don't have to waste money on saving the data in a particular format. You can run it on compressed files as well. Then you can run it on QuickSight as well. If you wanna, whatever queries you are running, you wanna create some charts and bar graphs or whatever of it, you can directly integrate Athena with QuickSight as well. Now, there are some more integration. These are the other integrations: CloudTrail, CloudFront, Elastic Load Balancing, VPC flow logs, CloudFormation, IAM, System Manager Inventory. You can run ad hoc queries on this as well. So how it works, we have seen that this could be one use case. You have data present in any of this location. You run the crawler, you create a glue data catalog. You can run glue ETL jobs on top of it. And on this data catalog that you have, you can run Athena queries as well. You can run Redshift Spectrum on this as well, or you can use this catalog to create run all this on EMR as well. Again, depends on your choice and your use case. And finally, you can visualize all of these things using any of the BI tools. So that's pretty much it. So we have covered Athena, we have covered Glue, and we have seen the demo of both as well. So yeah, good progress so far. Now, this is important. This I told you now, some people had questioned, when should I use Redshift Spectrum versus when should I use Athena? So I thought of putting it all together just to clarify things. So can you please read this? All of this are pretty similar, but they have some their own use cases, and that's what we are going to discuss here. So please read the use cases or overview of Redshift. So what can you see the difference? Here, this is for running complex SQL queries, join subqueries and all those things. And EMR, it is specific whenever you have some custom application where it requires your own logic, not just SQL queries. In that case, you will use EMR. And obviously another thing is whenever you have a requirement to use Hadoop ecosystem or Spark or Presto, Hive, something like that, definitely EMR is the best option there. And finally, you have the option of defining all this compute, memory, and storage to optimize some workload, like you saw in the glue DPU portion as well. If you gave it more resources, it was actually able to save you money, and it was able to save the time as well. So that you can plan in EMR. But in Redshift, there is a leader node, there is a query planner. You just select a lead, cluster size, and it takes care of all that. You do not have that autonomy there, which is there in EMR. And finally, run the Athena as well. So as you can see, it can be used with those things, Redshift and EMR, but it is not replacement of that. It is only for ad hoc queries. It's not for very sophisticated queries, or it is not for very complex reports, which Redshift can do better. This can do as well to some extent, and a good amount of extent as well. But Redshift is much more mature over here. Now, EMR, we have seen EMR and Athena are way too different in terms of their ecosystem altogether. So another few things, we have done the demo of this as well. S3 Select was our first demo. Glacier Select is another thing. So both of them, what they do, they also query. But what they do is they use SQL statements to filter the content of your S3 objects and retrieve just the subset of data that you need. So for an example, the demo that we did was, you have the user data in S3, and instead of reading the entire S3 file, which will cost you some extra money, what it was doing, S3 Select, it was specific parts of files only. So you read it only for the, where age was greater than 40. So you just read that portion of data. You do not read the entire file. So it is not for this ad hoc querying and all. It's just to filter out your S3 data, basically get the subset of data. Same thing, Glacier you can do as well, but instead of saving it to a frequently accessible tier, even with Glacier, your data is saved. You can retrieve it using Glacier Select.
Let's have a quick quiz question, guys. And the question is, which of the following best describes a data breach? Option A, a situation where data is intentionally shared with the public. Option B, unauthorized access or exposure of sensitive data to an untrusted party. Option C, the loss of data due to natural disasters. And option D, routine data transfer within an organization. Please do mention your answers in the comment section below. Just a quick info, guys. Intellipaat offers an AWS Big Data certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.
Yep. So here, whenever let's compare Athena to others. So in Redshift, you need to pull data from different sources. You have to build sophisticated business reports with complex queries. Athena, when do you use? When your data is saved in S3. You can run quick queries for troubleshooting and some analytics on it. EMR, it just goes far beyond running queries. EMR can do a lot more as well. You can use custom code to process and analyze massive amounts of data. You can manage your EMR cluster as well. But in case of Athena, it's again just for large-scale data processing solution. It is more of an ad hoc tool rather than a sophisticated tool like Redshift or a custom tool like EMR. It's basically serverless, so there is no need of managing the cluster for you. And finally, the S3 Select and Glacier Select. Here, it is just to filter the data and do not filter the data in application. So basically, it does not get 100 records and then whatever is your logic, give me 5 records which are age more than 40. It does not do that. It filters those records directly in S3 so that you're not paying for getting those 100 records. You're paying for just 5 records. So it helps you that way. So that brings us to the end of this section as well, when to use Athena. And finally, this brings us to QuickSight visualization and dashboards. Random facts about a few things. We can just start it with the QuickSight itself. So QuickSight, basically you have been hearing it from me since start. It is just a tool like Tableau and QuickView and other tools, BI tools, which is created by AWS. So it allows you to create this awesome visualizations and dashboard with your data, just like all those other enterprise tool does. How it works, you can connect your data from various places, files, application, AWS data, wherever it is. And relational data, I'm not going to read it, but it can take relational data from all of these places. And you can import files which are of this formats. And you can use even some software as a service softwares as well, like Jira, ServiceNow, Adobe Analytics, GitHub, Salesforce, and even you can do analytics on top of your tweets as well. So how it works, it uses something called as SPICE, which stands for Super Fast Parallel In-Memory Calculation Engine. So a few things about it. So basically what it does, it allows you to run your queries faster. So this is an additional thing that AWS has incorporated, which is different from other tools like Tableau, which is usage of the SPICE. It makes your queries much more faster. You do not have to wait for a direct query to process. Your data, which is stored in SPICE, basically can be used multiple times without incurring additional costs. So whatever you bring into SPICE, it basically acts as a cache. That data remains there in your SPICE memory. And as it is in SPICE memory, it is quick, very fast as well. And also the data that you have brought into SPICE, even if you are running 10,000 times the same data, you will be charged only once for the one time you put some data into SPICE. So that's some few things about it. Then the SPICE capacity, there is a certain capacity that you get, which is allocated separately for each AWS region. Now, how do you work? You can either use SPICE, you can put your data into SPICE and then run visualization, examine your data, create dashboards, or you can run direct queries as well. Now, you just need to know for this certification, what are the various visualization types it supports. And it is pretty basic. If you have worked with any BI tools, you will find it pretty similar to that. So you can have bar charts like this, or you can have combo charts, which is just this bar chart with a line chart there. Then you can have a donut chart, or you can have a gate chart like this. And you can even have geospatial charts, which takes your data, which is related to maps. Now you have heat maps. Apart from that, you have histograms. You have this KPIs. You can put put it into dashboards, and you have line charts as well as pie charts and some scatter plots, and finally the tree maps as well. And even this infamous word clouds as well. So you might have seen this. This was pretty popular a few years ago. Now, few notes about QuickSight dashboard. So you have to specify user access, which means all the things that AWS allows you to do in a lot of places, which is in terms of security. It does that over here as well. So when you share a dashboard, you specify which user have access to it. So whether you're C-level executives or whether your particular team, few members, things like that, all of those things can be taken care by QuickSight. Now you can have dashboard viewers versus owner. So viewers obviously will have limited functionality life. They can view the data, they can filter the data, they can sort the data. However, owners can only edit and share the dashboard and few other analysis options. And you can directly embed this into your website or application as well, the interactive charts and bar graphs. So that is it. That's all you need to know about QuickSight, how it works by usage of SPICE, how you can load your data, where you can load your data from, what are the various visualization type it offers, and what all you can do with QuickSight dashboard. Now, coming to the security aspect, we are going to learn about how it encrypts the data, how it connects to AWS resources, how it uses IAM, and certain best practices for security with a final summary of it. So by default, the data is encrypted at rest, but that is for enterprise edition only. You have to, just like how you subscribe or buy all this Tableau subscription, you have to buy the QuickSight subscription as well. There is a free version as well, but certain things are not supported. As you can see, this encryption at rest, it is supported only by enterprise edition. Now, encryption in transit. So by default, AWS uses it everywhere as well. It uses it in QuickSight as well. It uses this SSL
certificates to encrypt your data in transit. So all your data coming in and out of Spice basically is encrypted during that time as well. Now, the entire key management, it is taken care by AWS itself. However, database server certificates, they are the responsibility of the customer. Now, connecting to it, that's all you need. You can connect to Redshift, RDS, Aurora, some databases you have on EC2. All you have to do is provide username, password, port, public-private resources, security groups, VPC. It could be internet gateways, NAT gateways with proper permissions, and finally NACLs as well. Also, if your data, whatever you have in S3, you can give access to QuickSight by using the same things that S3 offers, which is IAM role access, bucket policies, and things like that. And finally, it allows you to do connect to your AWS resources in two ways. First one is manual connect. So here you have to select the permissions on your system tables to allow QuickSight to discover table schemas and estimate the table size. Then finally, the second one is obviously the automatic discovery. And here, the only catch is that all of your resources, it should be in the same region as QuickSight account. So even if your Redshift is in US East 1A, your QuickSight should be in the same region as well. So I'm not going to talk about any of it, but how do you connect? I have already given you the documentation, the links that I've shared in the study guide. It gives you the website for user access, where exactly they can access depending on the region on all these locations. It is there in their documentation. It gives you this endpoint as well. You can see that documentation for yourself. Now, connecting to it by default, everything that is out that is coming to QuickSight by default, everything is blocked. You do not have access to it. How can you make sure that you have access to it? You need to set all these rules, which is custom TCP rule. You have to provide this port range, whatever is the port range for QuickSight, and then you have to provide this IP address. Where to get this IP address from? Here. That's why this documentation is important. Without this, you will not be able to make connection with QuickSight because by default, it does not allow any traffic. So make sure you do that. Once that is done, you have a successful connection enabled, and that's how you can use the QuickSight from any of these resources. Now, Amazon QuickSight, in order to connect to a private VPC resource, your security group, it should contain an inbound rule authorizing this access from appropriate IP address for this range of QuickSight servers in that particular AWS region. That's what we saw in the last one. Now, how does IAM work? So you can have QuickSight for particular only user accounts. You can define their email address and things like that. And you can define all of those accesses using IAM credentials. So it has good connection with IAM. It has with AWS Directory Service. For an example, your office might be using Active Directory, which contains all the things that you guys are part of, which team you're part of, which project you're part of, what is your email address, what is your internal ID, and things like that. It has that connection as well using this Active Directory connector. And you do not have to even use IAM if you have this. You can directly use that Active Directory that you already have. Or even you can use an SSO connection, which is, I think every company has. If basically what it is this. So for an example, I log into something, everything at my office resources, it basically connects using my office email and password, all of the things. So that is an SSO connection. In Mac, you have that option of fingerprint. You can enable all those things. Same thing, security things can be taken in QuickSight as well. Now, as you can see, all these red things, they are supported only in Enterprise Edition, not the free version. Okay, so certain best practices for QuickSight, for securing your QuickSight is you can allow access to HTTP and WebSocket protocol using this, and this allows QuickSight to reach to a database which is not in AWS. So even if you're on-premise database, you want to use QuickSight, you can do so. All you have to do is change the non-AWS server's firewall configuration in order to accept traffic from the appropriate QuickSight IP range. The same thing, the documentation page with the IP addresses I showed you, you have to make sure that it is able to connect to that. You can provide appropriate accesses there. Now, SSL, as I mentioned, it uses SSL to connect to your databases. So by default, it is all your data is encrypted during transit, and QuickSight requires the use of publicly recognized certificate authorities for it. Now, for even enhanced security, you can encrypt data stored at rest in Spice. You can have this SSO and Active Directory connection. You can securely access data in private VPC and on-premises, and you can limit data access to low-level security, which means by default, you should not give anybody any access. Somebody comes, ask you for that, give only that access. Basically, the principle of least privilege LPP. Now, you can use VPC for a data that is stored in AWS resources. All you have to do is utilize Direct Connect to create a secure, private, and a connection for your on-premise resources with your VPC and QuickSight. So as you can see, QuickSight, definitely if you're in AWS ecosystem, it's a good place to, good tool, BI tool to use, but you can use it even if you are using your own on-premise or other things as well. So AWS wants an adoption. That's why they have all these features and best practices, even for securing those things as well. So let's quickly see what we saw here in this section. We firstly saw that data encryption at rest and in transit, both are there. REST is there in Enterprise Edition only, and all your keys are managed by AWS itself. Now, connecting to AWS resources, I told you what is required, the documentation that contains that link that is needed to connect to AWS resources. Once that is there, TCP rule is there, it is able to make connection, and then you can just do whatever QuickSight offers. Finally, you can use identity and access management as well. Whatever IAM functionalities you are seeing or you have seen so far, all of them can be configured along with QuickSight as well. And we discussed some of the best practices that you can use to secure your QuickSight even more. So that brings us to another section's end. And let's quickly go through some of the FAQs. So how do I import my data, which is existing in Apache Hive Metastore, to Glue Data Catalog? So remember, even if your data is in Apache Hive Metastore, you can directly use that. You can run a simple ETL job, which will read your current Apache Hive store, and it will export the data to S3. And once the data is in S3, you can just import that data into a Glue Data Catalog. So just remember, you have this option of using the existing Apache Hive Metastore with Glue Data Catalog as well. The second one is, how does AWS Glue relate to AWS Lake Formation? I showed you in the demo as well that you have the option of lake formation. Explaining lake formation is out of scope. If you want, you can give it a little bit read about it. So basically, Glue has ETL code creation, job monitoring, a central data catalog, and a serverless architecture. What does lake formation allows it to do is it encompasses all the AWS Glue features, and it provides you certain additional capabilities which allows you to build, secure, and manage a data lake. Whatever you have, S3 or something else, lake formation allows you to make it much more secure and even create a data lake. Now, how do I use custom libraries with ETL scripts in AWS Glue? Obviously, that option is there. You have jar files, you have custom Python libraries. You can just import those into your Glue jobs, and you can use those as well. So you're not restricted to only what AWS provides. Now, Python extension modules and libraries, they will be written only in pure Python. Just remember that. Now, how do I build end-to-end ETL workflow using multiple jobs in AWS Glue? How you can do that? We have kind of already seen that in a demo for a smaller data set, but that can be extended for a bigger data set as well. So what you can do, you can use AWS Glue jobs, which can be triggered on schedule or on certain event-based as well. Now, multiple jobs can be triggered in parallel as well, or sequentially, whatever you want. You want one after them or all of them to run together. You can choose that. And you can use Lambda functions to trigger your Glue jobs as well. For an example, something comes to your S3 bucket, you can have a Lambda function in between, whose job is to just see something came to S3, run Glue job. That's all. So
These are some FAQs, but again, in the study guide that I have given you, all of these FAQs are present. If this is just few ones which I feel important are mentioned here. Now, how will I be charged for the using AWS Glue and its services? So you should know that there is a monthly fee for storing and accessing the Glue data catalog. There is an hourly rate. This we discussed already, that you are billed for whatever crawling you are doing for hourly rate. There is an hourly rate basis that you are charged. Then there is an hourly rate for developer endpoints as well. So basically, AWS Glue gives you this option of running this Glue jobs using this developer endpoints as well. And finally, we saw the jobs which has DPU. All those DPU has their own hourly rate as well. So just remember, you do not have to remember the number, how much 1 minute, 10 minute, how much they are charging you. You just have to remember that there is a monthly fee for catalog. There is a hourly fee for crawler. There is an hourly fee for jobs. And if you're using developer endpoints, there is a fee for that as well. And this section is pretty important, Glue, Athena, mostly, and EMR as well. So please focus and pay attention on that a little more when you're preparing more for your certification. Now, does Athena support data partitioning? We already saw that you can use partitioning of your data, and you can restrict the amount of data scanned by each query as well, just to give you, let's say, partition for year 1994. It will not read the entire data. It will read only 1994 partition, and it will save you money. That option is there. You can partition your data on any key with a common practice to partition data based on time. By default, it does that, but you can use it on any key. And we saw that in the demo as well. You can define what should be your partition key. Now, you can have a multi-level partitioning as well. For an example, we had year, month, day, and hour in our demo. Something like that you can do as well. And then you can just use this partition by clause in your create table statement to do that. But as you saw, even that is not required. They have that created a flow where you don't have to write queries. You just select things and they write queries for you. Now, does Athena support other BI tools and SQL clients? So the answer is yes. It comes with an JDBC and ODBC connection. So even if you want to use Athena with Tableau or something else, you can use that. And how much do I have to pay for Athena? That's a good thing, that your price per query and for the amount of data which this query is scanning. All these things like compressing, partitioning, or using columnar format, it allows you to pay less anyway because you're scanning less data here. And some FAQs about QuickSight. So how do I access my data in AWS resources? So we saw that AWS has very good connection or integration with a lot of AWS services in your account. You have the option of providing all the relevant permissions using IAM roles. Even if your resources are in other AWS account, not your account, you can access that data in QuickSight. You can have the data in the same region or in the same region, not a problem. And if you are using the auto discovery feature, all you have to remember that everything Redshift or whatever, wherever your data is and QuickSight, they should be in the same region. Now, how do I connect my VPC to QuickSight? So VPC has public connectivity. We saw that you have to provide that IP address and that will enable the traffic to flow. Otherwise, you can use a VPC connection in QuickSight as well. And finally, you can use things like Direct Connect, VPN, proxy, all those things that require you to make connection to your on-premise or your personal VPC to QuickSight. You to interpret your data, make more sense of your data, do a little bit analysis on it as well. And especially it helps you with the discovery portion of the steps for success. Now, Elasticsearch, as I was mentioning yesterday, it is not something new that AWS has created. These are the three different services, or they are basically part of Elk Stash, as the industry calls it. These are three different services which are widely used in all the companies, and especially in all two of my companies, we used to use it a lot. So what is Elasticsearch, Logstash, and Kibana? That is out of scope of this particular certification, that you can read it on your own if you do not know it already.
But basically what they have done is they have created their own managed version of Amazon Elasticsearch service. It's just Elasticsearch. They are calling it Amazon Elasticsearch service in AWS. So just remember this Elk Stash, Kibana, Logstash, and Elasticsearch. So it's basically for searching. So for an example, you have this document one, which is welcome to the section of data analytics specialty course on Elasticsearch. Second one is congratulations for completing the Elasticsearch section. Now, when you're saving it in Elasticsearch, how it works is it saves it at all of these indexes. Welcome to the section of the data analytics certification, a specialty course on Elasticsearch. All these words, as you can see, are present here as well. Now, what is not present here? Congratulations and completing. So it just saves all these indexes in Elasticsearch. Now, whenever you're trying to retrieve something, what it does, it uses this index to call that data. So for an example, you have, let's say, created a website and you have implemented a search functionality that basically contains a lot of names, and you just want to filter names starting with Harsh. In that case, Harsh would be saved as one of the indexes. And what does Elasticsearch allows you to do is search with this index so that it can filter out the results. It can say, oh, Harsh, welcome is present here. So it will give you this document 1. Congratulations, if you're typing, it will give you this document 2. If you're typing DASCO1, it will give you document 1. Same goes for if you're searching with Elasticsearch, it will give you document 1 and document 2. So it's basically a search index, as simple as that. All you have to remember about it. There are a lot more facilities or the features that it offers, but I'll just introduce you to all these different services so you do not feel that you do not know them at all. So I hope that is clear. Elasticsearch. The second one is Logstash. It is a specific service or an enterprise edition of a service which is created just for logs. So all of the companies, all of the processes, everything emits log. This particular service, it allows you to ingest, process, and store that log data. That's all. That's all Logstash is. Again, they have obviously created some feature on how do you want to see those logs, what to do with those logs and things like that. But again, that is out of scope. You can read about it on your own. But that's what it is. It is a service that ingests, process, and stores log data. And so what are we looking at here? Last thing is web utility interface for Elasticsearch and visualization engine. So we saw that we have Elasticsearch. It just saves this index data. What is Kibana then? The last thing in Elk Stash, ELK. So Kibana is just a web utility. It is a place for Elasticsearch where it is basically a UI for Elasticsearch where you can filter and see things. What is the interface looks like? It gives you this URL. This URL is basically you can write REST APIs on top of it. You can write get, put, post, delete, request that, okay, from this particular URL, give me anything which is item ID, which is this type, things like that. So that is Elasticsearch in a nutshell. You can load data to Elasticsearch from a lot of places. It could be S3, DynamoDB, CloudWatch. It could be your Kinesis data streams. It could be a DynamoDB stream. Whatever data you have, you take it and you put it into this Elasticsearch domain so that you can have a link like this on top of which you can create this REST APIs. So what is an example? This is something that I created earlier. So for an example, I scraped Reddit. In Reddit, whatever starts with AWS in the AWS channel, AWS thread, my Lambda has the code to scrap that code. I put it into my DynamoDB table, and then finally I put it into Lambda DynamoDB stream processor, which streams this DynamoDB table data to my Elasticsearch domain. So what I get is I get this all of my data which is coming into this Reddit channel into my Elasticsearch domain so that I can filter data which is of my use. Now, service integration, it has good integration with Data Firehose, CloudWatch, and a lot of IoT devices as well. So that's pretty much it about Elasticsearch. How do we use it? So because it is just JSON, it is pretty simple to kind of get data from it. It has all this REST APIs. You can write all this HTTP codes on top of it, get, put, post, delete, and it gives you the data, deletes the data, update that data, and things like that. And it can ingest data from anything that can generate JSON. Basically, we saw whatever services are those. And demonstration pipeline, I gave you that example of a Reddit. And finally, service integration, it integrates with all the services. Basically, anything that emits JSON, it can actually work with that. So visualizing, how do we visualize it? So that comes with this Kibana portion, which I was showing you of my office as well. It is part of the Elk stash. It is by default pre-installed on your Elasticsearch domain. It does not require writing any extra code. And there is a library called D3GS that is also there. You can visualize this logs using this library as well. It can visualize any JSON formatted data. It has a lot of third-party connectors. This is not related to Elasticsearch, but Elasticsearch has an extension for it. Now, what can we visualize? You can visualize your document statistics. You can visualize numerical data. So this is how you visualize data in the Kibana portion of the Elk stash. And that is pretty much all you need to know about Elasticsearch. So Elasticsearch, it is just a service which combines Elk stash. It gives you this domain endpoint, which you can run REST queries on top of, and what integration it has. And basically it is all JSON. So anything related to JSON, you can store here, you can visualize that as well. Certain FAQs about it. So how can you secure an Elasticsearch domain? So all the API accesses that you have, they can be controlled via IAM, like who can make a put call, who can make a create, delete call, and things like that. So it is much secure because IAM, you guys are aware, it is pretty secure. Now, security groups and ACL, you can use those as well to make sure what traffic you want to allow. Now, Elasticsearch, it also provides fine-grained IAM integration as well for everything related to IAM. Now, how do I back up my Elasticsearch domain? So just like every other service, it also supports snapshots. Okay, this can be automatic or it can be manual. And you can use these snapshots to migrate Elasticsearch domain between regions and accounts. Now, do Elasticsearch domains comes with Logstash? So Logstash by default is not included in Elasticsearch service domains. Elasticsearch domains, they are compatible backend for Logstash implementation, but by default, it has just Elasticsearch and Kibana. So you do not actually have Logstash, but it has good integration or implementation that you can use. Now, a final question for you. Not final, last second question for you. So please read, give me your answer, and we'll continue. One of you, can you please read this so that I know once reading portion is done? It's not heavily focused on the certification and it's just part of it. And there is nothing much to learn here as well. It's just a service which uses already created service and they have just created a wrapper on top of it. So nothing much to learn here, but still, if time permits, I'll show you this. Basically, I've created this website in S3, which obviously uses JavaScript. It connects to API gateway. That's how it reaches AWS, my account. Then there is one Lambda function I have written, which make a request to Elasticsearch and filter out whatever I am typing here. So basically, it's your own mini version of Google. So for something of your own, so for an example, I created this for one of my other class. I created a website which was showing that, okay, my laptop is literally a clutter. I have too much certification data for machine learning specialty, for solutions architect, for DevOps. So a lot of things are there and it is cluttered all over my laptop and I'm pretty lazy to kind of organize it. And I just had the entire, I just created a code which scraped through my entire laptop data. It figured out whatever is kept. And it used to, I can just search it in my phone itself that, okay, this file, this certification file, where exactly it is present. it used to give me all that entire data path and things like that. That was again just for a demonstration, but that shows the usage of Elasticsearch, which is Identity and Access Management, or IAM. Then we are going to talk about some VPC security features. What is KMS? What does it do? Secrets Manager. Most of the things I have been talking about here and there, so you might know. But again, it's a specific section of its own. Let's quickly see that here as well. So Identity and Access Management, it allows us to control access to AWS APIs, who can access what and things like that. It has service authentication integration as well, and it allows external identity federation as well. For an example, the same example, if you have your own Active Directory, IAM integrates with that as well. Then certain VPC security features. This is what we are going to talk about. So VPC security features, you have NACL layers, network layer, where you can define rules, who can access data, where data can go and things like that. And finally, routing and logging, where exactly this request should be routed, where exactly it should be logged. CloudTrail helps you to do that. Finally, KMS. You guys tell me, what is KMS? We have been talking about it. It is the whole and sole service which is used for encrypting your data at rest when it is in S3 or any other AWS services. It is a basically key management service. So in order to encrypt your data, you need a super secret key. That super secret key is stored and managed by KMS. So whenever, let's say, you want to download something or see something in S3, what does it do? The data by default is encrypted. Nobody can come and see what exactly is the data. You do not see it with your eyes, but what is happening under the hood is it goes, reaches out to KMS, it asks for this key, use this key. If it has this key, then it gives you the data which is decrypted. That's why you see the data normally with your naked eyes. Otherwise, you will see some gibberish there. So that is KMS. It generates this encryption keys. It manages, securely stores this encryption keys. It logs an audited key usage as well, like who used it to encrypt what. Now, finally, Secrets Manager. Secrets Manager is just like a vault. You use your vault to save your password, API keys, and things like that. You can use Secrets Manager to automatically rotate the secrets. So for an example, in my demo of RDS and various other clusters that we created, I created a lot of username password. Remembering that is a pretty difficult job. Changing that, keeping it secure is even more difficult job. How we can do that? We can save it in Vault, Secrets Manager, and whenever we change the value in Secrets Manager, by default, it will be changed in all of our databases as well. So that makes our lives much more easier. And finally, you can manage access to secrets through IAM as well. That was an overview, but let's quickly see how IAM works. So IAM is just basic AWS. Basically, if you think about it, it's one big API. All the things that you do in AWS, it's all API. You reach out to S3, you ask it to move, copy, blah, blah, blah. You reach out to RDS, you ask it to create a cluster. You reach out to DynamoDB, you ask it to create a table. All of the things are happening nothing but via APIs. Now, IAM, what does it do? First, you reach out to this API. This API reaches out to permission. This API reaches out to IAM. IAM then checks whether whatever policy has been returned for it, whether you have permission or not, whether you have permission to access Lambda, to S3, to DynamoDB. It checks all that. If you have permission, it will allow you to use that. If not, it says no, and it says get lost. So what are the few things about IAM permission objects? So it is basically a document that dictates API accesses, who has access to what, that is your policy. What is the user? User is nothing but an individual person. It holds the information about that user, and it gives you that access key and secret access key, which is required to access AWS using CLI. Now, what is group? Group is nothing but a container for all these users. It combines and clubs and keep all those users together, so that you do not have to assign policies to single users. You can assign to the entire group as well. And finally, what is the role? So role is what we have been using. So if you saw me,
when I use Lambda, in the Lambda demo, what we did, we said Lambda has permission to talk to S3. My Lambda has permission to talk to, let's say EC2. You define all that in a role so that whenever you are using Lambda, by default, it will know that it can reach out to S3 and DynamoDB or whatever. So role is basically, it is assumed by your users or services. Now, what are the IAM secured services? Definitely, this is not a comprehensive list. These are some common services which uses IAM. Everything actually uses IAM in AWS. So basically, think of it like everything. Now, what is external identity federation? Can you guys please read this? Thank you. So in simpler words, external identity federation, what does this do? So we can give access to our services to an outside identity provider. So users in an Active Directory domain, we can federate IAM with something called as SAML 2.0 or OpenID Connect. And basically this lets us use any providers that are able to create trust relationship with this protocols access to our IAM authentication frameworks. So the example that I gave you, for example, I showed you my company uses this SSO. So that SSO is following this format which is mentioned here, which is SAML 2.0. So for some reason, let's say my company starts using AWS. In that case, I can just use my current accesses, current things, whatever I'm using IAM as well, because my company has already created something for authentication using SAML 2.0, and IAM supports that already. It supports federation through SAML 2.0 and OpenID Connect. So whatever is built on top of this, it will allow you to use that as your basically to create a trust relationship with this protocols, which allows you to access to our IAM authentication framework. Then also we have AWS single sign-on service, which works similarly to IAM, but it actually stands up as an identity provider. And that then can be federated with an external identity providers. So this can be actually be used as a primary source of our identity information that we are going to use to authenticate our various systems. So on-premise, our AWS account or any other AWS cloud provider that has federation capabilities, we can federate that with AWS single sign-on. It supports the Okta Azure, Active Directory and SAML 2.0 federation protocols. And as I said, we can use it as a single control panel to manage multiple AWS accounts, as well as anything else that we can federate with an identity provider that uses one of these protocols it supports. And that brings us to the end of this section as well. So just think of identity federation as whatever currently you're using in your company to authenticate yourself. Whenever you're using AWS, if you want to use the same thing in your company with AWS, you can do that. So for an example, you do not want people to log into AWS console using their ID and password. You just want to give them a link. They should open that link, and whatever is your company page that asks you for your company email ID and password, that will open the AWS account for them. So you can do that using this identity federation. I hope that makes sense. Okay, so in this particular section, we are going to be talking about key management service or KMS. First, we are going to do a quick overview of KMS. We are going to talk about KMS encryption flows, one of the workflows that we use to encrypt data with KMS. And then we are going to quickly summarize whatever we have talked about. So what problem does KMS solve? So we have a super valuable data, as you can see in this diagram, and we want to turn it into encrypted data. So like you might have seen the ad of WhatsApp giving you your data is encrypted. What basically that means is nobody can read your data. It does not mean you can't read your data, but nobody else who is trying to hack into your account or somewhere in between when you're sending a message and whoever it is going to, in between, nobody can read it because it is encrypted. So that's what KMS does as well. So you have this super valuable data and you want to turn it into encrypted data. Now, this one allows you to store and manage our encryption keys, and it can also be utilized to encrypt data. So if our keys expire or become invalid for whatever reason, we can use it to rotate those encryption keys. And doing this manually can be labor intensive because that is the entire part of why KMS exists. It is a service to facilitate these activities. KMS uses something called a customer master key, and it can either be generated within the KMS service itself, or if you want, you can supply your own master key that you want to use. So if you want to ensure we are in full control of our encryption material, they are really the key that makes everything work. And we'll talk about how that works in the flow here in the next diagram. So now we are going to talk about that in our encryption flows. How do we encrypt data with KMS? So KMS is going to have that customer master key, and we can actually send data to KMS and say, I need to encrypt this, and KMS will encrypt the data and it will send that data back. So that is pretty much how it will do. Now there is a flaw here. And if we're encrypting a lot of individual files, what will happen is the network latency between our client here and the KMS service, it is going to add up. And it doesn't seem like much, but the network latency from the request to sending the files back is going to add up as well. And it may only be tens of milliseconds, but if we're talking about thousands of files, that is going to add up really quickly. So this works well for infrequent encryption or situations where we don't necessarily have compute available to encrypt our data. But what if we don't want to have this network latency in the mix? Well, the other encryption flow we can use is called as envelope encryption. So you can use that envelope encryption. So this is what most of the services that are going to use KMS to encrypt data at rest when we do that encryption. So what happens is our client says, I need to encrypt this data. KMS, it is going to generate a key, which it then encrypts with our customer master key, and it stores in the service, and then it generates a table of what that data is encrypted with. So the token, not the actual data, what the key identifier is for the key that is generated, and the encryption key that is used to encrypt, decrypt that key from its storage, it that sends that generated key back, and we can combine that data with a super valuable data like here. So basically, instead of sending data to KMS, what you're doing is you're sending this key to your data so that you do not have that network bandwidth latency and things like that. So that is envelope encryption, and KMS by default automatically does all this. So you do not have to worry about it, but this is something you should understand at least. That is not there. What is the bottleneck? Was the first thing that I explained, that sending data to KMS would be expensive. But so that is not how it works. How it works is you generate that key and then you send that key to your data. Okay. So the fee is only for KMS. There's nothing, two things that we saw in KMS. The last thing that I'm going to be talking about is Secrets Manager, and it's a pretty simple service. We have seen that already. So let's talk about how secrets are stored. We'll talk about how secrets rotation, and then we'll summarize whatever we had talked about. So what does this service do? It just lets us store various text-based security tokens. We can control access to those tokens via IAM, and then we can encrypt those for an extra layer of security as well. So the best security approach is always a multi-layered security approach. So let's say you have a very valuable secrets, username, password of your production database. We are going to want to encrypt them at rest as well. Why would we do this? Well, using a secrets vault. Another example of a utility like that is something called as HashiCorp Vault, if you have used that. If not, just Google about it. So what it does, it allows you to let us keep all of our authentication material out of our code so that we don't hard code anything into our code. So instead, what we would write in a code is that we are committing to a code repository. It just calls the secrets manager to retrieve those secrets. So in that case, we no longer have to hard code those secrets to our code. So for an example, this is my password, strong password. Secrets rotation, it takes care of the rotation of it as well. Whenever I'm going to change it to, let's say, strong pass2, I'll change it here and it will change everywhere in all the services. So
That's pretty much it. The last thing, I think this is the last. So VPC network security features. Let's quickly get into it. So So VPC, it is just a network space that lives within a region. We define the top level of that network space with this CIDR range 10.0.0.0/16. We then have availability zone in that particular region. So availability zone A, availability zone B, as you can see here. Now we can create subnets 10.0.1.0/24, 10.0.0.2.0/24. These are two subnets I have. Now, each of this get a CIDR range of its own, which is a subnet of a primary VPC CIDR range. So subnet is 1.0 to 24, and then subnet 2 is 2.0/24. So those subnets within our VPC, they are interconnected. And if we have an internet gateway, they have a pathway out to the outside internet as well. So these are considered subnet edges. And in this diagram, we are just showing the subnet interconnect. We then launch a resources within this subnets, and all those resources, they are assigned a particular IP address as well within this CIDR range. Now, our first layer of network level security is called as NACL or network ACL. What is NACL? So, so they are attached at a subnet level. They are stateless. They are attached at the subnet edges. So anywhere that there is a connection outside of the subnet, the network access control list applies. We can create one network ACL that is attached to many subnets as well. Subnets can only have one ACL attached to them, but we can use the same ACL for multiple subnets. So the network ACLs use rules. They can be allow or deny, as you can see here. So what all it is going to contain? We specify a source destination. So if it is an incoming rule, it is going to have source. If it is an outgoing rule, it is going to have a destination. And then we specify those CIDR notation, and the rule is going to specify a port range as well. We can also specify which protocol the rule applies to, or we can make the rules for IPv4 and v6 traffic. And these rules, they are checked in order, whatever you are writing. So they have a number in them, and we'll see that in a second. And when they are checked, it just goes down the list, and as soon as there is a match, it stops checking, sends the traffic through, which makes them very efficient, but it can also make them very difficult to work with as well. So here's an example of very basic network ACL in this case. So we have an incoming traffic ACL, and we are allowing in the port 80 here. And all the other traffic, it is going to be denied. Also note that we are allowing IPv4 to port 80 traffic or the TCP protocol. Our next layer of security and security groups, they are attached at a resource network interface, and they will take care of the rest of the things. So that is one layer of security, which is NACL. Second is your security groups. We have seen security groups attached to EC2 instances and RDS instances and whatnot. Then for traffic monitoring, you have a lot of things like VPC flow logs. Whatever is coming in and out of your VPC, all the logs are created. Then you have traffic mirroring as well. So it mirrors your full packets. It will filter available things like TCP, dump, and things like that. But again, that is very high level. You do not have to go deep. Just understand and remember, for security, you have few things like this: NACL, security groups, and for traffic monitoring, you have VPC flow logs and few other things. What exactly is traffic mirroring? That you do not need to understand, but just understand to monitor the traffic, you can use VPC flow logs. So
just a quick info, guys. Intellipaat offers an AWS Big Data Certification course designed for the AWS Certified Data Analytics Specialty Exam DASC01. This course will assist you in acquiring an in-depth understanding of AWS big data concepts such as AWS IoT, Amazon DynamoDB, Amazon Machine Learning, data analysis, and data processing technologies. With this course, we have already assisted thousands of professionals in successfully passing the AWS Certified Data Analytics Specialty Exam. You can find their testimonials in our Achievers channel, the link to which is provided in the description below. Without a doubt, this course can propel your career to a new heights. To To take your first step towards career growth in the field of AWS, please visit the course page link provided in the description.